shows better performance. The absence of proper travel data collection system and extensive past data add to the difficulties of implementing this model for the routes. And so the SVR model performs better and gives superior results. So we are implementing a machine learning based hybrid model for arrival prediction for the transit routes. Coming to the holding model, the bus bunching occurs not only when a bus platoon is formed. So this phenomenon starts when the headway becomes unstable. So the headway between two consecutive buses is defined as unstable whenever we need to it is strictly necessary to apply a corrective action in order to recover the headway value to the acceptable levels. The bus system runs from Bagh Bazaar to Garhi and Garhi to Bagh Bazaar. And the service starts at 6 a.m. and ends at 10 p.m. It is a high-frequency transit service. The 16-hour service period have varying passenger demand characteristics, and the travel time in each segment is also vulnerable to changes from the expected values because of the traffic conditions. The real-time location monitoring system will check the arrival time of the buses at each stop against the target schedule. The objective of holding strategy is to stabilize the disrupted bus system with introduction of delays for all affected buses and bring the system back to the target schedule. This requires reduction of delay time in each subsequent buses following a thumb rule. And the holding process will be initiated whenever the delay goes beyond the threshold as detected by the monitoring system. The threshold of delay can be defined as 1/4 of the scheduled headway. The difference between the actual arrival time and expected arrival time based on the schedule can be defined as the delay for late arriving buses. And if the bus reaches a stop early than the bus before the that is before the scheduled time, the system will hold the buses till the scheduled departure. So our proposal focuses on introducing a sequence of delays in the preceding and succeeding buses of delayed bus at their immediately arriving bus stops to regularize the headway and recover the disrupted schedule. Buses yet to dispatch are also considered. However, the number of these yet to dispatch buses are limited by adopting a gradually reducing holding time in subsequent buses. So that is, if the bus at J is delayed for a period of D, we are holding the bus arriving at stops J-1, J-2, and J+1 and J+2, and so on. So holding time introduced are gradually decreasing. That is, the holding time at J+2 is less than that at stop J+1. So the sequence of delay developed from the holding model will be optimized using an optimization algorithm with an objective of minimizing the user cost. The total user cost constitute the cost incurred due to time spent waiting at the stop, then time spent during the in-vehicle traveling, and the passenger loss due to crowding. Therefore, the cost optimization can significantly improve the passenger cost, comfort, passenger comfort, convenience, and the sense of reliability on the bus transit services. So the holding values generated are tested against its effects on the full day schedule. The schedule would be updated with the new sets of headways, and the overall cost for the full day operation is calculated. The delay sequence with the least amount of effects on the overall cost is found out, and using the optimization process. The holding process is iterated till we get till the model generates a sequence of delay that has that won't change the fleet size and have a minimum overall cost. So the ridership of a public transit is directly related to the user experience, and user perception of the service is based on the scheduler headway adherence and the crowding level of the bus operation. Thus, providing a reliable service that adheres to the schedule is important for bus operators to increase the ridership. A regular bus operation system also offers a regular distribution of passengers in the bus that will help to control the overcrowding. The bus bunching is inevitable in our congested urban areas, and it will disrupt the system. To reduce the effects of these disruption, this research proposes a protocol for designing a dynamic bus dispatch and control system along an urban corridor in the Indian context. So the Our proposed model is a novel attempt to stabilize the disrupted system with the introduction of delays in both backward and forward direction using a hybrid strategy combining the schedule-based, headway-based, and optimization-based approach. Thank you.
Please, questions are welcome, and I'll request. It was quite technical topic, and from the side of some road safety officers and other students, I welcome the question to be put on to Gitanjali. You can unmute yourself, means I have given the right to unmute and ask the questions. इसके बाद break है. It was a really very good attempt by Gitanjali to put up to discuss about the intelligent transport system, in which how to operate the bus, centralized operating bus system, how to delay one bus and how to move ahead the other bus. It's a very good study done by you and a good presentation made by you. Any questions by the participant or the audience? Please focus some more light on this topic to get it more clear to us. Any technocrat type of participant? Gitanjali, thank you very much to you. I think you have covered it in a very nice manner, so no doubts are coming from anybody. It was really a very good attempt, very good presentation, and thank you very much for contributing in this conference and CAPT. Thank you, Gitanjali. Gitanjali, you are able to listen to me? You are here. Can you hear me? Gitanjali, can you hear me? Just a minute. Hold on, please.
Hello, sir.
Unmute.
Yeah, thank you, sir. Like I was not able to unmute myself, so thank you, sir.
Okay. Now I have. Now you can unmute yourself. That what is there.
Yeah.
Self.
Yes, sir. Thank you, sir.
Yes, Mr. Kalyan sir is trying to ask something. Please, Kalyan sir, go on.
Sir, hello. Yeah, now it got unmuted, sir.
Okay.
Only one thing I was to know and ask her to Madam that this bus congestion is a real havoc in the city in view of road safety. So with all this analysis and the system it is developed, then whether the congestion and the road safety issue can be tackled.
Hello, sorry, sir. Hello. Sir, can you repeat the question?
Madam, my question is, in the city, bus congestions are a regular phenomenon. Bus congestions due to bus rushing and congestion is being taken place. So in view of the road safety, how your system can be helpful for the to reduce the road accident?
So we are more focusing on how to provide a regular service than on the safety safety aspects of road actually. So that is all I can comment right now. So we are focusing on providing a regularized service and bus operations, mostly based on cost and all. So the safety aspect of is still not explored.
Okay, thank you.
Arvind sir, please, you can ask your question.
Good morning, everybody. Good morning, madam. Madam, it's a very nice paper you have presented, but it is, I think, based on complex mathematical modeling. So just I want to share, and I have an inquiry. How can this paper can be implemented on field based on practical aspects, so that each and every transport officer or the other police officer can very well implement your research paper on the field?
Yes, sir. So we are working on developing a Python models, and it's a data intensive part, and so we are working on the model right now.
Okay.
To implement it in site.
Yeah, because practical implementation is very essential in the field,
yeah.
so that you can reduce the dwelling time or the time of travel. Or
so we are working on the developing simulation models based on the the max that has shown. So right now the development model is like.
Thank you.
Okay, thank you, Gitanjali. Thank you very much.
Yes.
Thank you to the participant for offering the questions. And now, in the series of this presentation, we are going to get one paper presentation by Aluwala Gayatri of NIT Hamirpur. It is on the provision for speed bumps, a data-driven method. Gayatri, are you there on the screen?
Yes, sir.
Gayatri, please start sharing your presentation.
Yes, sir. Just a minute. Sir, is it visible? Sir,
Okay,
is it
Gayatri,
visible?
it is in slide mode, but let me give a brief intro of yours.
Yes, sir.
Gayatri Aluwala,
Yes,
Aluwala Gayatri, and she is pursuing master degree in transportation engineering at NIT Hamirpur. She is doing research work under Dr. Subhadi Biswas, Assistant Professor, Civil Engineering Department, NIT Hamirpur. Please, Gayatri, please go on with your presentation.
Thank you for giving this opportunity. Good morning, everyone. I was going to present on a topic on provision for speed bumps, a data-driven method. This study is done under the guidance of Dr. Subhati Biswas. This is the outline of my presentation. A question will arise that why we need a traffic calming at a critical zones like where we can expect the more pedestrian volumes, that is nearby schools or parking lots or near market areas. For here we can see this graph. If a pedestrian hit by a vehicle running at 30 km/h or less, there is a chance of surviving is more than 90%. If he will hit by the 45 km or more, then this probability of surviving will drops to 50%. And if this speed increased to 80 km/h, there is almost no chance of surviving of this pedestrian. to ensure the safety of the pedestrians, we needed traffic calming devices that will reduce the speed of the vehicles. And some of the most common techniques are adopted are posted speed limits and temporary barriers, lane channelization, and vertical shifts. These speed bumps comes under the vertical shifts category. These speed bumps are most commonly recommended by the local authorities because of their effectiveness in reducing the speed and the cost. They are very less cost. As I said earlier, these speed bumps are induced near critical locations like schools, marketplaces, and parking lots. Yes. These are the some previous researches regarding the present study. As a summary of these researches, they are telling that there is a definite correlation will exist between the height number and the speed reduction, and these research also having some gaps like that. They consider only individual impact of the height or number of speed bumps. The combined effect of these both two factors, that is height and number, on the speed reduction, they haven't considered. And these almost maximum of these previous studies conducted in the context of urban roads. It is a questionable that these studies conducted on urban context are applicable to the rural areas or not. As considering that aspect, the present study will be only applicable for the two-lane undivided roads of rural highways. And a primary objective of this study is to investigate the speed profiles of the vehicles at various locations of the speed bumps, explained in further slides. And by using those speed profiles, an empirical models are developed for the percentage reduction of the speed with correlation with number and height of the speed bumps. By using these empirical models, that individual charts are developed for different vehicle categories to achieve a predefined speed reduction goal. This is the research methodology for this study. And here we can see an animation video how the drivers will behave when they see the speed bumps. Here we can see that after seeing the speed bump, the driver will slow down the vehicle and obtain a minimum speed over the speed bump, and they'll increase the speed after crossing the speed bumps, and they'll go. And to conduct this study, we have some criteria for the site selection. First one will be the site. The site should feature the bituminous speed bumps, and the road segment should be straight without any gradient, and it should be free from horizontal curvature. The road segment should be free from side frictional activities like on-street parking. It may influence the naturalistic driving behaviors of the drivers, and the surface condition of the pavement should also be good without any distress. By adopting above criteria, 3 sites were selected in Himachal Pradesh. The details are tabulated here in this table. The first site is Anu, second will be Bota, and third one will be the Nandaul. These 3 sites will feature different configuration of the speed bumps. Number and height is varied for each site. And after selecting these sites, a videographic survey was conducted in the peak hour for 1 hour period in the weekdays. A high resolution video camera was mounted on a top of a tripod stand, and if this picture will show the how this is done. Here we can observe that a camera is mounted on top of a tripod stand. It will cover the both upstream and downstream side of the speed bumps, that is -9 meter before the speed bumps and +9 meter after the speed bump. And here we can see that this total study area was divided into 7 segments. Whenever the vehicle front bumper crosses the first reference line, the time has noted down as T1, and uh, after crossing the second reference line, the time has noted down as T2, as like this. the time is noted till T8. By using the formula of distance by time, that is d1 by t2 minus t1, we can get a speed for this segment. Likewise, we can get a speed of these total 7 segments till V7. After taking these videographs, these videographs are played in a computer screen, and by using with Kinovia software, a virtual grid lines were formed on the road section. Like here we can see the reference diagram. Like this reference diagram, we have drawn a grid lines on the camera, on the video, so that we can further analyze the results. These are the obtained traffic volume. We are tabulated here. By observing this traffic volume, we can say that the cars and bikes are occupying the traffic volume more than 85%. So that the present study will be further investigated only for cars and bikes. These are the average speed values at different upstream and downstream locations of the speed bump. As I said, how to take the speed, how to extract the speed. These are the values of average speed. With the help of these average speed values, we will further move to find out two major factors, that is influence of vehicle type and the bump configuration on the speed reduction. Here we got three different graphs for each side, and here we can observe for the first side, that is Anu, the difference between the speed reduction is more, and in second side the difference between speed reduction is moderate, and it almost disappeared in the third side, that is Nandaun. This is a combined graph of individual vehicle category. Here we can see that the side 3 has a more impact than side 2 than side 1. It is because of the bump configuration. We have seen that for the first side, the bump configuration is 3 in number and 30 mm. For the second side, it was increased to 6 in number and 40 mm. And third one will be the more 6 in number and 50 mm. So that as the bump height and number is increases, the reduction of speed also increased. That one here we can differentiate by conducting this by with the help of these graphs. We can further move to the percentage of speed reduction, how much percentage of speed was reduced due to these speed bumps. Here it is done by using this formula, that is v1 minus v4 by v1. Here we explained as v1 as initial average speed prior to arrival of the speed bumps minus average speed at the speed bump by initial speed at the before the arrival of speed bump. These are the values for different vehicle categories, that is cars and bikes, for the each side respectively are shown here. And but as we know that this percentage speed reduction value is a dependent variable on major two factors, that is number of the speed bumps and height of the speed bumps. As these two variables changes, the percentage speed reduction value is also changes. To establish the relationship between these three parameters, we have done a multiple regression analysis. The formula was obtained will be like PSR equals to A naught plus A1 NB plus A2 HB. Here A naught is taken as 0 intentionally, because in the absence of the speed bumps, the speed reduction value should be 0. It should not be any minus, so that we are taken A naught is intentionally 0. These two formulas were obtained from the multiple regression analysis. By using these two empirical models, charts are developed. These are the two charts are developed by using previous empirical models. The first one will be the for cars and second one will be the for bikes. Here we can observe that different colors were given, that will show here the range of percentage speed reduction values it will vary from 25% to more than 56% of speed reduction. Suppose if we want to induce a speed bump near a school gate, if we will experiencing a 60 kilometer per hour speed, but we want to reduce the speed by 35%. Here, by observing these two charts, we will get two possibilities. That one will be the first one will be for cars, 2 in number and 35 mm height, and in second probability is 35 for the 35% of speed reduction, 3 in number and 35 mm height. So that we will raise a question that which one we should use. As in this case, we are giving more priority to the safety of the pedestrian. So we have to satisfy all vehicle categories. They should reduce 35% the speed. So that if we adopt for the bike, that is 3 in number and 35 mm, the all vehicle categories will satisfy automatically. In this case, we are taking the 3 in number and 35 mm. Likewise, we can adopt any speed reduction value. For that, we are having different kind of possibilities for each and every case. This is the explanation of the previous slide, how we will use those charts. By conducting this study, we were observed that the speed reduction was varied because of the speed bumps is from 27% to 60% for the car and 34 to 58% for the bikes. And in a micro level, if we add one single bump, it may lead to increase of 2.63% of speed reduction for the car and 6.12% for the bike. And in other hand, if we increase the 10 mm height of the speed bump, it will increase the percentage speed reduction by 8.58% for cars and 4.69% for bikes. As here, we have collected a very less data for that is for 3 number of sites. These charts cannot be generalized. To generalize these charts, a more number of sites are required that will be further developed by this study. No more number of sites will be considered, and it is also considered that more number of vehicle categories and road types in future. And another perspective is there that to optimize the speed bumps configuration, we can also consider the comfort perspective. That one is related to jerk experience by the vehicle users. We can also optimize by this criteria. These are the references I have used, and hereby I'm completing my presentation. Thank you.
Please go on with your questions. Achal Gupta, sir,
Yes,
please go on. Just a minute, just a minute.
Sorry, sir, I cannot hear you.
Please hold on for a minute. Hello. Madam, unmute करना है सर. You can please
everyone.
Yes.
This is a very good topic you have taken, Ms. Gayatri. In the rural roads,
Yes, sir.
these bumps generally is given on the roads, but you have said that
Yes.
35 mm and 3 numbers are satisfactory for bikes and cars. Will it be
Yes, sir.
comfortable for other vehicles also, and will it reduce the speed of like other motor vehicles like LMV and others also?
So as of the time constraint, we did only for the bikes and cars category. In future, we can extend this topic for the all vehicle categories, and a common chart will be provided with the using comfort criteria also, so that so that all vehicle categories are satisfied. I think I have answered your question.
One more thing, the distance between each bump will be depending on will increase its speed, or accordingly they will reduce accordingly with the distance between two bumps. Distance between two bumps, what will be the
Sir,
criteria?
Sir, actually, we didn't consider that factor. We will add that in our future scope. We cannot say that how they'll behave. After collecting the data and analyzing the results, only we can say that how the behavior will change with respect to the distance between the each bump.
Okay, thank you.
Thank
Kalyan
you,
sir,
sir.
please go on with your questions.
Yes,
Kalyan
madam.
sir, if you can.
Namaskar. Madam, am I audible?
Yes, sir.
Am I audible?
Yes, sir.
Okay. Now,
Yes.
as per
sir.
IRC 99/2018, we are practicing this rumble
Yes,
strip for thickness up to 20 to 30 mm. Then one strip to another
Yes, sir.
distance maintained is 1 meter. And then we are putting six rumble strip. So this is what is being practiced for the all vehicles.
Yes, sir.
Now, since your concept is to develop up to 35 mm height. Now, what I am experiencing is if we raise the height of the strip, the more accidents are happening on the road. So earlier we used to put more than 6 number, and we experienced that the vehicles are getting stuck up, and then from the backside the vehicles are dashing. So then now, as per IRC 99/2018, 6 number strips are being put, and we have rather we are now practicing to put only 20 mm height. So how you introspect now, as per your study, how you conclude?
Sir, actually, as per the ERC, as you said, the number of bumps should be as 6 in number and 20 mm height. But in a real basis, in a real field, no one will be no speed breakers are as per the recommendations, and it is abruptly the height of the speed bump has increased about more than 30 mm or 50 mm. As I have studied in my study area, in one side it is 50 mm height and 6 in number, so that it will be very harsh on this road users. So that by using these charts, we can add a comfort criteria also, so that with the increase in the height also, this comfort should not be changed. By like that, we have to suggest the number and height of the bumps. In some cases there should be only need of 2 bumps, but if we instead we will place 6 bumps, it will be more on the driver's perspective. That's why we are suggesting these charts.
Okay, now for your information, I'll like to say that before this rumble strip, we are also putting the transbar bar marking. Transbar bar marking is also being put up for the psychological effect of the driver, so that he gets alert, and in the meantime he can reduce the speed. Okay, thank you very much.
Thank you, sir.
Thank you, Gayatri. You have done a good data collection by selecting the steep rumbles and speed bumps. Your study, I think you have got some insight from our experts, road safety officers also, that there need to be done some more in your studies. Means as the distance between the two rumbles, that should also be catered for, and for the other heavy vehicles and other type of vehicles except this motorcycle and all, motorcycle and car. You have done otherwise also you have done a very good work. You have made means ready-made data for the road safety officers to implement on the ground, but need to do more in this field. Thank you very much. Otherwise, it's very interesting and very knowledgeable topic
Thank you,
you have
sir.
presented. Thank you to you. Now, sir, let's have a break of
Thank you,
10
sir.
minutes. Thereafter, we will join again. It's now 11:25. We'll come back again after 10 minutes, 11:35. By then, please have break of 10 minutes. And please don't quit. Keep your videos, or you can shut down your videos. At the same time, be connected to us. Thank you. Thank you, sir. So welcome back again, all the ladies and gentlemen. I request you to please come back on the screen. Please be attentive now. So to continue with this session, now we are going to have with us Sri K.C. Tiwari. He is an international safety consultant. He is going to present. Yes, sir, your voice is coming, sir.
Okay.
He's going to present the lecture on speed management. Mr. K.C. Tiwari, sir, please, you can start sharing your presentation. By the time, let me introduce you with the audience. Mr. Kailash Tiwari, he is from Mo, Indore, but now I am Australian citizen since he is Australian citizen since 1993. He has an excellent qualification and had taught for 5 years at IIT Roorkee. He has worked for 45 years in 15 countries in the area of transport system planning, traffic management, road safety management, safe system, audit, engineering, policy, and strategies. He has worked in 15 countries of 20 World Bank, ADB, Japan, JICA, African Bank, Australian Aid Finance Project, and has trained 5,000 engineers and police professionals to improve road safety. A very eminent speaker. I request Tiwari sir to please start with his lectures.
Yeah, good morning, everybody. I think voice should be clear.
Sir, your voice is clear, but you are not visible, sir. Your presentation is also not there. It's a blank screen only.
Let me try.
Okay, okay.
Is it okay now?
Not yet, sir.
You have my PowerPoint presentation.
Sir, earlier it was coming, sir. You please quit and join again. I think then it will come.
Okay.
Sir, I'm sharing it from my side. You please carry on with your. Very sir, you can see the presentation now. Ankit Jain, are you there? Samkit Jain? Tiwari sir, are you able to share it, sir? Otherwise, I'll do it from my end. Tiwari sir, are you able to do it, sir?
Yeah. No, please do it yourself.
Okay, right, sir. I'm doing it from my end. It's okay, sir?
Yeah. So good morning, everybody. I will be talking about excessive speed management. And in that one, I will be covering about road safety situation, safe system, speed management, and the examples. Next, please. So as already, I think you might be well familiar and have already been informed that the number of fatalities in road crashes have increased dramatically, and there are significant rises are there, especially in India, where the numbers in 2019 were about 155,000. And then in spite of the COVID, number was about 133,000. And in most of these fatalities, what we call now the lives lost, that excessive speeding has been found in up to 35% of road crashes, fatalities in many countries, but especially in India, it is about 57%. Next, please. So these are from the data from NCRB, and again that police they collect the data, and that data is especially what NCRB published is, we can say, the most authentic one, and that should be used for all purposes. And here again, you can see that in 2019 and 2020, and so always that excessive speeding has been the main factor. Next, please. So, but before that, I start about excessive speeding, why we should tackle about the excessive speeding, and what is the safe system approach, which is now being used to as an intervention, and that is what we call the safe system towards zero. And it all started with in Sweden and in Netherlands. And in 2019, people always laugh that how can we get vision zero, or it is impossible to achieve that zero. But in Oslo, Norway, in 2019, they used to have 30 fatalities per year, 30 to 40 fatalities per year. But within 10 years, they have reduced it, and now that in the 2019, they had the zero fatalities. So it is achievable. And again, it is that what the target is being now being made by the different authorities. They are all are working that one. So basically, when it started in Sweden and in the Dutch, what we call the sustainable system or sustainable safety, that there were mostly that they tackled the actions on 4 pillars. So those 4 pillars were like safer roads, then safer road users, and then safer speeds, and then also the safer vehicles. So they targeted these 4 pillars. Next, please. Then in the Stockholm Declaration, which was in 2020, after the review of that decade of action 1, which was from 2010 to 2020, and the target could not be achieved of 50% reduction. So goalpost has been shifted now to 2030. So second decade of action is now 2021 to 2030. And then there was in 2020 Stockholm Declaration. And India has, our Honorable Minister, Mr. Gadkari went to that one, and then India has signed that they will be following all the recommendations. So basically that is Stockholm Declaration, decade of action 1, decade of action 2, they all have actually recommended strongly that we should follow the safe system approach. Next, please. So there are 4 principles basically of safe system approach. That is, the first one is we have a limited, we can do the mistake. So anybody who is like a road user or a road drivers, riders, they can make the mistake. So because of the mistake in the road crashes, they should not be punished or they should not die or seriously injured. Next one is vulnerability. Like we have a limited tolerance in our bodies. We cannot withstand that kinetic energy or the force of any strong road crashes or collisions. So human body has a limited physical ability to tolerate crash forces. And again, the most important thing is that road safety is a shared responsibility. So it is not only that police department or road department or transport department, it is a shared responsibility. And for that purpose, there should be continuous cooperation, collaboration, and coordination among the various stakeholders. And for that purpose, like we started, and already India has, luckily, after a lot of, you can say, effort and a lot of persuasion, that India actually has, last year, they have announced the National Road Safety Board. And I was involved with the establishment of road safety authorities in Kerala, Karnataka, Gujarat. So there we did established those type of authorities for the purpose of that this 4 C's in to improve the road safety. And then also when I was working as a Kerala, Karnataka, Tamil Nadu, that all where that road safety cells were established also in the those PWDs. And then there was a lot of training was provided to that police also. And a lot of equipments were purchased in Kerala, Karnataka, Gujarat. Those were like for speed management, for that drink and driving prevention, new driving licensing system, then seat belt, helmet, awareness. So those all packages, they were there. And again, till this decade of action second came, even in India, all the World Bank publications, all the researchers, all the faculty members, all the practitioners, they were following those 5 principles, 5 pillars. And then in that, the fourth pillar was, that fifth pillar was post-crash emergency care. And now that sixth pillar has been added, that is on speed management, safer speed. So why safe that, please, last slide, please. Earlier slide, yeah. So why safety matters? Safe speed involves reconsidering the speed limits to reflect the road quality and the surroundings. So all the roads, when they are designed or constructed, they have a function and like basically mobility and access. So there is an adjustment among those two factors. Like if it is a local road, then access is important. But if it is a expressway, super expressway, freeway, then that national highways, then mobility is very, very important. So we have to make an adjustment among those functions of those roads, then as per the classifications. And then accordingly, those speeds are being actually fixed. And again, that whatever speeds are being fixed, the speed limits, they are being again done in consultation with the police and all the stakeholders, and then considering that functions, terrain, and then local situation. And for that purpose, from engineering point of view, we can control that speed, or we can manage the speed with the traffic calming measures. And IRC 99, which has been developed, and that has got all the details about those traffic calming measures like roundabouts or humps, rumble strips. So they have all the details and their specifications. I was involved with that, preparing the materials and all the details about that IRC 99 in 1988. So I was teaching at Roorkee University, and then after extensive research, like what the presenter has mentioned, that type of work we did already in 1988. And then we had, because we luckily between Muzaffarnagar to Roorkee, we had about more than 60 different types of speed breakers, what we call speed reducing devices or Gati Avrodhak. So there we could do a lot of, with the help of students, with the help of radars, do a lot of profile. And then one, Mr. Jain, he also completed his master's thesis at that time. And then we presented all those details to the IRC, and then there was a lot of discussion. There was a heated discussion also. And then finally that IRC 99 in 1988, it was published. And rather than calling the bump, we use the term hump and Gati Avrodhak or speed breakers. So that was used because in the US or in the other countries, that bump is not being treated as a good language. So that way that bump was dropped, and then IRC and everywhere that hump has been introduced. And in throughout, even today when I was working in Gujarat as a team leader on the World Bank project, still they are using that bump ahead. So all the signs in Gujarat are still have that bump ahead. Whereas IRC in 1988 itself had mentioned that we have to not use that term. So speed definitely matters. And again, if anybody is familiar with the physics, what we call the kinetic energy, half mv square. And then we have to also see that what is the, like a speed is the one which is a scalar quantity, and that velocity is the one which is a vector quantity with like a both displacement and the direction. So we have to see that one, that if higher the speed, higher the kinetic energy, and more the damage and more the severity of accidents. Next, please.
Sir, please see the time also, sir. We are
Yeah,
exceeding that. Sir.
Yeah, so to build the safe system, we have to actually keep the speeds low. Yeah, next please. So again, if it is a head-on collision, up to 70 kilometer per hour is acceptable for an intersection. When it is a side collision, then it is a 50 kilometer per hour, but impact with a tree or for the pedestrian, it is 30 kilometer per hour. So Stockholm Declaration has mentioned that one in all the busy areas, in the school zones, in town areas, there should be 30 kilometer per hour. Next, please. So speed management, again, there are, as I mentioned, that is the approach, and what we have to follow, an integrated speed management approach, where that we have to actually decide the speed, then we have to do the education to the road users, and then only we should start the enforcement. And then we should continuously do the evaluation, and on that roads, for the safer roads, we have to provide those traffic calming devices. And then at the same time, we have to educate at the workplace that they should not go with a higher speed. Next, please. So I will skip number of those slides because they are all in the presentation. Next, please. Yeah, next, please. Yeah, next, please. Next. Next. Yeah, next, please. Next, please.
Just a minute, sir. It is not moving right now. What's the...
Yeah. So basically, that for traffic calming devices, and because you are mostly the police officers, so that the principle is that one, we should do that enforcement after educating and after providing all the traffic calming devices. Then we should do that, actually give emphasis on patrolling, because patrolling makes sense, and then it has found that one, with the patrolling with the CCTVs, that up to 10% reduction is possible in the fatalities. Then there are other equipments like variable message signs. Then there is those radars. Again, radars, different categories are there. So they are all being used for speed enforcement. And it has been found that in France or in Pakistan or in lower middle income countries, in Australia, in South America, that speed reduction is, if we follow that integrated speed management approach, then we can certainly reduce the number of fatalities and number of those severity of serious injuries. So in that context, we have to do, especially in India, that Madras High Court has already mentioned 80 kilometer per hour on the, those national highways and express ways. So again, and quite extensive studies has to be done, and then again, especially for that, because no need to provide the speed for different vehicles, speed limits, because it is a traffic stream, and where that uniform speed should be followed. Like if it is a 80 kilometer, means it is for any of the vehicles, like truck, bus, or those cars. It is not that one that you provide that one. And another advantage with that, like suppose 80 kilometer per hour, is that also it reduces the fuel consumption, it reduces those emissions of greenhouse gases, so pollution is reduced. So if higher the speed limits, first thing is severity, and then there is a more fatalities, more serious injuries, more energy consumption, more pollution. So only the difference is that one, that your travel time has to reduce it. But in most of the cases, that travel time is that if you can save the lives, if you can reduce the injuries, that reduction in travel time is not that important. So I finished that one, and that please go through that presentation. If there is any question, just please send it by email to me. So I complete my presentation here. Yeah. Any question?
Please, Jan sir, please go on with your question. Let me unmute you. Yes, now. Now go on, sir.
Thank you very much. Good afternoon, sir. Good afternoon, everybody. Sir, as I was listening to your presentation, it's very nice. And you said, you said, ki, speed management in terms of the speed reduction. So speed reduction saves you the fatalities. Okay, it's very nice. But looking to the sophisticated and high-graded infrastructures, recently we have been come across in the worldwide or even in India. Can't we think speed limits shall be increased, because you chal rahi hai 80 km per hour, national highway, expressway 100 km per hour. Now the vehicles are so sophisticated, so can we increase the speed limit or the design speed in terms of the pavement designs? Number one, can we think? However, it is a matter of IRC and modes. Number two, speed reductions always increase the travel time and cost benefit analysis. If you do so, travel time increase, the cost increase, indirectly the cost increase. So how will you make the balance between the two, looking to the recent sophisticated infrastructure and vehicle conditions nowadays? Kindly.
In that context, first thing we have to see that what type of cars and the two-wheelers we are operating. Still, the 97% of the cars which are sold in India, which are manufactured in India, they have 0 to 3-star crash rating. So the cars itself are not safe. None of the car in India has got the 5-star for the child occupant. So even the Tata Nexon or Mahindra or all these type of manufacturers, what they are getting those cars, none of them have 5-star rating for the child occupant. Again, those all things are being introduced. Then what about our those drivers and the riders? Again, in most of the cases, if you see, and then how to get the license and how they are trained, what is their experience level. So it is those drivers and riders, and that is the reason that that, as you can see already, I mentioned that negligency and that over speeding. Because of those over speeding and negligence, this number of fatalities and serious injuries are occurring, and number of crashes are increasing in India. So, and then just by designing the road for say 150 km per hour or 120 km per hour is of no meaning. And that is why the Madras High Court has intervened. And they have mentioned it very categorically. They have done quite comprehensive analysis. Everything was presented to them. And those countries which are showing the results, like Norway, Sweden, Netherlands, even Australia, that in entire Australia, that the national speed limit is 110 km per hour. But on most of the roads, depending on the functions, and there are now 90 to 100 km per hour. New Zealand, all rural roads, including our like a national highway and state highways, now their speed limits, they are reducing it to 80 km per hour. So quite comprehensive study, because lives are important. As you told, benefit cost ratio, more that, like, you will be surprised that the cost of a unit cost of a fatality in India is 91 lakhs and about 91.4 lakhs. So that is a cost of a one fatality, which is not actually been mentioned or in benefit cost analysis. If you can save one life, you are saving about 1 million rupees. So that way it has to be done in that calculations, and the lives are important. And again, the burden on the this one traumas related with these fatalities and serious injuries, plus the loss of productivity, plus the burden on the law and order people, burden on the health professional is quite enormous.
Thank you very much, sir, for your analytical answer. Thank you. So nice.
And speed management and speed, I think I can give lecture for 1 week. So just within about 20 minutes, I have just given just a brief introduction. But if we can control the speed in India, then we can almost 50% of that our fatalities we can reduce. And China did it. I was collecting the data. I was working in China, and in China, that suddenly that from 130,000 fatalities, it reduced to 95,000 in 1 year, and that was only because of the enforcement. People have to follow. In Tamil Nadu in India, 54% reduction, because they use those all the 6 principal pillars, actions on the 6 pillars in a coordinated way. And everything was like evidence based. So Tamil Nadu is the only country, only state in India which has developed quite those accident database management system, and now HP is also working on that one. Any other
Answer,
question?
you can ask your question.
Thank you, sir. One very important aspect I want to bring here, sir. You are talking about fatalities and the accident due to the high speed. Now, on the contrary, in our 4-lane national highway or 6-lane national highway or more than 4-lane national highway, we find that a lot of people are driving contra flow. Now, you are talking about the speed radar gun for e-challan and etc. So in this regard, since you have a lot of experience and of abroad also, my query is, query is that, sir, for contraflow, can we go ahead? Can there be any mechanism by which this e-challan can be introduced? This is very important thing, because maximum accidents are happening on the national highway while driving contraflow. Contraflow means opposite side people are driving. And we cannot go on putting median opening everywhere as per desire of the people. We have, as per IRC norm, we can put median opening within 2 kilometer on rural, and of course more within 500 meter or more than 500 meter in the inhabitant or metropolitan or say most populous place. So now, sir, I want to know from your side, sir, how can we go about with this to reduce the accident due to this contraflow and high speed? Contraflow means when opposite side vehicles are coming, due to high speed, accidents are occurring. So how to solve this problem? That is the main problem is now occurring on the national highway, sir.
So just in that respect, first thing is why we do enforcement. That we want to regulate, and that people should follow the traffic rules. So similarly, like jumping the red light or contraflow movement. So all these are all what they are not following the traffic rules. So if anybody is not following the traffic rules, that Motor Vehicle Act has got like a list of all those punishment, And in Gujarat, I also introduced the term what we call the demerit points. If you have the 12 points, then your license will be cancelled. So if you are jumping red light, 3 points. So similarly, that is the need of the hour in India, that Motor Vehicle Act has to be amended, that not only fine but also the points also. So like in a contraflow type of situation, who prevents you to do that like a fine or do that enforcement? Nobody prevents if you are not following the traffic rules anywhere, anytime. So that is the what we do the enforcement in Australia, that whenever we do the enforcement, once we have provided the facilities, once we have got the education and awareness, then we do that enforcement. And that is with the principle that anytime, anywhere, anybody, anytime, anywhere is not following the like speed limits or any rules and regulations, then that person will be punished, and that will be also have the demerit points.
Sir, thank you very much. I think there is no more questions from side of audience. And sir, it is true that time was very less and topic was quite vast. And then also you have kept the interest alive of all the participants. Thank you very much to you, sir, for giving us time for this nice presentation on the speed management. You have really given good data about the other countries comparison you have done with other countries. Thank you, sir. Now in the series of in this session, we are going to invite Mr. Samkit Jain. He is ME scholar from Sati Vidisha. He is going to present one case study on the development of methodology for prediction of traffic accident fatality in Vidisha city by using a software developed as MATLAB. Ankit, please carry on with your presentation.
Sir,
Samkit.
thank you, sir. Yes, sir.
He has done this research work under Dr. Rakesh Meher of Samrat Ashok Technological Institute, Vidisha. Samkit, are you able to share your presentation?
Yes, sir. Sir, I am having a difficulty in sharing the presentation, sir.
Why so? There should not be any problem. Your video is also not coming. You are also not visible.
Sir, can we try after some time, sir? Is there something technical error, I think?
So let me see. Panda sir, are you there? Dilip Kumar Panda sir, are you there on the web, sir? Samkit, by the time you try, I will also let me check whether another speaker is there ready or not. You keep on trying. Officers,
Yes, sir.
please let me check up the availability of other speaker. पांडा सर आप कनेक्टेड हैं पांडा सर
Yeah. Yes, sir. Hello, sir. Hello, sir.
Sir, आवाज आ रही है?
Yeah, are you hearing me?
Yes, sir. Panda sir, but I can hear you, but you are not visible on the screen.
Yeah. I'm starting my video. Yeah, is it coming?
Sir, you are visible. Yes, sir. Welcome, sir. You are visible, sir.
अच्छा, तो ये कोई पेन ड्राइव है क्या किसी के पास वर्ड्स में देने के लिए साहब को?
Please keep yourself mute. Please mute yourself.
हैं? उसको कंप्यूटर में लेना चाहते हैं। पेन ड्राइव है? प्रकाश के पास तो नहीं है। पूछना कोई से के पास होगा, पेन ड्राइव होगा। एक लिया ना तो पेन ड्राइव 2-400 का आता है। अभी तो मंगाने से नहीं तो नया मंगाने घर पे मैं देखूंगा, पड़ा तो था मेरे लिए।
एक तो कहाँ से आवाज आ रही है?
सुरक्षा सखी का शक्ति वाली कार का नोडल का पता है
आपको?
हाँ।
मिला जाए आप मॉडल तो इस टाइप में हो आप, ठीक है। 30 साल पहले कोई सिखाओ होता ना तो ये मान लो इस पॉइंट के लिए मारा मारी क्यों? आप बताओ।
Please mute yourself. So much noise is coming. Please mute yourself.
हाँ जी, कैरेक्टर गाएगा। हाँ भाई, हाँ
पंडित सर, मैं इसको शेयर कर रहा हूँ, आप चेक करें। शेयर कर दिया ना, आपकी वो नहीं आ रही वीडियो। सर, आपकी वीडियो नहीं आ रही, हमने प्रेजेंटेशन अपने आप शेयर कर दिया है। Hello, sir.
वीडियो आ गया, ठीक है, ओके। और आपका प्रेजेंटेशन क्लोज कर दीजिए, इधर से हम शेयर कर रहे हैं क्योंकि दिक्कत होगा नहीं। हाँ हाँ
By the time, let me introduce Mr. Dilip Kumar Panna to all of you. He is a BCom, MBA, and MSW. He is a road safety advocate and expert working for road safety issues with various states, national and international agency of the government. He is a researcher on the driving behavior aspect of driver in India, a mentor for the implementation of good Samaritan laws and capacity building in different parts of the country. Working at international platform with Global Alliance for Road Safety, he will represent India. He has represented India in 7 global meet for non-governmental organizations advocating for road safety and road victims in Budapest, Hungary this month. He is actually the president cum CEO of NGO known as Safe India. Sir, please go on with your presentation, sir.
Thank you, sir. And my best regards to all dignitaries. Good afternoon to all participants. Till now, we have learned and discussed many models and research paper have seen case studies we have discussed, presented different experts. What I think and experienced that that it is not a single model which can help us to resolve this issue what we are discussing from yesterday. So my opinion is that the road user is more important for whom we are discussing on different technologies and development. So my focus is to develop the road user actually who is using the technology and what technology we are discussing and developing that will be used by those user. If those user will not use all this technology, then it will no use. So cost factor is also a issue to implement for a long-term sustainable way. Sometimes we have seen that many technologies and model, very good models, so we have implemented, but we are not able to implement it for a long-term sustainable way. So if it will fail in long term, then again that model will be a problem for us. So in this presentations, I basically I will not discuss many more things regarding the data because the past speakers have already discussed many data, the status of road crashes in our country or globally. So just a hint, I can give you some details. What we will discuss today in these presentations, that is status of road crashes and status of urban mobility. In Indian context. And then I will show you a sustainable urban mobility, what we have just started as a pilot. So you can see, is it moving? The screen is moving?
No, sir. No, sir. Sir, you can pull the bar from your cursor, sir. It will do.
Yeah. Now you are able to see the first road traffic death.
Yes, it's okay now.
This is the first road traffic death ever reported in the world. And it happens in 1896. The circled face is the lady who died in a road collision in London. And the vehicle speed was approximately 8 miles, which is 13 km per hour. This is the first ever road crash death reported in world. So if we will see the global status, we have already discussed earlier with, and many speakers have cited about it, that injuries, this is seriously injuries. It is more than 50 million globally, and death is 1.35 million. But if we will calculate the present status, the death rate will be more than 1.5 millions. This is the data taken in 2018, and the data published by WHO in his global status report, and it is still rising. And if you will see the national status, you all knows that we are contributing only 1% of global vehicles, but we are responsible for more than 11% fatalities. So every 3 minutes there is a road crash fatality in India, and every minute there is an accident. So why we are particularly discussing road safety or road crashes? Because we are more dependent on road in India. We are the second largest in the world, that our road length is almost 62,000 kilometers. It may be more because the data is 2-3 years back data. Road carries in India, road carries almost 87% of passenger and 65% of freight. So think that we are more dependent on road, and not only dependency, but the gross GDP is also a big factor. In India, the transport sector contributes 4.5% GDP to our country. So the worry part is that how much persons are killed in road crashes in India. It is almost 70% age group is 18 to 45. This is the most worrying factor. So why will work on road safety? What is the main cause, or what is the reason we are that much of worry to work on road safety? Because if you will see the data of Government of India is telling that we are losing almost 55,000 crores rupees per year due to road crashes. But recently a study done by IIT Delhi and DIMTS, which is a Delhi Integrated Multimodal Transit System, they have jointly studied that and told that the cost loss effect is 1.47 lakh crores per year. But again, they have told that it is underestimated. If you will estimate properly, it will be almost 6 lakh crores per year. And if we will analyze it and if you will simplify it, then it is roughly 74 lakhs per person. This is the loss output per person. So this is the situation of India, and definitely we are number one, and the rank is one in world relating to road accident also, and road fatalities, road crash death across 199 countries. So definitely it is a worrying part. But today, what I want to discuss, this is urban mobility and how urban mobility can be safe. How will we create a safe atmosphere in urban for the urban citizen? So I focused only on only some factors which can be easy to implement, because cost is a big factor. If there is a very good model and if there is a very good technology to implement, but the cost is big, then it is definitely a problematic thing that we cannot sustain it a long run. But locally, how we'll do it, and locally at a city level, at a city authority level, how we'll run a sustainable model, that we'll discuss today. And what we have experienced in our pilot project, I will try to describe all of you. So what is urban mobility? ये एक ऐसा चीज है कि अर्बन मोबिलिटी का मतलब है कि हम एक जगह से दूसरा जगह विद इन द सिटी हमारा काम के लिए, जैसे कि टू स्कूल्स, टू ऑफिस, टू शॉप एनीथिंग, टू मूविंग अराउंड द सिटी, तो ये एक वन पॉइंट टू अनदर पॉइंट हम लोग जब मूव करते हैं कोई सिटी के अंदर, दैट इज अर्बन मोबिलिटी। एंड अर्बन मोबिलिटी का मतलब नहीं है कि हम लोग खाली वन पॉइंट टू अनदर पॉइंट जाएं, हाउ विल मूव सेफली फ्रॉम वन पॉइंट टू अनदर पॉइंट। सो इन इंडिया रैपिड अर्बनाइजिंग एंड अर्बनाइजेशन काफी जोर से अभी ग्रो हो रहा है, एंड वी आर सेकंड लार्जेस्ट अर्बन सिस्टम इन वर्ल्ड। ऑलमोस्ट अगर 2011 का डाटाबेस हम दें, ऑलमोस्ट 367 मिलियन पॉपुलेशन ये हम लोगों का इंडिया में है आफ्टर चाइना। अगर सिटीज का बात करें 2011 का जो डाटा है, इट इज ऑलमोस्ट 8000 सिटीज। और ये एक्सपेक्टेड जो पॉपुलेशन ग्रो हो रहा है इन अर्बन एरियाज इन आवर कंट्री, इट इज ऑलमोस्ट 473 मिलियंस, और ये एक्सपेक्ट किया जा रहा है बाय 2051 इट विल बी 820 मिलियन। सो कहीं ना कहीं आगे चल के अर्बन एरियाज में हम लोगों को ज्यादा पॉपुलेशन का मतलब ज्यादा व्हीकल मूवमेंट का मतलब आपका ट्रैफिक कंजेशन, मोर नंबर ऑफ एक्सीडेंट, तो ये सब आगे चल के होने वाला है। तो हम लोगों को जो अभी हम लोग टेक्नोलॉजी के बारे में बात कर रहे थे, तो डेफिनेटली टेक्नोलॉजी, आई एग्री दैट इट इज नेसेसरी, बट उससे पहले ये टेक्नोलॉजी जो रोड यूजर के लिए यूज हो रहा है, तो दैट रोड यूजर शुड अंडरस्टैंड दैट टेक्नोलॉजी, शुड अडॉप्ट दैट टेक्नोलॉजी। नहीं तो हम लोग अभी जैसे कि हम लोग अभी ग्लोबल एक्शन प्लान के बारे में, डेकाड ऑफ एक्शन प्लान के बारे में कुछ स्पीकर्स हम लोगों का बात कर रहे थे, तो इंडिया इज ऑल्सो ए सिग्नेटरी ऑफ दैट ग्लोबल प्लान, जो कि हम लोगों का ग्लोबल प्लान 2011 टू 20 था। अभी उस ग्लोबल प्लान में जो हम लोग हमारा ऑनरेबल मिनिस्टर नितिन गडकरी जी साइन किए हुए थे लास्ट मीटिंग में, तो वी ऑलमोस्ट फेल्ड। तो ग्लोबल प्लान में जो भी हम लोग डिसाइड किए हुए थे करेक्शंस के लिए, हम लोग उसको नहीं कर पाए। तो अगेन ग्लोबल प्लान अभी आया है डेकाड ऑफ एक्शन का, आपका 2030 तक। तो उसमें भी अभी 1 जुलाई में हाई लेवल मीटिंग होने जा रहा है, जहां हो सकता है कि ऑनरेबल मिनिस्टर गडकरी साहब वहां ज्वाइन करें। तो उसी का पहले हम लोगों का भी अभी प्रिपरेटरी मीटिंग हो रहा है हंगरी में, बुडापेस्ट में, इस महीना 20 से लेकर 24 तारीख, तो जहां मैं इंडिया से रिप्रेजेंट कर रहा हूँ। लेकिन बात वो नहीं है, बात है कि हम लोग क्या प्लान करते हैं, क्या पॉलिसीज करते हैं, क्या टेक्नोलॉजी डेवलप करते हैं, वेदर इट इज इम्प्लीमेंटेड, और वो क्या अडॉप्ट कर सकते हैं हमारा रोड यूजर्स, दैट इज वन ऑफ द बिगेस्ट थिंग। सो क्या ट्रेंड है, ये इन्फ्लुएंस क्या करता है? रैपिड अर्बनाइजेशन, रैपिड मोटराइजेशन, ड्विंडलिंग शेयर। ये आप देखेंगे कि अभी धीरे धीरे नॉन मोटराइज ट्रांसपोर्टेशन जो था हम लोगों का, साइकिल रिक्शा, ये भी अभी कम होते जा रहा है बिकॉज ऑफ दिस अर्बनाइजेशन, रैपिड ग्रोथ जो हो रहा है अर्बनाइजेशन में। अर्बन ट्रांसपोर्ट का क्या प्रॉब्लम्स हैं जो हम लोग ये आइडेंटिफाई किए हुए हैं? इसके अलावा भी बहुत सारे प्रॉब्लम्स है, बट वी थिंक दैट, आई पर्सनली, माय ओपिनियन इज दीज आर द की प्रॉब्लम्स व्हिच वी आर फेसिंग इन अर्बन ट्रांसपोर्ट सिस्टम। रोड कंजेशन तो हो रहा है, पार्किंग प्रॉब्लम इज ऑल्सो ए बिग इशू, और हम लोगों का जो रोड सेफ्टी का जो एटमॉस्फेयर बनना चाहिए वो डिटेरिएट हो रहा है। इमरजेंसी रेस्पॉन्स का कोई हम लोगों का, आप अगर देखेंगे, क्योंकि इमरजेंसी रेस्पॉन्स और गुड समरिटन के ऊपर मैं पिछले 3 साल से काम कर रहा हूं, एंड आई एम ऑल्सो डूइंग मेंटोरिंग ऑन दिस। सो इसमें बहुत सारा मैंने रिसर्च, बहुत सारा इवेलुएट हम किए हुए हैं, मेरे पास डाटाबेस हैं। अगर हम लोग इमरजेंसी रेस्पॉन्स के बारे में बात करें, इन इंडिया वी डोंट हैव एनी इमरजेंसी हेल्थ केयर फैसिलिटीज। अगर फॉरेन कंट्री में आप लोग देखेंगे तो दैट इज, ये एक उनका प्राइम रेस्पॉन्सिबिलिटी है, वो एक बाइंडिंग है, उनको कितना टाइम के अंदर इमरजेंसी रेस्पॉन्स प्रोवाइड करना है वो वहाँ है, उनको देना पड़ेगा। बट हियर, बिकॉज ये एक इंफ्रास्ट्रक्चर कॉस्ट इशू है, मैं इसीलिए ये बात कर रहा हूं कि हर चीज हम लोग इमीडिएटली चेंज नहीं कर सकते हैं, क्योंकि कहीं ना कहीं अगर जहां इमरजेंसी रेस्पॉन्स का बात होता है, ऑल ओवर इंडिया अगर ये केयर ये फैसिलिटीज हम लोग प्रोवाइड करेंगे, डेफिनेटली हम लोगों का जो इंफ्रास्ट्रक्चर लेवल में गवर्नमेंट को इसको लाना पड़ेगा। बहुत सारे डॉक्टर्स, बहुत सारे हेल्थ पैरामेडिक्स स्टाफ्स, उसके लिए जो आर्टिकल्स, एम्बुलेंसेस, ये बहुत बड़ा एक कॉस्ट का फैक्टर है। तो अगर हम लोग इमरजेंसी रेस्पॉन्स के लिए तैयार नहीं है या हमारा देश में वो नहीं है, सो हाउ वी विल गिव इमरजेंसी रेस्पॉन्स टू रोड एक्सीडेंट विक्टिम? एक ही रास्ता बचा हुआ है, दिस इज ओनली द हेल्प ऑफ बाईस्टैंडर, जिसको हम लोगों ने गुड समरिटन कहते हैं। इसका ऊपर ज्यादा हम लोग चर्चा नहीं करेंगे बिकॉज टाइम इज कांस्टेंट ऑल्सो। बट अर्बन ट्रांसपोर्ट प्रॉब्लम्स में ये 4-5 चीज जो की थिंग्स है, ये आता है कि हम लोग का आज के दिन में जो प्रॉब्लम्स वी आर फेसिंग इन अर्बन एरियाज, तो ये एयर पोल्यूशन इज ऑल्सो ए बिग थिंग। और ये एक उरी वाला पार्ट है। आप देख रहे हैं दिल्ली का जो सिचुएशन है, चैलेंजेस क्या है हम लोगों को, व्हाट आर द डिफरेंट चैलेंजेस वी आर फेसिंग, गैप्स बिटवीन लॉ एंड रेगुलेशंस, ये डेफिनेटली है। क्योंकि इसी के ऊपर हम लोग जब काम करते हैं, वी ऑब्जर्विंग एंड वी आर ऑल्सो एक्सपीरियंसिंग कि हम लोगों का जो लाइफ सेविंग रूल्स एंड रेगुलेशंस हैं, हम लोगों का जो डिफरेंट ट्रैफिक लॉज हैं, हम लोगों का जो डिफरेंट सपोर्टिव लॉ है टू एक्सीडेंट विक्टिम्स, ये कहीं ना कहीं गैप्स है। लैक ऑफ कोऑर्डिनेशन बिटवीन एजेंसीज, जो रिलेटेड एजेंसीज हैं, फॉर एग्जांपल पुलिस, हेल्थ, ट्रांसपोर्ट डिपार्टमेंट, ऑल्सो सिविल सोसाइटीज, म्युनिसिपल कॉरपोरेशंस, इन लोगों का बीच में भी कोई कोऑर्डिनेशन नहीं है, जिसके चलते ये गैप्स है। ह्यूमन रिसोर्स का भी बहुत बड़ा चैलेंजेस है। हम लोग को ज्यादा कुछ होने से ट्रैफिक में जो हम लोगों का ऑफिसर्स हैं या ट्रैफिक पुलिस हैं, उन्हीं के ऊपर हम लोग एक सिंपली रिमार्क्स दे देते हैं। बट ये भी तो देखना है कि कितना ह्यूमन रिसोर्स है वो सब चीज को हैंडल करने के लिए, ट्रैफिक कंजेशन को दूर करने के लिए, और उनका पास वो सफिशियंट ह्यूमन रिसोर्स है क्या, हम लोग वो सेफ मोबिलिटी को इंश्योर कर सकें। इम्प्लीमेंटेशन ऑफ लाइफ सेविंग रूल्स, ये इसका एक बहुत बड़ा रोल है। हम लोग का उसका बहुत सारा लाइफ सेविंग रूल्स तो बना लिया, बहुत अच्छी चीज है, क्योंकि बहुत सारा कंट्री में ये अभी तक नहीं बन पा रहा है। फॉर एग्जाम्पल गुड समरिटन लॉ, लगभग 5 साल से हम लोगों का ये लॉ बन चुका है, और इसमें सारा स्टेट भी अपना एसओपी, स्टैंडर्ड ऑपरेटिंग प्रोसीजर, हैज बीन सेट एंड सर्कुलेटेड टू ऑल डिपार्टमेंट्स ऑल्सो। और ये क्या इम्प्लीमेंटेशन हो रहा है? पार्किंग एंड ट्रैफिक क्लियरेंस, ये भी एक बहुत बड़ा चैलेंजेस है आज के दिन में। आप देखेंगे बहुत बहुत सिटीज में, मोस्ट ऑफ सिटीज में ये एक सरदर्द है हम लोग, हमारा अथॉरिटीज के लिए, कि पार्किंग कहाँ हो रहा है, ऑथोराइज जगह में हो रहा है कि नहीं, पार्किंग का प्लेस प्रोवाइडेड अगर नहीं है तो कहीं ना कहीं हम लोग पार्किंग गलत जगह में होगा। और ट्रैफिक का, इसके चलते ट्रैफिक का जो क्लियरेंस होना चाहिए, जो जाम होता है, वो क्लियर नहीं हो पाता है। and coordination with the transport operators. Those are the transport operators who are operating their public transport service in the city. अगर हम लोग का डिफरेंट कम्युनिटीज होता है, इफ यू विल सी देयर इज ऑटो रिक्शा कम्युनिटी, टाउन सिटी बस, इफ देयर इज एनी स्मॉल वैन्स, दे हैव देयर कम्युनिटी। तो इन लोगों का बीच में भी कोई कोऑर्डिनेशन नहीं, एंड absence ऑफ रिलायबल ट्रांसपोर्ट डाटा। हम अगर किसी का पास जाएंगे, अगर मैं खुद पर्सनली एक्सपीरियंस किया हुआ हूँ, एक एग्जांपल आप लोगों को देना चाहता हूँ आपका अंडरस्टैंडिंग के लिए। सेफ्टी ऑफ स्कूल चिल्ड्रेन इज ए इशूज ऑल्सो, एंड दिस इज ऑल्सो ए सेंसिटिव इशू। स्कूल चिल्ड्रेंस का जो सेफ्टी होता है, व्हेन दे आर मूविंग फ्रॉम देयर होम टू स्कूल एंड अगेन फ्रॉम स्कूल टू होम, इसमें कौन सारा ऑपरेटर्स हैं? स्कूल बस डेफिनेटली हैं, और बहुत सारा प्राइवेट व्हीकल्स डिप्लॉयड हैं जो कि प्रोफेशनली स्कूल चिल्ड्रंस को कैरी करते हैं। तो हम लोग उसके ऊपर एक काम कर रहे थे। आई पर्सनली विजिटेड मेनी टाइम्स टू द कमिश्नर ऑफ पुलिस, टू द ट्रांसपोर्ट डिपार्टमेंट, टू द एजुकेशन डिपार्टमेंट, टू डिफरेंट लीडिंग प्राइवेट स्कूल्स, बट नोबडी हैज द करेंट डाटा ऑफ दोज व्हीकल्स। इसका मतलब ये पता चलता है कि हम लोग अंधेरे में हैं कि कितना व्हीकल्स हम लोगों का स्कूल चिल्ड्रन को कैरी करके लेके जाते हैं, और वो व्हीकल्स कौन कौन सा है, उनका डाटाबेस क्या है, वेदर दोज व्हीकल्स आर फिट और नॉट। तो ये सारा डाटा का भी हम लोगों के पास एब्सेंट है, नहीं है। अगर ये नहीं है तो हाउ विल मैनेज दिस ट्रांसपोर्ट सिस्टम, हाउ विल एंश्योर द सेफ मोबिलिटी। तो ये भी एक चैलेंजेस है हम लोगों के सामने। सो रोड यूजर एंड व्हीकल्स क्या है सिटी में, अगर उसका दोनों हम देखेंगे, ये आप लोगों को सबको पता है, ज्यादा कुछ डिस्कशन नहीं करेंगे। रोड यूजर्स में आप लोगों का पेडेस्ट्रियन आ गया, बाइसाइकिल्स हैं, पब्लिक ट्रांसपोर्ट यूजर्स हैं जो कि रोज सिटी बस में जाते हैं या शेयर ऑटो रिक्शा में जाते हैं या कैब में जाते हैं। प्राइवेट व्हीकल यूजर्स भी हैं जो खुद का गाड़ी लेके जाते हैं। स्कूल चिल्ड्रंस हैं। तो ये सारा रोड यूजर ऑफ ए पर्टिकुलर सिटी। अगर टाइप्स ऑफ व्हीकल उस सिटी में अगर देखेंगे, नॉर्मली जो चलता है वो बाइसाइकिल और साइकिल रिक्शा, लेकिन मोस्ट ऑफ सिटीज में अभी साइकिल रिक्शा धीरे धीरे कम होते जा रहे हैं, कहीं पे जीरो भी हो गया है। एंड ऑब्वियसली मच मोर व्हीकल्स आर टू व्हीलर्स, एंड ऑटो रिक्शा इज ए मेजर प्लेयर इन एनी सिटी इन आवर कंट्री। और उसके साथ साथ आपका अभी कार और कैब आ गया। कैब का बहुत सारा सिटी में ऑपरेट हो चुका है प्राइवेट, जैसे कि ओला उबर्स हैं, और बस, स्कूल बस और ट्रक कुछ कुछ पर्टिकुलर टाइम लिमिट्स में। ये सारा व्हीकल्स हम लोगों का सिटी रोड में यूज होता है। प्रायोरिटी इशू हम लोगों को क्या दिखना है, एक्चुअली व्हाट वी हैव आइडेंटिफाइड प्रायोरिटी इश्यूज, जिसको कि इमीडिएट बेसिस में हम लोग अगर उसके ऊपर ध्यान दें, इफ यू विल फोकस्ड ऑन दीज इश्यूज, आई थिंक सम प्रॉब्लम will be minimized. नंबर 1 इज ट्रैफिक कंजेशन एंड पार्किंग। ये एक बहुत बड़ा इशू है। ट्रैफिक फैटेलिटीज, अगर आप फैटेलिटीज का बात करें तो ऑलमोस्ट 12% रोड ट्रैफिक फैटेलिटीज जो है पूरा इंडिया का, जो 1,50,000 फैटेलिटीज है, उसका 12% ये अर्बन सिटीज के अंदर होता है, और 12% सिटीज के अंदर ट्रैफिक फैटेलिटी हो रहा है। का मतलब है ये काफी हाई फिगर है, क्योंकि एक सिटीज के अंदर स्पीड क्या होना चाहिए व्हीकल्स का, अभी हम लोग स्पीड के बारे में बात कर रहे थे, तो वो स्पीड के हिसाब से और जो ट्रैफिक सिस्टम्स हैं, हम लोगों को ये अज्यूम करना चाहिए कि किसी एक रोड क्रॉस में भी डेथ नहीं होना चाहिए, लेकिन स्टिल we are losing 12% of the total. And number 3 is lack of emergency response. This is also one important factor जहां हम लोग फैटेलिटी बढ़ जाता है। आप लोगों को ये पता है कि गोल्डन आवर इज वन ऑफ द इम्पोर्टेंट थिंग। अगर विद इन ए आवर हम लोग रेस्पॉन्स नहीं देते हैं उसका लाइफ लॉस होगा। तो ये भी एक रीजन है जिसके चलते हम लोगों का मिशन ऑफ इंडिया और WHO ये रेकमेंड कर चुका है कि हम लोग 50% लाइफ सेव कर सकते हैं अगर इमरजेंसी रेस्पॉन्स 1 घंटे के अंदर देते हैं। लेकिन जो हम लोग नहीं कर पा रहे हैं। एज पर द WHO रिपोर्ट, हम लोगों का जो डेथ होता है 50% डेथ पहला 15 मिनट में हो जाता है। कोई भी क्रॉस का हिंदुस्तान में हम लोगों का जितना क्रॉस हो रहा है, क्रॉस में जो 1,50,000 है, वो पहला 15 मिनट में ही 50% डेथ होता है, जिनको हम लोग सेव नहीं कर सकते। लेकिन बाकी 50% 70-80 हजार लाइफ और ये इमरजेंसी रेस्पॉन्स के थ्रू ही हम लोग सेव कर सकते हैं, क्योंकि उनको अगर टाइमली रेस्पॉन्स नहीं मिलेगा देन इट इज वेरी डिफिकल्ट टू सेव द लाइव्स। एंड नंबर 4 इज हरासमेंट एंड क्राइम। ये सिटी के अंदर होता है। ड्राइविंग बिहेवियरल एस्पेक्ट ऑफ ड्राइवर्स, यही एक मुद्दा है जिसके चलते कंजेशन और पार्किंग का जो दिक्कतें बढ़ता है बिकॉज ऑफ द ड्राइविंग बिहेवियर ऑफ द ड्राइवर and some other things also. This is our priority issue we need to resolve it. ये एक स्टडी ये भुवनेश्वर स्मार्ट सिटी ये सर्वे किया हुआ था उसमें हम थे। इसमें कुछ चीज आपको समझाना मैं चाहता हूँ, अगर एक आइडिया के लिए हम आपको दे रहे हैं। आज के दिन में अगर हम बिफोर कोविड, राइट वाला साइट अगर हम बिफोर कोविड, ये पब्लिक अर्बन सिटीजन उनका मूवमेंट था, वो लोग कैसे उनका मोबिलिटी था। आप अगर देखेंगे कि सबसे ज्यादा परसेंटेज टू व्हीलर में होगा और बस का शेयर होगा, जो सिटी बस है। वो जो आप देखेंगे टू व्हीलर का शेयर जो 27% है, और इसमें 36% बस है और शेयर ऑटो है। अकेला बस का डाटा नहीं है, इसमें शेयर ऑटो का भी डाटा है। और जो कैब यूज होता है दैट इज वेरी लेस, इट इज 9%। एंड कुछ अदर जैसे कि चल के कोई साइकिल में कोई अदर जो हम लोगों को डाटा नहीं मिल पाया, 28%। ये बिफोर कोविड सिचुएशन। अगर आफ्टर ये कोविड का टाइम में और अभी जो चल रहा है रिसेंटली, अगर ये सिचुएशन देखेंगे, इट हैज इंक्रीज, द टू व्हीलर मूवमेंट इज इंक्रीज अप टू 40%। और ये शेयर ऑटो और बस ये दोनों मिला के 29%। और ऑटो, टैक्सी और कैब अगर रिजर्वेशन में जो जाते हैं, खास करके आप इंडिविजुअली कोई ऑटो रिक्शा रिजर्व किया या टैक्सी रिजर्व किया या ओला उबर रिजर्व किया, उसका शेयर ओनली 9%। ज्यादा शेयर आपका टू व्हीलर एंड बस एंड ऑटो रिक्शा। ये है आज के दिन का हम लोगों का अर्बन सिटीजन्स का मूवमेंट का जो स्टाइल है। अगर इसमें ये खास करके भुवनेश्वर सिटी का हम बता रहे हैं, दैट इज वन ऑफ द बेस्ट सिटी इन आपका जो स्मार्ट सिटी सिस्टम के अंदर। सो आई एम ऑल्सो ए मेंबर ऑफ देयर टीम। उन लोगों का एक टीम है जो उसमें मैं मेंबर हूँ, तो ये डाटा इसीलिए मेरे को मिल पाया। पब्लिक ट्रांसपोर्ट मॉडल जो यूज हो रहा है अभी, अगर भुवनेश्वर के अंदर हम लोग देखेंगे, इसमें आप देखिए कि शेयर ऑटो का परसेंटेज 34%। जितना सिटीजन मूव हो रहा है पूरा टाउन के अंदर, 34% शेयर ऑटो यूज करते हैं। और जो सिटी बस है, जो टाउन बस जिसको हम लोग कहते हैं, इट इज 46%। लेकिन इसमें मैं एक चीज कहना चाहता हूँ, ये 46% पर्सन्स, हाउ मेनी व्हीकल्स, हाउ मेनी सिटी बसेस, और 34% जो शेयरिंग ऑटो में जा रहे हैं, इट इज हाउ, व्हाट इज द नंबर ऑफ ऑटो रिक्शा। सो माई फोकस पॉइंट इज दैट how much auto rickshaw is operated in the city and how much city bus is operated. More number of vehicles means more congestion, more traffic problem, more accident. So इसमें अगर हम लोग कुछ डाटा लिए हुए हैं, इसमें ये जो सैंपल साइज था, ये लगभग 3500-4000 रेस्पोंडेंट थे सिटी के अंदर। उन्हीं से ये डाटा कलेक्ट किया हुआ है, इंटरव्यू किया हुआ था। उन लोगों का कहना है कि जर्नी फील इनकन्वीनियंट जो लोग कहते हैं, लगभग 56% ये कहते हैं कि जर्नी जो उन लोगों का सिटी के अंदर होता है, जो भी मोड में वो लोग करते हैं, ये इनकन्वीनियंट होता है। 56% कहते हैं, और लगभग 57 ये कहते हैं कि अनकंफर्टेबल भी है। और 64% ज्यादा परसेंट आदमी कहते हैं ये अनसेफ है। वो लोग जो रेगुलर मोड पे ट्रैवल कर रहे हैं सिटी के अंदर, उनका जो अर्बन का जो मोबिलिटी हो रहा है, 64% सिटीजन्स ये कहते हैं कि दे आर अनसेफ। ये स्थिति है आज के दिन में। तो इसमें अगर एक मोटा मोटा आइडिया लेना चाहेंगे कि इसमें क्या है, जर्नी फील अनकंफर्टेबल में क्या क्या सब कैटेगरीज हम लोगों ने लिए हुए थे। जैसे कि ये सारे हैं, व्हीकल्स आर टू क्राउडेड, स्टेशंस और स्टॉप्स, जहां स्टॉप पॉइंट है वो भी क्राउडेड है। और ये हम लोग चढ़ने के लिए, गाड़ी में उठने में हम लोगों को दिक्कत होता है। व्हीकल्स आर वेरी डर्टी। जो लोग अनसेफ बोल रहे थे, उसमें क्या है, हरासमेंट और थेफ्ट का भय रहता है। कहाँ ना, पोस्ट पे, जहाँ स्टॉप पे, जहाँ हम लोग गाड़ी के लिए वेट करते रहते हैं। लगभग 28% सिटीजन ये कहते हैं। और जो स्टाफ्स हैं, अगर सिटी बस या कोई भी जो मोड ऑफ पब्लिक ट्रांसपोर्ट होता है, वहाँ उनका जो स्टाफ्स हैं, वो लोगों का रूड बिहेवियर भी होता है, ये 16% आदमी कहते हैं।
Sir,
Oh,
sorry for interference, sir. Sorry to interrupt you. Sir,
yes,
please
yes.
see the timing. We are crossing the time
Yeah,
limits.
yeah. I will take another 2-3 minutes only. एंड ये स्थिति है। अगर हम लोग ये इसमें जाएंगे तो हम लोग जो मॉडल तैयार किए हैं इसका जस्टिफिकेशन क्या है? वी हैव टेकन वन कम्युनिटी, दैट इज ऑटो रिक्शा कम्युनिटी, बिकॉज वी सॉ दैट इन भुवनेश्वर सिटी इटसेल्फ almost 45,000 registered auto rickshaw are there, and it is if you will see approximately 20,000 active auto rickshaw are operated in the city. So we have taken that community. Why we have taken that community? Because these peoples are everywhere in the city और इनका क्राउड इतना ज्यादा है, ये लोग ट्रैफिक कंजेशन ज्यादा करते हैं, ये लोग हर जगह में पहुंच सकते हैं, ये लोग का सबसे नॉन प्रोफेशनल होते हैं, स्किल्स इन लोगों का सबसे कम होता है। तो ये एक बहुत बड़ा मुद्दा था जिसको हम लोगों ने ये कम्युनिटी को लिया। अगर हम सिटी बस कम्युनिटी को लेता, हम लोगों को ज्यादा से ज्यादा 15-20 या 40 व्हीकल मिलता या 100 व्हीकल मिलता, तो वो 100 व्हीकल को लेके हम लोग एक मॉडल नहीं कर सकते हैं। लेकिन ये आप कोई भी सिटी इंडिया का देखेंगे, बहुत सारा नंबर्स होगा ये ऑटो रिक्शा का। सो इसमें अगर हम लोग एक उन लोगों का जो ट्रेनिंग किया था, 1006 ऑटो रिक्शा ड्राइवर्स लोगों को लेके ये मॉडल तैयार किया था, जिसमें हम लोग का ये एनालिसिस निकला था कि उन लोगों का जहाँ ट्रेनिंग हम लोगों किया था, फर्स्ट टाइम ये लोग कभी ट्रेनिंग अटेंड किया नहीं है। 85% एमवी एक्ट जो हम लोग 2 साल हो गया किए हैं, 12% ऑटो ड्राइवर्स को पता है। दिस इज द कैपिटल ऑफ द स्टेट। गुड समरिटन लॉ के बारे में 2% ड्राइवर्स को पता है। इमरजेंसी रेस्पॉन्स वो लोग कभी लिया ही नहीं है, 1% बोल रहे हैं कि हम लोगों को पता है। तो ये स्थिति है सिटी ड्राइवर्स का। अगर ये हम देखेंगे केस स्टडी का मॉडल में, अगर देखेंगे हम लोगों का गोल ये था कि हम लोग सिटी में 0 फैटेलिटीज करेंगे, फास्ट रेस्पॉन्स को बहुत ज्यादा फोकस करेंगे, क्योंकि फास्ट रेस्पॉन्डर क्रिएट करेंगे यही ऑटो रिक्शा कम्युनिटी को लेके, और वो एक टास्क फोर्स के हिसाब से काम करेगा। उनको ड्राइविंग बिहेवियर के ऊपर ट्रेनिंग देंगे और कोऑर्डिनेशन रखेंगे ट्रैफिक, पुलिस, हेल्थ एंड ट्रांसपोर्ट डिपार्टमेंट के अंदर। विदाउट पार्टिसिपेशन ऑफ ऑल डिपार्टमेंट्स हम लोग कोई भी काम नहीं कर सकते हैं, ये खास करके रोड सेफ्टी के अंदर। ये स्टेप्स हम लोगों ने तैयार किया था। पहले तो हम लोग आइडेंटिफाई किया हम किस ग्रुप को लेंगे, हम ऑटो रिक्शा को लिया, क्योंकि द पॉपुलेशन ऑफ ऑटो रिक्शा ड्राइवर्स इज मच मोर एंड हायर देन एनी अदर मोड ऑफ ट्रांसपोर्टेशन। इसमें हम लोग एसोसिएशन को कांटेक्ट किया, की ऑफिसर्स ट्रैफिक का एंड पुलिस को कनेक्ट किया, हेल्थ डिपार्टमेंट का जो हेड्स हैं उन लोगों को भी शामिल किया, आरटीओस को शामिल किया, और म्युनिसिपल कॉर्पोरेशन को भी हम लोगों ने शामिल किया। इसके बाद हम लोगों ने पहले अथॉरिटीज लोगों का एक कैपेसिटी बिल्डअप किया रिलेटिंग टू बेसिक रोड सेफ्टी का रूल्स क्या है, इमरजेंसी रेस्पॉन्स का क्या स्थिति है, गुड समरिटन लॉ का क्या स्टेटस है। बिकॉज मैं ये एक कहना चाहता हूँ कि एक डिस्ट्रिक्ट में कटक में हम लोग 570 डॉक्टर्स को गुड समरिटन लॉ का ट्रेनिंग दिया। हम लोगों का ये ऑब्जर्वेशन है कि ओनली 3% डॉक्टर्स आर अवेयर अबाउट गुड समरिटन लॉ। ये स्थिति है। तो गुड समरिटन लॉ का उनको बताया, राइट्स क्या है कि गुड समरिटन का वो भी पता नहीं है। बहुत सारे पुलिस वाले हैं जो कि गुड समरिटन को उतना जो देना चाहिए उनको वैलिडिटी वो नहीं देते हैं। गाइडलाइंस ऑन रोड सेफ्टी ऑफ स्कूल चिल्ड्रन उसका ऊपर भी देंगे। देन वी हैव प्रिपेयर्ड ए मॉडल फॉर ड्राइवर्स, जिसको कि हम लोग टास्क फोर्स बनाएंगे सिटी के अंदर। तो ये सारा चीज ये पॉइंट्स हैं जिसके ऊपर हम लोग उनको ट्रेनिंग दिया और उनको तैयार किया। वो सिटी के अंदर वो लोग मूव करेंगे ये ट्रेनिंग के बाद। तो इसमें क्या होगा कि कोऑर्डिनेशन भी हम लोगों का एक मैकेनिज्म होना चाहिए कोऑर्डिनेशन का। इसमें ऑटो ड्राइवर्स लोगों का जो डाटाबेस है वो रेडी रहना चाहिए, कॉन्टैक्ट डिटेल लोगों का रखना चाहिए। ये जो कोऑर्डिनेटेड डिपार्टमेंट्स का रहेगा कोऑर्डिनेशन, उनके अंदर हम लोग ये डिसाइड करना चाहिए कि ये सिटीजन्स का सेफ के लिए हम लोगों को कुछ कॉन्टैक्ट डिटेल्स हर जगह में, हर ऑटो, हर बस स्टॉप में या ऑटो स्टॉप में ये उसको लगाना चाहिए। पार्किंग स्पेस हम लोग को स्पेसिफाई करना है कि वो लोग कहाँ पार्क करें, whom टू कंटैक्ट, अगर कुछ होगा तो किसको कंटैक्ट किया जाएगा, किस चीज के लिए किसको कंटैक्ट किया जाएगा। कुछ रिकॉग्निशन के लिए भी मैकेनिज्म हम लोग करेंगे। अगर अच्छा काम हो, कोई भी हमारा वो ऑटो ड्राइवर्स के अंदर कुछ अच्छा काम कर रहा है, उसको हाउ विल रिकॉग्नाइज देम। और ये जीपीएस एनेबल हम लोगों को ऑटो रिक्शा में करेंगे तो हम लोग ट्रैक उनको कर सकते हैं, और उसका मंथली रिव्यू होना बहुत जरूरी है। आउटकम ऑफ द मॉडल, ये सारा आउटकम हम लोगों को होगा, क्योंकि एक सिटी टास्क फोर्स बिल्डअप हो जाएगा, जिसको कि ये सारा रिलेटेड डिपार्टमेंट ट्रैक कर सकते हैं, यूज भी कर सकते हैं। स्कोप क्या है इसमें? यूटिलाइज एज ए गुड इंफॉर्मेशन सिस्टम, हम लोग इसको यूटिलाइज कर सकते हैं। पुलिस आगे चल के अपना इंफॉर्मेशन सिस्टम के तरह यूज भी कर सकता है। बॉस कैब को भी इंटीग्रेट कर सकते हैं, पैसेंजर फेयर को हम लोग स्टैंडर्डाइज कर सकते हैं, डेंसिटी जहां हो रहा है, कहाँ कम कहाँ ज्यादा, इसको भी हम लोग मैनेज कर सकते हैं और मॉनिटर भी कर सकते हैं। और एनकरेजमेंट के लिए हम लोगों को ये करना है कि हम लोग कुछ अवार्ड एंड अप्रिसिएशन, जो अच्छा काम कर रहे हैं, गुड समरिटन, रोड एक्सीडेंट विक्टिम्स को लेके पहुंचा रहे हैं, उनके लिए हम लोग क्या अवार्ड एंड अप्रिसिएशन कर रहे हैं। और स्पेशल कैंप्स भी हम लोग रखें, ताकि क्या होगा कि हम लोग उसमें जो डिफिकल्टीज अराइज हो रहा है ऑटो ड्राइवर्स के लिए, डॉक्यूमेंटेशन को लेके, इंश्योरेंस को लेके, कोई आरटीओ रिलेटेड को लेके, तो उसी कैंप्स के अंदर हम लोग कुछ वो करेक्शंस मेजर हम ले सकते हैं। तो दिस इज ऑल अबाउट द मॉडल we have piloted recently 1 month back. So this is all about the presentations. Thank you.
Okay. Any questions to Mr. Panda?
Afternoon, sir. Arvind Jain, SC PWD. Sir, your presentation is dealt with the sustainable urban safe mobility, participation of public transport, and integration of local resources. Probably, I think what I feel we are off the track of what has to be presented as per the sustainable urban safe mobility and public transport. So in concluding remark or concluding query, I just want to ask, what is that in 1 or 2 lines, sustainable urban participation of public transport?
इसीलिए कि ये
Which we have not particularly more discussed rather than the other points we have already taken care of in this presentation. Kindly in 1 or 2 lines, because we are taking time.
एक्चुअली दिस मॉडल हम शुरू में ये बोले थे कि कॉस्ट इफेक्टिव एक बहुत बड़ा फैक्टर है। हम लोग ऐसा मॉडल यूज करें जो सस्टेनेबल वे में, लॉन्ग रन में उसको हम लोग इम्प्लीमेंट कर सकें। तो अगर ये जो लोकल ट्रांसपोर्ट होता है, जो कि हम लोग का लोकल अथॉरिटीज के दायरे में रहते हैं, इनको हम लोग अगर इस मॉडल में यूज करें तो एक लॉन्ग टर्म कॉस्ट इफेक्टिव वे में इसको हम लोग यूज कर सकते हैं। और उनको वही लोग, दे आर द रोड यूजर, और उनको ही हम लोग रिफ्रेश करके ये इसको हम लोग क्या है कि जो आज के दिन में हम लोग जो डिफिकल्टीज फेस कर रहे हैं, ये डेफिनेटली डे बाय डे मिनिमाइज होते जाएगा। दैट इज द रीजन आई टोल्ड दैट इट इज ए सस्टेनेबल मॉडल, एंड इंटीग्रेट हम किए जा रहे हैं लोकल ट्रांसपोर्ट, जो पब्लिक ट्रांसपोर्ट है।
That is what I just want to know. We have not included the things BRTS and MRTS and metro and all these public transport system as a safe mobility.
Yeah. Actually, there is. I missed
Can be included
two, three batch because of the time constraint. तो उसमें हम लोग स्कोप ये रखे हुए हैं कि हम लोग उसमें सारा को इंटीग्रेट कर सकते हैं, लेकिन दिस इज ए पायलट मॉडल, इसीलिए एक ही कम्युनिटी को हम लोगों ने लिए हुए हैं। तो हम लोगों को सारा कम्युनिटी को इंक्लूड करना है, नहीं तो नहीं होगा। तो पहले हम लोग अगर नहीं तैयार करेंगे तो दूसरा कम्युनिटी को हम लोग इंक्लूड नहीं कर सकते हैं।
Thank you, sir. Thank you.
Anybody to ask anything else, or should I invite my another speaker? Sir, thank you much, Pata sir. It was a very comprehensive lecture you have taken on the urban mobility and safety, sir. Quite informative. And sir, I thank you very much for sparing your time for CPT for presenting your lecture and educating us, sir. Thank you, sir.
Thank you, sir. Thank you. It is my pleasure, sir. Thank you very much.
And now I invite Professor Srinivas Rao for presenting papers on trends and opportunity for infusing AI into new generation intelligence transport system. Srinivas Rao, sir, you are there.
Good morning, friends. Am I audible?
Yes, you are audible but not visible.
No, we are visible from this side. Now, sir?
No, not
You
yet.
are
not
audible
yet.
and visible both. Please carry on, continue.
Yes, sir. Okay. So let me share our screen. Can you please confirm our screen is visible? The PowerPoint
Yes,
screen.
it's okay now.
Okay, thank you. So
Make
let us
it in
introduce
presentation.
ourselves. I am Dr. R. Balaji Ganesh, doing postdoctoral research in the Department of Computer Applications in National Institute of Technology, Trichy. And my research scholar, Mr. V. Srinivasa Rao. We both are doing research in the AI technologies plus transportation systems. So that we call it as intelligent transportation systems. And we are doing our work under the mentorship of Professor Michael Aruk. He is Professor, Department of Computer Applications. So Mr. Srinivasa Rao will start the session with a few slides. Then I will continue with the case studies and what are all the experiments that we have done. That I will explain. Let us start with the introduction. I'm handing over to Mr. Srinivasa Rao.
Good afternoon to everyone, sir. So today we are presenting a 4th National Conference on Traffic Technologies, Central Academy for Police Training, Bhopal. So now we are going presentation of trends and opportunities for infusing AI into new generation intelligent transportation system. So we are observing AI in our daily life. Nowadays, we are seeing major advances in artificial intelligence, which brings out an ascending implementation of computer vision in real life. And the usage of autonomous vehicles will increase in future. So it is predictable that autonomous vehicles will set off commonplace in the next 10 years. It is challenging to AI developers. However, with the increasing demand, the challenges to computer vision in autonomous vehicles are also growing. Without human operator vehicles requires precise pattern recognition and huge amount of computing power to drive independently. So that's why it has become popular by achieving object detection in traffic scenes. And now we see we are now about 2022. The 3 AI trends we'll be talking about. They are general artificial intelligence, decision intelligence, and democratization of AI technology. So this technology brings out a development of AI-based vehicles by large companies and research firms. At the beginning of every year, the large technology companies and research firms analyze the current trends and forecast a further development areas and prospects of the over next 5 to 10 years. And one of the limitations to overcome by this is a traffic congestion. That the traffic congestion causes delays that translate into billions of dollars in losses every year around the world. And there is no lack of coordination among the vehicles. The primary reason for traffic jams are motor vehicles and their lack of coordination among themselves, traffic monitoring and controlling infrastructure. So it will address by autonomous vehicles. And next, The traffic problem causing us to problems in health and nature habilitation. So the traffic problem is caused by having more vehicles than the capacity of the roads. This causes pollution and delays in reaching the destination on time, and thereby causing health problems, mental difficulties, and stress to the commuters. It is purely human based centric. So there is a lack of proper procedures due to the fact that it is purely human centric, which leads to a lot of misconduct and coordination. Now come to the next point. Intelligent transportation system are essential tool for predict traffic. So intelligent transportation systems are essential tool for traffic planning analysis and forecasting that can utilize the huge amount of traffic data available nowadays. So traffic forecasting is the estimation of traffic conditions in the future based on historical data. So traffic forecasting is the estimation of traffic conditions in the future based on historical data. The examples of traffic parameters and events that are estimated: traffic flow, traffic speed, density, travel time, congestion, and incidents. These are the under all the traffic historical data. And next come to the rules are emerging to control traffic using AI. Still, there are no proper rules and methods for controlling traffic. So far, the police system only has been managing to control the road traffic by coordinating the common road users during the peak hours of traffic. So that's why we are introducing AI system are deployed to sense the vehicles and movements. So these systems are capable of sensing the road environment for automatically detecting the co-vehicles, roadside units like traffic signs and road topologies to navigate with the help of navigation map. Then the vehicle communicate using V2V, that is vehicle to vehicle and vehicle to infrastructure, to exchange information. How they can exchange information? The sophistication in the recent vehicles can connect with other vehicles, that is called vehicle to vehicle, and also with other units, vehicle to roadside units or vehicle to other infrastructure of transportation system, to exchange the real-time data over internet. So this paves way for a developing social internet of vehicles in real-time traffic monitoring and control system. So the traffic monitoring is getting automated. So then the extensive application of AI has induced process automation, leading to pioneering industrial solutions. And the Ministry of Electronics and Information Technology, that is called MITI, Government of India, launches India AI's Compendium. The AI virtually and predominantly present in every industry and individual. So this is an overall architecture for a road transportation system. So here we're taking the cameras, traffic signals, some vehicles. These are the traffic control, traffic information hub. This is the travelers or commuters. This is the transients. This is the emergency. Any information taken by the emergency means the very VIP vehicles, ambulance, fire extinguishers, etc., etc. So this is the overall architecture for the transportation system. And next, the hottest topic in the world right now is artificial intelligence. Perhaps the hottest topic in the world right now is artificial intelligence. When people talk about this, they often talk about machine learning and specifically neural networks. So the artificial intelligence makes it possible for machines to learn from experience. For example, chess playing, computers to self-driving cars using a deep learning methods. So AI makes it possible for machine learning from experience. So the computers are recognizing the patterns by training the large amount of data. Using these technologies, computers can be trained, accomplish a specific task by processing large amounts of data and recognizing patterns in the data. So the AI is making its significance in most of the major sectors these days. The AI is a comprehensive domain of computer science that deals with a variety of use cases for enhancing computability. AI enhances the manufacturing capability for product level autonomous vehicles and its allied areas. So nowadays, AI has gained more popularity due to emergence of deep neural networks and its cognizance due to the computing capability of graphical processing unit. So AI enhances the manufacturing capability for product level autonomous vehicles. So now my co-author, Dr. Balaji Ganesh, will continue the remaining session.
And good afternoon to you all. Now I am going to present how AI will give you the next level of transportation systems, that is intelligent transportation systems. How can we modernize the infrastructure which is present nowadays, right? We have roads, vehicles are all moving in the road, and how can we modernize it with the existing infrastructure? There is no need to go with more cost, more budget. There is with very few trainings for the police personnels. How can we infuse this artificial intelligence into these transportation systems? That is the main agenda of this paper. And basically, this artificial intelligence focuses on learning from experience. And as we have lots and lots of traffic data being generated nowadays, and how can we use those traffic data to generate deep neural models, right, that we call it as neural network models, to learn from the experience. Say, for example, consider a scenario in a junction at peak time and in a weekday and peak hours, the number of vehicles will be more. Right? So the type of vehicles will also be different. It is diversified. So we are generating a neural network model that can be deployed in that place, which can count the number of vehicles. That will be given as information to the traffic infrastructure managers and also police personnel to redirect the traffic. Suppose if a traffic jam has happened in a place, so this neural network system can give useful insights to different stakeholders, including commuters, police personnel, infrastructure managers. That can be very much useful for all those personnels. And this is the full power of AI. That is, we are leveraging the full power of AI to count the number of vehicles in a real traffic scenario, right? That too with the very limited infrastructure, right, which is available with us, right? So that is the main agenda of this paper. And what is the components in our AI system? We are discovering the patterns in the traffic, and we are predicting what will happen, and we are justifying our stand, whether to divert the traffic or to take a different stand. We are justifying it, and that information is being passed to the police personnel or other managers, and they will act upon that. And our AI system will keep on learning. A continuous learning is required in all our systems. Our AI system will keep on learning from the past experiences. So there are so many theory concepts which is related to the features of AI and all those things. We have included these slides for continuity and also a completeness, right? And AI is the emerging technology for more startup companies or researchers to evolve themselves, right? And AI is an emerging area, and it's very easy to learn and get trained. Suppose if a police personnel who is from a different background may get panicked to learn the new technology. It's not so big thing to learn. Right? So every police personnel can learn these technologies very quickly, right? And we are making it in such a sense that it can be learned so quickly in the existing infrastructure. Say, for example, we are developing an embedded GPU kit, just like a plug and play device. Right? So you can see it here in my screen. This is just a handheld plug and play device. Right? So now we have programmed this device to detect the vehicles in real time. Right? So just with an IP address of a camera, this simple kit can detect the movement of the vehicles and classify them. And the main feature of this kit is it can detect the vehicles even at night time. Through the headlight pairing mechanism, this can count the number of vehicles. So by our mathematical model will give you the total number of vehicles, that is the traffic density. So I will complete within 5 to 6 minutes, only very few slides. The AI endeavors which are all prevalent across our Indian states. So, but the drawback is how these technologies are being utilized either by the police personnels or by the infrastructure managers. Are they aware of these technologies? It's not at the, we can't say it's the learning skill of the police personnel or somebody else, because it is the technology plus the training. So how we are infusing these technologies to the police personnel? Suppose if we give it just like a mobile app, right? A mobile app that can read the number of bike riders with and without helmet. Right? That will be very much useful for the police personnel. So as AI is pervasive in nature, we want to bring it down in a smaller size of different use cases. One of the use cases is detecting the helmet. Right? As similar to that, we can also count the number of vehicles and find the traffic density in a particular place, toll gate plazas, so many things. Right? So red light violation detection, it's also one of the major area. And the accident detections, route optimization for emergency vehicles. Right? Presently, this kit, what I have shown to you, is also gives you a route planner. Right? You might have seen Google Maps, it is giving a route planner with the travel time and the number of nodes. As similar to that, we have also kit that can connected across all the traffic cameras. So what we try to present from this paper is AI is pervasive in nature, both at the national and the international level. Many state and transport corporations are implementing AI, but the problem is how far it is being utilized. Say, for example, a traffic camera has been fitted in a metropolitan city, and how it is being used by the police personnels or infrastructure managers, how far they are utilizing, how far they are acquainted with that usage. Suppose if we bring it down very simpler, just like a mobile app or something, that will be very much useful for them to use. So traffic forecasting, that's also very much popular, and there are different AI models are prevalent nowadays. And what is the objective is we want to bring the AI into smaller size with the existing infrastructure. Nowadays, you may see very high cost cameras or speed guns are being installed, and due to some poor maintenance of that, it is not fully utilized. Right? Whereas when we install some embedded GPU kits that can grasp the information on the spot and give it to the police personnel immediately, then the police personnel can act upon immediately. That is instant inferencing from the spot, right? That is what we are focusing on. And I'm concluding, sir, just the final slide. Right. What we are expecting from the department or from the ministry or from the police personnel is we are highly tech-oriented people. Right. We don't have enough knowledge with respect to the situations prevailing in the on-spot practicals. So if we collaborate with some of the personals from the police department, we can leverage the potential of artificial intelligence fully. So we are developing so many kits, that is handheld portable kits powered by the AI technology, which can be used for variety of use cases, including helmet detection, speed violation detection, red light violation detection, that can be done on the spot instantly. That is the power of our kit. Now we want to further propagate the power of this embedded GPU kit to all the police personnel and also highways authorities. I hope this forum will facilitate us to do further. And I thank you, the personals, for giving us this opportunity to deliver this session. Hope we are expecting that this forum will also be connected for a long time to share our ideas and to share our prototypes and initiatives for the various traffic problems. Thank you all. Thank you. Any questions from audience, please? Sir, please allow the audience to ask a few more questions. Just one or two questions at least, if possible.
Yes, please. I've unmuted all of you. Please, you can go on with your questions. It was quite a technical topic. Use of AI into controlling the traffic to make life easy. Please, somebody to come forward with this question.
Hello. Hello. Yes, sir. You're audible, please.
What will be the cost?
Yes. Actually, expected this question. We are giving this cost in different versions. The least one, which can simply detect whether the bike rider is wearing a helmet or not, which will be around 20,000 rupees. And this kit, which I'm showing you rightly, right, which cost around 1.25 lakhs. So it's all from NVIDIA, and we are running our own models to do so. So we are seeing a lot of police personnel are standing in the very hot summer to deduce the vehicles and to detect the violators, whereas this kit will help them to achieve their target. Right. You can have a note of this kit. This is a GPU powered kit. NVIDIA Jetson AGX Xavier. It's have 512 CUDA core graphical processing unit, and 8 cameras can be attached to this device simultaneously. Right, 8 cameras at a time.
Thank you. Thank you.
Sir, Manu, maybe sir, anything you want to ask here, and you have raised your hand.
Will this be for application like a black access, or frequently this one kit will be enough for the junction?
Yes, sir. Actually, we are deploying a deep learning model into this kit based on the use case requirement, say to count the vehicles, or to detect the bike riders without helmet, or to detect the accident zones, or red light violation detection. Based on that, we will give you the specific kit, or a kit can do multiple tasks simultaneously. Because the deep learning model that we are deploying is called as multitasking neural network. So that can perform multiple tasks.
Thank you. Thank you.
So thank you very much. It was a great effort by Sir Balasubramaniam and Balaji Ganesh, you have really made the use of AI for the transport system, how to manage, how to make transport system easy. So no end to it. You have really developed a very good product, and it was a great effort by you to propagate about that over here.
Yes, sir.
So
We are
thank you.
expecting further support from you, sir, to make it as a final product that can be deployed.
Of course, you will definitely find that help from our side also. So thank you very much, Professor Srinivas and Mr. Balaji Ganesh, for sparing your time for CAPT. And now, to end up with this session, there is a last presentation from the side of Caltron. Mr. Srijit CS, he is technical head from the Caltron. He is also going to share one Peltrack solution as a safety measures for the vehicle for the vehicles and all. Mr. Srijit, are you there?
Sir, is it audible, sir?
Yes, you are.
Sir, good afternoon. I will going to the presentation right now. Can I share the presentation, sir?
Yes, please. By the time you share a presentation, let me give a brief introduction of Mr. Srijit to you. Mr. Srijit JS, he is a senior project executive traffic signal division from Caltron, that is Kerala Electronic. Kerala Electronics has worked a lot with the government of Kerala to produce some very good technological item for the solution of this traffic and safety. And he is working as Q had developed a new low-cost pedestrian controller and mini controller, and developed a web-based asset management software. He has been working at IITM project of Cochin Smart City, and he's got many experience about these technologies and all. So we have got the opportunity to listen to him today. Mr. Srijit, please go on.
Sir, good afternoon all. I am going to present on small device that can have better pedestrian utilization of the road and safety. I am directly going into the product. First of all, Peltrack is a solution for traffic signal. This solution was developed from the traffic signal division for end road users. So the peculiarity of this traffic signal solution is that pedestrians are facing a lot of issues when they are coming to the roads. But the solution we will provide should be a stable and a safe one. Considering that point, we have introduced a traffic controller called Peltrack, and it is a microcontroller based device which has the peculiarity that we can program the minimum vehicle time and pedestrian mean time. And these two peculiarities we have given. Why? Because I will, in this slide, you can see on the left-hand side how a pedestrian Peltrack controller works. Here, one push button boxes will be in the side of the road where the pedestrians can push on that, and there they will see the wait signal. When a vehicular phase is there, it will be terminated with the amber time, and the pedestrian green signal will go. So after that, after the pedestrian crossing the road, there should be a minimum time for the pedestrians to cross the road. We can program that time. And second thing is that after crossing the road, the green signal for the vehicles will come. There comes the second option for the controller is the minimum vehicular green period, where if a pedestrian crosses the road, thereafter one person comes and pushes again, there a queue will be built up. So to evacuate the queue, what we do is we will give a minimum vehicular green time. So if a pedestrian comes and pushes, after the pedestrian phase, immediately he will not get the pedestrian green signal, walk signal. There he will get a minimum wait time. That wait time is a programmable one that is for the queue escalation of the vehicles. That is the minimum vehicle green time. That is the two systems we have introduced in this system. And second thing, considering the safety of the passengers, after the pedestrian time, there will be a alarm alert system also. So at the end of the pedestrian end time, there will be an alarm alert. That alert can alert the pedestrians that the pedestrian time is going to end. That facility is in our system. And the push request registration facility that I have earlier mentioned, that is for the vehicular minimum green time. That vehicular minimum green time, the push will be registered in the controller and it will be executed after the minimum vehicular green time. That will help the queue formation of the vehicles in the road. That will help to reduce the queue formations in the vehicles in the road. That is the option. That is the facility. This system has been implemented in Cochin Smart City in 4 junctions, and in Kerala, in the capital city also, some installations are also there. It will be useful for the public to have public and the vehicles to have better utilization of the time using the system. Now, I'm going to present the future development that is going to be happen in the same system. We are working on the system and it is on at the process of coming out. The next is the passengers can be dictated in the mid block. If a pedestrian has crossing the road, if the pedestrian time is coming to an end, if the pedestrian is at the mid, we can use the cameras and trigger the controller to extend some time. That is the next option we are adding to the ultra controller. Other options for the pedestrian safety we can add is we can provide the automatic gates at the both side of the pedestrian crossings, where we can close the doors using the same system. And if during the vehicular phase, no pedestrian will enter into the zebra. That is an optional thing. And the second thing, the system can be remotely controlled to a central control room so that it can be monitored from the central control room. And in case of any emergency vehicle movement or like that, we can disable the system so that if any ambulance or any railway we can stop that stop the system functioning so that we can avoid pedestrians from entering into the road, so that the system will be in a disabled mode. And the same detection cameras we can use to use some event detections also in the system, same system. This is meant to get a better result in the road. The system we are implemented from the experience we got from the last years, so that we can give a better solution to the road passengers also, along with the traffic signal systems. So this is a brief of my presentation. So okay, sir.
Questions from the side of audience, please.
Yeah, yes, Mr. Srijit. This is Nataraj from Hyderabad. See, actually, you have designed very well, but actually, the number of majority of the accidents will occur due to in the highways, especially while crossing the roads.
No.
If the pedestrian safety, your gadget should be interlinked with these signage boards, huge signage boards on the highways, because the vehicles are running under 80 kilometers to 120 kilometers per hour. So they should be enough able to see that. So you must be interlinked with the concerned signage boards is mandatory, just to incorporate those features in that. That is very, very important.
Okay, we can incorporate the VMS with the signage board, VMS informations also.
So if it gets done perfectly, so I think the majority, almost 16.8% of the cases as per the MORD. So majority of the accidents are hit and run cases and pedestrian. So that will be a great help for the society.
Sir, we have considered these points also. Based on that, we have given the minimum green time for vehicles, minimum green time for pedestrians. That considerations we have considered. In the future expansion also, we have considered for the camera also. The mid block we have considered. In the middle of the road, if the passenger is present there, that should be addressed. That we have given there, sir. Your vehicle number plate, I would have valid. Ideally, there is no way. Actually, so operator have to locate the NXT border because NXT mechanism from market. NXT very provides data, but they as of now, as in they get the data from vendor and violation data. Now the police and then they are validate the API will be created. We create it, but that I don't know whether the number is correct or whether the what is the and how to verify it? You cannot from my side only pilot or not, and the number is correct. Not that it's your decision. The NIC model he has to verify the thing whether correct or not. Otherwise, it should be created. He has to delete it. No process of there. Not like to my side. When I see these topics are validated. So again, the operator or the yes, or it is created. But you use the API. It's created or under the cost of new data at the end. Then what is one has to do in your system, then he has to do in it. So from my side, I can bypass it. Bypass that. From my side, I can. Sir, any questions, sir?
Yes, Srijit, also you take care of the power supply, which is very important. In general, the power supply will be get interrupted, so that you have to include the solar as well as the battery power as an additional battery.
Actually, we in our traffic control system we have solar based system is there. We use hybrid system is there. All systems can be integrated in the system. In Kerala, we have done the installations with the solar.
Getting done at the next.
Oh.
From my side, I'm open for postal. As far as different Indian you cannot do suppose Vahan is permitting you. They are allowing you. If they provide such details, if you do, they can whitelist your so that you can request and on one transaction, you every time you request and validate with the database. I think you can push it directly. There's no need of. But they have some other purposes. Go against the ball. BAPT. No, BAPT, but still, as in one nation, one child, they don't share their database with some advantage, even whether it is a BAPT. What they will do, they will ask to push the condition data to the data to government as a policy, single interpret, one nation, and so,
Any questions, please, sir?
Mrs. Rita, you can ask a question. Please, rest of all, please keep yourself mute. So much noise is coming. Mrs. Rita, you can ask your question, please.
Then they have to pay also. They will also charge them, right? NIC also charge. NIC don't charge. For one, no yearly, no years they don't charge anything for this is a government, they don't charge.
Okay, Srijit, I think some unnecessary noise is coming, and thank you very much, Srijit, for sharing about the project and successfully implemented.
Yeah, thank you for unmuting me.
Yes.
I'm Dr. Eva Savli, medical doctor and founder of Radhi Foundation, Mumbai based. This was very nicely, specifically pedestrian safety and features what you have developed was amazing. I saw a similar concept implemented in Mumbai, but there is no alarm system where the pedestrian signal starts. We have the number of minutes which the person can see. Like it starts from 60 seconds, 59, 45, 7 seconds.
Madam, that I cannot clearly not get you. You want to increase the time, right? Hello, madam, you are talking about increasing the timing.
Yeah.
Actually, yeah. Actually, in our pedestrian track system, we have the option for increasing the pedestrian time. We can increase the time of the vehicle queue, minimum vehicle time also. We have both the options. We can give maximum of for pedestrians. We can give up to 90 seconds. For vehicles, we can give up to 150 seconds.
So it's
The time
manually
we can
operated, or it is as per the automatically AI used in a way that it is automatically gets operated. It depends upon the density of the vehicle or density of the people wants to cross the road.
So, madam, we are operating the system in AI mode also. In AI also, we will give minimum time for pedestrians. After that, AI will activate because all the pedestrians will be move in a mixed. Their speed will be different, as you know. Yeah. What we will do is we can give a minimum time for the pedestrians. After that, we can increase the time using the AI systems because it will be a practical solution. If we give the count and take the present give, it will not be a practical one in the field. We are first give a minimum time. After that, if it needed, we will increase the time. We can increase the timing use the AI systems.
Okay, Mr. Sujit, now we should conclude our this session, and thank you very much for sharing your product and about its utility and traffic domain. Thank you very much to you for spending your time and giving a nice presentation on this technology to us. And for the participant, I request we are going to end this morning session right now, and we will assemble come back again at 1500 hour. We still do have some more some case studies, some presentations are there, and correct at 16:30 we are going to start our valedictory session. In that we have invited Sri Sanjay Kumar Nirwal as chief guest, but before that our director will also join to have a course report, this summary of this conference. So I'll request all of you to please join the evening session and tell your colleagues also, because we have got the registration of some 407 different persons, different officials for this conference, but right now only 197 are there. So my humble request to all of you, please convey your colleagues also to join in the evening session, particularly for this closing address. Thank you very much to you. By the time, see you again at 1500 hours. Thank you. Please don't quit. I'll say that you please get yourself connected remotely. Thank you.
Vâng lại thì mình phải là đấy. Просто приятно, ладно. Ага. Если шапку complete, hello.
Hello. Hello.
Okay, okay, ठीक है right, sir. Okay, okay. Sir, thank you very much.
चेयर चाहिए।
हाँ सर। सर वो बोल रहा था वो माँ बोरवेल वाले का करा देते सर पेमेंट, वो बार बार कॉल कर रहा था। ठीक है।
शर्मा साहब, डॉक्टर सुब्रतो दास here.
Sir, welcome. Good evening, sir.
Good afternoon, sir. कैसे हैं?
All well, sir. Thank you.
I am not getting a video. You're not allowing video, I think, mine.
Okay. Just a minute, sir.
Sorry, I just need to.
1 minute, sir.
Yeah, sorry.
Now, sir, try if it is, I have given you the rights. I have given you the rights of presenter.
Oh, it's not coming in. No.
Not yet, sir.
No.
Just a minute, sir.
वॉइस तो आ गया, ऑडियो बट
ये कर दो, क्या नाम, राइट्स इनको दो ना, सुब्रतो दास सर को।
शेयरिंग राइट से वीडियो नहीं आ रहा है।
बुला लूंगा, टाइम पे हमारा आंसर बनेगा। सुब्रतो, डॉक्टर सुब्रतो दास लिखा हुआ है। हाँ, ये सर,
स्लाइड देख पा
प्रेजेंटेशन
रहे
आ रहा
हैं?
है।
स्लाइड देख पा रहे हैं सर?
यस सर, स्लाइड आ रही है। एक बार इसको सर पीपीटी मोड में करना सर। हाँ,
ठीक है,
इट्स ओके सर।
I need a video.
दोनों मैं समझ नहीं थी बात को। जो आपने इसकी जो भी जिंदगी में फाइंडिंग ये देखे ना कि ये आदमी तो पाएगा।
Sir, let's wait for 5 more minutes, so then we'll start.
Sure, sir. Just figuring out why my video is not coming in.
Now it's okay, na sir? Your video is still not coming.
Yeah, the way मैं कर रहा हूँ, एक मिनट से, just hold on. I'll just switch off and again come back.
Okay. हाँ यार, कोई देख, मैं प्रेजेंटर दिया तो मैं इनके बाद में जैसे खत्म होता है तो तुरंत इनको ये राइट देना होता है कि सवाल जवाब कर पाए। पहले मैंने कहा फॉर्म ऑन करूँ दो, अगले का टाइम वे देने पर है। सर लॉगिन किया आपने सर? सुब्रत सर ज्वाइन किया आपने?
Yeah. Can you hear me?
Yes, I can hear you, but your video is still.
Video is on
still.
now.
Yeah.
Now my video is on.
I have delegated to your presenters, right? Then also your video is not coming. What is
That's strange.
यार मैडम को पूछना है, ये वीडियो नहीं आ पा रही.
I think I don't know why. My settings are all right. Rachna, एक मिनट आओगे?
Sir, can you log in on from some other browser, sir? There may be some problem in the browser otherwise.
Just give me 2 minutes. मेरा वीडियो नहीं चल रहा है.
नहीं, इनका तो देखते हैं. Let's see. ये नंबर लिख इनका. से बात करना. Yes sir, okay now. Sir, it's okay now. I said try to present, share the presentation.
Okay.
इनको बोलना कि आप जुड़ गए क्या? प्रेजेंटेशन नंबर.
Fine. You can see the presentation. शर्मा जी presentation दिख रहा है?
Yes sir, आगे presentation अब PPT मोड में कर दें इसको.
ठीक है, fine. Okay.
So welcome back all the officers for this post-lunch session. Now we have with us a very eminent and very renowned speaker, Dr. Subrata Das. Before he starts, let me give his brief introduction to you because he is a highly decorated officer. Dr. Subrata Das, winner of the India's highest civilian award, Padma Shri, for his work on highway trauma care and co-foundation Lifeline Foundation, along with his wife Susmita, the only Indian to be honored with the Asian EMS Lifetime Achievement Award by the Asian EMS Council in 2015. The Times of India called Dr. Das a country best known EMS expert. He has been associated with the various projects on road safety and EMS supported by Niti Aayog and Economic Advisor Council to the Prime Minister, including being the technical head of the Road Safety Education Committee formed under aegis of Niti Aayog. He was the first in India to advocate a unified national medical emergency helpline number for highway and legislation of EMS and trauma care. Dr. Subrata Das continue to campaign for the cause of highway trauma care and EMS as a fundamental rights across South Asia. A founding member of Asian Association for EMS, he also chairs the South and Central Asia chapter. Born in 1965, Dr. Das, an alumna of Baroda Medical College, Maharaja Saji Rao University, later pursued hospital management and industrial health. Along with his wife, he was honored with the Red and White Bravery Gold Award for Social Acts of Courage in 2003. As a social entrepreneur, Dr. Das was elected as Ashoka Fellow in 2004. He received the UK-based Prince Michael International Road Safety Award in 2004, the CNN, IBN, and Reliance Industry Real Heroes Award in 2008, and was honored the role model in EMS by the Emergency Physician of India. And there are so many decorations which I've got a long list to say on. Dr. Das, I'll request you to please continue with your presentation, sir.
Sharma sir, thank you for those kind words and the very elaborate introduction. Pelatome, I want to apologize to you for being very hard to communicate with me. Unfortunately, I was at a place where communication was very difficult at one of essential utilities of the government of India and could not always reach out on phone. So my apologies for keeping you on tenterhooks. It's always a pleasure to be at the CAPT Bhopal. Unfortunately, it's a virtual thing again. I've been privileged to be there in person, and it's such a nice institute. So I'm sure kuch dino mein we'll start having in-person conferences in CAPT, and I would love to be there. Having said that, I'm going to talk on something which is quite alien to a lot of police officials. Though I suppose you read about it in the papers, but that's not the first thing that comes to your mind. Post-accident management. And I'm going to talk about how we got to it. What happened? This talk is going to be 15 minutes, so it's going to be divided in 4 parts. What gives me the expertise to talk? The 4th E of road safety, the emergency care, what exists now, and the future that we'll see at. So one of the statements that I always believe in is that there exists none amongst us who has not had to undergo the pain, either physical or emotional, of an accident involving oneself or a close associated relation. And that's very important because all of us suffer accidents, all of us see it and then say, wo to hona hi tha. Purna aage ka janam ka ye phal hai. Those things that we are very fatalistic about creates more and more accidents. I hope the slides are changing. Can you hear me? Can you hear me?
Yes, sir. Yes, sir. It's okay.
And I hope the slides are changing.
क्या आने वाला था ना, क्या नाम है यार उसका, पंकज?
Okay, as you see this slide, this slide talks about our first attempt to create a highway EMS and emergency services on the highways, a highway trauma care system. This happened because me and my wife Sushmita suffered a nasty accident in '99. Mr. Bajpayee was then the Prime Minister and he was just
हमारे यहाँ वो है ना रे, जवारा वो रहे हैं अप्रैल में, इसके बाद सीधा उसी टाइम पे जाओ.
Okay. So we created the first helpline in the country post an accident that we had. 4.5 hours we were lay on the highway with no help, 21 kilometers from home. And that's where my wife Sushmita decided that India needs a helpline. And this is a BBC clipping of our work starting off in '99. This was the first highway rescue project in the country. It was a pilot between between Ahmedabad and Surat. We stay in Baroda in Gujarat. And if you're familiar with Gujarat's geography, Baroda is nearly center between Ahmedabad and Surat. So 261 kilometers is a pilot, no government aid, no wallet biopsy, a network of utilities. And we created, as you see in this photograph, the first GIS control room ever for road traffic accidents in Indian highways. You did not have cell phones then, so there was no GPS, so it was a GIS control room. And this was the helpline board, again, 10-digit numbers, because India still did not have a short code. The national numbering plan came 3 years after our work. We took it to 5 states. We were studied at Harvard, Boston, and Tata Institute of Social Sciences in Bombay. And then a gentleman is sitting next to me here, Mr. Ramalinga Raju of Satyam. I always say history might judge him differently, but the 108 service that you see in the country is because of this gentleman. sitting on the table, and this table is where it is said that the 108 was conceptualized. We have taken our work into Sri Lanka, where if you follow cricket, Muthiah Muralitharan, Sri Lanka's biggest cricketing legend, is the brand ambassador, and we cover these colored districts across Sri Lanka in their accident helplines. Coming to what is emergency care on highways, I'll make it simple, but all of you need to understand what it is. There are 4 E's of road safety. There's enforcement, there's education, there's engineering, and the 4th E is emergency care. And that's what we pioneered in the country. Simply put it, it's emergency medical services or emergency care is by the right people at the right place at the right time and the right care. If you address these 4 things, you have addressed everything. You all see this symbol perhaps on ambulances, and there is a meaning to this. So emergency care is about early detection, which every police official can do it, because police is the one agency that is authorized by law to be at the scene of the crime. Everybody is a stranger, but police is not. Early reporting to the control room, early response, on-scene care, care during transit is very important during ambulance transfers, and transfer to a definitive care. And that is perhaps the essence of emergency services that all of you need to understand. Definitive care. So you cannot transfer, and that often happens, you cannot transfer a patient of a head injury to a community health center or a small hospital because they don't have neurosurgery, neurophysician, CT, MRI. So you always need to assess the patient and transfer him to a hospital where such treatment is available depending on the injury. We miss that out. We transfer it to some hospital which wastes time. So as people into first response, always remember you need to transfer a patient to a definitive care. Also remember, no two emergency medical services can be same because no 2 incidents are same. Always remember that you cannot copy paste. कल तो मैंने ऐसे handle किया तो आज भी ऐसे ही handle करूँगा. Victims are different, number of victims are different, the severity of the accident is different, so you need to handle them differently. Also need to understand that in emergency medical services, there is something called a trimodal pattern of death. 50% people die on the spot. Crush injuries, head injuries, a wheel of a truck going over a chest. They all die on the spot, heavy bleeding. 30% die within 48 hours of accident, and 20% die within 7 days of an accident. And my appeal to all of you is to look at this 30% and 20% to save lives. And these are avoidable deaths. In fact, it is said that when 90% of the times, when a patient is brought dead to the hospital, he or she is already dead by the time being put into the ambulance. And that makes it important to understand that 90% of these deaths perhaps can be prevented or delayed at least. Give the patient some time. And that's where emergency care comes very handy for all of us to know. There's something called a golden hour. All of you hear it. It's said in the papers. Politicians talk about it. So what is the golden hour? It's very important to understand that before I go to the next part of my presentation. It is a strategy that was developed in the United States of America. And this means getting a patient in surgery within an hour. Most of the times we think golden hour के अंदर 1 घंटे के अंदर फर्स्ट एड पहुंचा दीजिए, एम्बुलेंस आ जाएगा, वो गोल्डन आवर फुलफिल हो गया. गोल्डन आवर ये कहता है कि सर्जरी के टेबल पर, ऑपरेशन थिएटर के टेबल पर 1 घंटे के अंदर पेशेंट को पहुंचाना है. इन्वेस्टिगेशंस, एडमिशन सब होने के बाद. That is the essence of the golden hour, not just providing first aid. And this is only true in cases of bleeding and trauma. It is not in cases of cardiac arrest and other things. और ये गोल्डन आवर को मीट करने के लिए आपको 4 चीज जानना बहुत जरूरी है. प्री हॉस्पिटल केयर, हॉस्पिटल तक पहुंचने तक केयर देना चाहिए. स्पाइन स्टेबिलाइजेशन, रीढ़ की हड्डी को किस तरह से स्टेबिलाइज करें, क्योंकि अगर रीढ़ की हड्डी में डैमेज है और अगर मेरुदंड कट कर हो जाता है तो बंदा पैरालाइज हो जाएगा सारी जिंदगी के लिए. आप चाहे उसको जीप में डालिए, ट्रैक्टर में डालिए, उसे बचाना कोई फायदे का नहीं अगर वो पैरालाइज हो गया तो. एयरवे, ब्रीदिंग एंड सर्कुलेशन एंड इंटरनल ब्लीडिंग कंट्रोल, ये 4 चीज करते हुए एक विक्टिम को हॉस्पिटल पहुंचाना है, उसके इन्वेस्टिगेशंस खत्म करने हैं और ऑपरेशन टेबल पर पहुंचे, वो गोल्डन आवर में आपको अचीव करना है. दैट इज द एसेंस ऑफ द गोल्डन आवर. इट इज नॉट अबाउट प्रोवाइडिंग फर्स्ट एड. द थर्ड थिंग, आई हैव 10 more minutes, so I'll rush through this. अब क्या अवेलेबल है हमारे पास इंडिया में रोड ट्रैफिक एक्सीडेंट विक्टिम के लिए? 108 है. 2005 में जैसे कहा मैंने शुरुआत हुई थी, मिस्टर रामलिंग राजू ने इसको करवाया था, सत्यम EMRI के थ्रू. अब करीबन 28 राज्यों में ये है, 8071 एम्बुलेंसेज हैं और 904 90 करोड़ लोगों को ये कवर करता है। एंड देखा जाए तो इट्स वन ऑफ द वर्ल्ड्स बिगेस्ट ईएमएस। ये जो राज्य हैं जिसमें कलर में है, सब राज्य में, इन एवरी स्टेट देयर इज अ 10 अवेलेबल। एंड इफ यू आस्क मी, इफ यू लुक एट द कॉर्नर हियर, अवेलेबल एम्बुलेंस का जो स्टैटिस्टिक्स है और डब्ल्यूएचओ का जो स्टैंडर्ड है, India meets the WHO standards as far as ambulances are concerned. What it does not meet is the quality of the paramedics. But I take life as an incremental change, and एक दिन ऐसा भी आएगा जब हमारे paramedics, हमारे doctors जो ambulance में बैठते हैं, they will be also at par with the world standards. But today our ambulances are at par with world standards. देखा जाए तो एक गर्व की बात है कि यूएस और इंडिया के हम कंपेयर करते रहते हैं। 1961 में यूएस में एक व्हाइट पेपर निकला था और उन्हें 28 साल लगे थे, प्रेसिडेंट क्लिंटन जब वहां के राष्ट्रपति थे, 28 साल लगे थे उनको ईएमएस शुरू करने में, और आज के तारीख में सिर्फ 70% यूएस कवर्ड है 911 से। अगेंस्ट दैट इफ यू सी इट, 1999 में फर्स्ट ईएमएस हुआ था जो हमने शुरू करवाया था। आज के दिन में 88% of India is covered in 22 years. So India has done remarkably well compared to a country like US as far as EMS is concerned to address road traffic accident victims. इंडिया में एक्ट्स निकले हैं, EMS एक्ट है, गुड सैमरिटन गाइडलाइंस आप सब जानते हैं, पुलिस ऑफिशियल्स ऑल नो अबाउट दिस गुड सैमरिटन गाइडलाइंस 2015 जो सुप्रीम कोर्ट ने दिया था और जो मिनिस्ट्री ऑफ रोड ट्रांसपोर्ट एंड मिनिस्ट्री ऑफ हेल्थ एंड फैमिली अफेयर्स, फैमिली वेलफेयर गवर्नमेंट ऑफ इंडिया ने जिसको प्रोमलगेट किया है। हर नागरिक किसी को जाके बचा सकता है रोड ट्रैफिक एक्सीडेंट में, एंड देयर शुड नॉट बी एनी अरेस्ट ऑन दैट काउंट और हैरेसमेंट ऑन दैट काउंट। इंडिया में 1033 है हाईवेज के लिए, 108 सिटीज एंड रूरल एरिया के लिए, हाईवेज के लिए 1033 है। जीपीएस अभी अवेलेबल है हमारे पास, हर 50 किलोमीटर में एक 1033 का एम्बुलेंस आपको दिखता है। इंसिडेंट मैनेजमेंट के लिए क्रेन्स हैं, पेट्रोल व्हीकल्स हैं। सो देश का जो हाईवे एक्सीडेंट रिलीफ प्रोग्राम है वो काफी सुधर चुका है जब हमने शुरू किया था। सो लॉट ऑफ थिंग्स आर अवेलेबल नाउ इन द कंट्री। द लास्ट पार्ट व्हिच इज द एसेंस ऑफ दिस टॉक, and I'll spend another 6-7 minutes on this. So what is coming up new? Digital care, obviously. Digital technologies is going to drive emergency care in road traffic accidents. A patient will become the point of care. आज हमारा point of care hospital है, छोटा हो या बड़ा हो, the point of care is the hospital. एक समय आएगा जब patient himself will be the point of care, and that is where digital technologies will make the change. Artificial intelligence is the first thing that comes to mind. And artificial intelligence, आप सब जानते हैं, AI is impacting the medical world, drug discoveries, diagnosis सब में, and अभी emergency room और emergency department में भी it has started to come in. In Hungary, a lot of things are being done about AI, and one of this Hungarian ambulance service जो है OMSZ is using AI for capacity and logistic allocation in its daily operations. What AI does is, like they get 3,000 patients every year, 40 million kilometers ambulances run, so बहुत data है उनके पास. AI is being used to analyze such data, create algorithms, और जिससे हम predict कर पा रहे हैं उन लोग कि यहाँ इस जगह पे accident होने वाला है. And that makes it very important for people, for service providers के यहाँ ambulance allocate करें इस समय, I mean, सुबह के समय इस समय allocate करें, शाम के समय इस समय allocate करें, and that helps save lives because response fast होता है. So AI is a big thing. A quote from Dr. Gabor Sastro, CEO of the National Ambulance Service in Hungary, and I'll read it. AI does not know that there will be an accident tomorrow afternoon on a major two-lane road between two cities. Artificial intelligence cannot predict कहाँ और कब accident होगा, but एक statistical probability वो predict कर सकता है, और उस statistical probability पे ambulance कहाँ रखना है, emergency vehicles कहाँ रखना है, cranes कहाँ रखना है, Hungary is looking into it so that responses are faster, and very soon I'm sure India is going to use it. The second technology emerging is apps. We all know about apps, and apps are being used very regularly for road traffic accident victims. चाहे वो सिंगापुर हो, हंगरी हो, यूएसए हो. क्या होता है कि इमरजेंसी सर्विसेज में जब एक्सीडेंट होता है, एक इमरजेंसी होता है, लोग जल्दी जल्दी कम्युनिकेट करते हैं, आधा कम्युनिकेट करते हैं या कोई दूसरी तरफ आधा सुनता है. So 80% of medical errors usually happen because of miscommunication between medical staff. This has been documented. These apps and software programs are being developed to help these so that these errors can be minimized. Pulsara in US is a great app. It was developed in Montana. ये app जो है, it connects the paramedic in an ambulance to the emergency department of a hospital. GPS के तहत वो बता सकता है कि expected time of arrival कितना है, so that hospitals can become prepared to receive a patient. Things like ECG and other parameters can be sent to the hospital to guide the paramedics how to handle it, and the hospital also can be prepared. Studies of Pulsara have shown that response and treatment time decreases by almost 30% in such cases. Singapore Civil Defense perhaps is the best example globally about app being used for accident victims for cardiac arrest. What it does is it notifies volunteers. Can the gentleman be put on mute, please? The Singapore My Respond. Yeah, thank you. Singapore My Responder is a novel smartphone app and perhaps one of the best in the world. जब कभी किसी को कार्डियक अरेस्ट होता है, चाहे वो एक्सीडेंट के लिए हो, ऐसे ही हार्ट अटैक के बाद कार्डियक अरेस्ट हो, this app sends signals to all volunteers within 500 meters of that incident, and volunteers can come and perform CPR, and ambulance can get there. And the Singapore Civil Defense Force has nearly 1 lakh volunteers, and they have nearly double the number of successful CPRs using this app. A great technology of the future. American Heart Association, leaders of cardiac care in the world, has this app called Full Code Pro, again doing great work on the CPR event tracking in accidents. Video games. Now, video games are being used for learning purposes in emergency medicine. आप सब video games खेलते हैं, but in emergency care it's coming up big time. A lot of things in emergency care is based on simulation. And to reduce the cost of simulation, क्योंकि सब जगह सबको इकट्ठा करना पड़ता है एक simulation lab में और सबको पढ़ाना पड़ता है. COVID has changed that scenario, and emergency workers and paramedics and doctors need to learn new technologies. So gaming features are being merged into digital health, and they are being used to emergency sector. Level X, a Chicago-based startup, is a classic example. They have come up with something called Airway X, which gives paramedics and doctors real scenarios. और उस real scenario पे वो games खेलते हैं, वो challenges देखते हैं, कितना damage हुआ है patient का, bleeding कितना है और कितने speed से उसको airway management करना चाहिए, risk क्या है, patient का vital signs क्या है, pulse क्या है, blood pressure क्या है, सब कुछ किया जाता है, and they do it on a video game to practice, and it can be practiced at home, sitting in a metro train, sitting in a bus. So you don't have to now go into a simulation center to learn newer techniques. And the video games are being really coming up, and I'm sure India will get their video games soon. Portable point of care, diagnostic devices, आपने सुना होगा, हाथ में आ जाए इतना छोटे, आजकल ECGs आते हैं स्मार्टफोन से, 12 रीड ECG होता है. iStat from Abbott, which is a big company into diagnostics, they have come up with an iStat जो blood testing कर सकता है, वो results doctors को भेज सकते हैं, वो doctors interpret करके ambulance के doctors and paramedics को बता सकते हैं क्या करना है क्या नहीं. Ultrasound जो आप hospitals में देखते हैं, now ultrasound is no more being done in developed countries just by radiologists. Small ultrasound devices are in the hands of paramedics in ambulances who can do ultrasound and figure out internal injuries kya hai, internal bleeding kya hai. And very soon, I'm sure India is going to change its rules about that, and such ultrasound devices will be available in ambulances. One of the last things I want to talk about is medical drones, and medical drones are delivering care from air. In Africa, it's doing a great job in Zambia, in Zimbabwe, where medical supplies, right from sanitary napkins to everything is being transported into far-flung areas. AEDs, you must be reading about it. आपके पास WhatsApp में आता होगा. AED drones जाते हैं, and they even give prompts on how to give cardiac shock, electric shock during a cardiac arrest. So technology is going around. India में AED drones अभी भी आए नहीं हैं, but till that time comes in, I'm sure we all need to understand this simple statement made by Humanities University of USA. And I'll quote it: emergency services of the future look more data-based, efficient, streamlined, and quicker than ever before, while considering the limitations of caregivers who are paramedics and drivers and ensuring the needs of the patient. So it's getting more efficient, more streamlined, and quicker. Till these things happen, however, CPR is the most important thing that all of us should learn to prevent a cardiac arrest in an accident victim due to blood loss and other injuries. There's a photograph of me playing KBC as an invitee with Tapsi Pannu, and that's my son on the floor demonstrating to Mr. Amitabh Bachchan CPR क्या होता है. And Mr. Bachchan has promised us that he'll look into the possibility of taking CPR into Bollywood. Thanks a lot for the time. Sharma ji, once again, apologies for last minute confirmation. Thanks a lot.
Audience, they are welcome to ask any questions if they have.
Yes, sir. मेरा एक सवाल है सर कि आपने जो गोल्डन आवर वाली जो बताया बहुत अच्छी बात है. इसके लिए कोई एसओपी भी बनाई है सर?
सर इसका एसओपी बनाया हुआ है. आप अगर विस्कॉन्सिन यूनिवर्सिटी डॉक्टर ब्रूक लर्नर, ब्रूक इज BROOKE, लर्नर LERNER, उनको गूगल करेंगे तो वो आपको एसओपी पता चल जाएगा कि गोल्डन आवर क्या होता है, गोल्डन आवर में क्या करना चाहिए. इट्स अवेलेबल ऑन द नेट, फ्री सर, फ्री पब्लिकेशन है. डॉक्टर ब्रूक लर्नर, विस्कॉन्सिन यूनिवर्सिटी USA. गोल्डन आवर गूगल कीजिएगा सर.
ठीक है सर. थैंक यू सर.
वेलकम सर.
Anyone else, please? Sir, really time was very short and your presentation is such a fantastic one that time should have been there to listen to more. You have given a very good data about this 108, background of the 108, thereafter the emergency services in the foreign countries used different type of apps, and about the golden hours, that it is not that you are giving the first aid in the golden hour. It is of course giving making the patient to reach to the operation theater. Sir, a very good presentation, sir. Thank you very much to you, sir. Thank you, sir.
Thank you, sir. Pleasure to be here again. Stay safe.
And now next, I'll invite DYSP Ujjwal. Ujjwal Singh. Ujjwal sir, are you there?
Are we audible?
Yes, yes. Ujjwal sir, you are audible.
Good afternoon, sir. Sir.
Yes, sir. Ashwini Bagga, sir. Please go on.
We have Ujjwal Sharma ji. She's Deputy SP and been deputed in the State Road Safety Cell Department of Transport and Road Safety. And today we'll give the small presentation about the initiatives that is being taken by the government of Rajasthan. So I'm sharing my screen. Is it visible?
Yes, it's coming. Just give 1 second.
Yeah. So these are the best practices that is taken in the field of road safety by the government of Rajasthan. So the slide is changing.
Yes, Mr. Bagga, your presentation is coming very well.
Okay, thank you. So in this presentation, we'll be talking about the road accident scenario in Rajasthan in very brief, institutional framework which is prevailing in Rajasthan, the initiative, the Supreme Court Committee guidelines that we are following, the initiatives taken by the government of Rajasthan, and way forward. So this is the agenda of today's presentation. In very brief, I would like to tell about the road accident scenario in Rajasthan from last 5 years. We can see the number of deaths are almost very stagnant. It is around 10,000 or 300 or 10,500 or something like this. So the figure is quite constant in few years. And the number of accidents in Rajasthan is around 21 to 22, 23,000. And in 2021, the number of crashes were 20,951, which involved 19,344 injuries. So this is the pattern of road crashes, which is at present in Rajasthan. Now talking about the institutional framework, which is very important to deal with the problem of road safety. So apart from the district level road safety framework, we have state level road safety framework institutional capacities there in Rajasthan. First of all, there are certain committees which has been established in the state. The one is which was recently established was the High Power Committee, which has been established under the chairmanship of Honorable Chief Minister. Then we have a State Road Safety Council that was established in 2009, and it is headed by the Transport Minister of the state. Then we have a Traffic Management Committee, which is chaired by the Chief Secretary of the Rajasthan, and it was founded in 2007. Apart from this, we have the various stakeholder departments which are working together for the cause of road safety, which includes transport, police, medical and health department, education department, and road owning agencies. If we talk about the road owning agencies, there are multiple, apart from the government departments, there are other institutions or agencies who are involved in the construction and maintenance of roads in Rajasthan. And I would like to emphasize over there the Department of Transport and Road Safety is the nodal department for road safety in the state of Rajasthan. And to strengthen the institutional capacity, a road safety cell was established in the state in 2016, wherein the officers from different stakeholder departments are been deputed over here in the cell, and they work in under one roof and to have a better collaboration with all these stakeholder departments. So all of the departments which I have just quoted earlier in my previous slide, so they include the officers from medical health, police, PWD, LSG, and education department. So there are certain posts which are vacant, which have been depicted in the red color here. Then in the continuation to these institutional framework in the state, Rajasthan has also got its road safety policy, which was issued in 2017. And the most important thing is to undertake all the activities which are required by various stakeholder departments. It was necessary to have a road safety fund. So according to the directives which are given by the Supreme Court Committee, the government has formulated a road safety fund in the state for exclusive activities of road safety. Now it is a non-lapsable fund. It was constituted in 2017. And in this particular fund, the 25% of the challan amount that is being that is collected from entire state is allocated into this particular fund. The another major initiative that we have got in the recent budget announcement was a declaration done by the Honorable Chief Minister. That was the Chief Minister Road Safety Award, which has been started from the last year. And for the first time this year, the award will be given to the three districts which have done. They have performed good in terms of road safety, and they have been able to reduce down their fatalities. And similarly, there was an order was passed by the government in 2015, which says that helmet has been made compulsory in the entire state. So irrespective of the boundaries of the jurisdiction of whether it is it lies in category A, B, or C. No, a helmet is compulsory in the entire state, even for the rider as well as the pillion rider, and it is effective from 2015. Now, coming on to the some of the recent initiatives that has been taken by the government of Rajasthan. In 2019, a delegation went to Chennai to study the Tamil Nadu model of road safety, because Tamil Nadu have done well in controlling the fatalities. So, based on the initiatives of Tamil Nadu and certain other states, now Rajasthan has formulated its own road safety roadmap, which was the part of the again it was a part of the budget declaration that was made by the Honorable Chief Minister. Now in this roadmap, the different activities that has to be complied by various stakeholder departments have been clubbed into a roadmap, and all these stakeholder departments are now being complying all the deliverables which have been mentioned in this particular roadmap. So it has a department-wise list of activities which are being taken care by the stakeholders. In the continuation to the best practices of Tamil Nadu, as we know that IIT Madras has done very good work in the shaping of the scenario of Tamil Nadu state in terms of road crashes and deaths. So to implement all these road safety initiative in the Rajasthan. The government of Rajasthan has signed a MOU between signed an MOU with the IIT Madras. So IIT Madras will help in initiating the achieving the targets for the state of Rajasthan. It has been effective from 2020. Now the activities under this MOU has been just initiated in the Rajasthan. There's another initiative which is being carried out in Rajasthan. That is the you can say this is a project of ministry. Now it has been implemented in Rajasthan, and as you have heard about the integrated road accident database, so it's a project of ministry that was adopted again from the IIT Madras. Now, this integrated accident database has been implemented in Rajasthan in an entire state, in all the districts. There are 33 districts in Rajasthan. Now, using this application, now the various stakeholder departments have now started collecting the road crash data on using this app. So the best feature, the best part of this app is the earlier we were not having the geotagged location of the accident, and the other relevant details were, it was very difficult to chase the details from different stakeholder departments. Now all of the departments now feeding their data onto a one single platform which is accessible to all of them using a single click. Now, there's another initiative that has been started by the government now to appreciate and to recognize the Good Samaritans in the state of Rajasthan. Now, even Ministry of Transport and Highways has also started a similar kind of scheme wherein the Good Samaritan who takes a road accident victim into the hospital and helps him to save his life is been recognized by the hospital, and is and he's been awarded a cash prize of rupees 5,000 rupees, and apart from that an appreciation certificate is also provided by the Department of Health. Now this is being again the scheme is carried out from the road safety fund which has been established in the state. So most of the activities which have been given in the presentation are being carried out from the State Road Safety Fund by the Department of Transport and Road Safety. Similarly, to strengthen the trauma care in the state of Rajasthan, again it's a part of the budget declaration, and in this the various CHCs has been identified which are just near to the locations of highways. Now these CHCs now been upgraded to the a primary trauma center. When we say a primary trauma center, that means it's a work as a stabilization unit where the accident victim is brought onto the CHC, and if some case is, let's say it's very severe injuries, a patient will be first stabilized in this particular primary trauma center, then he will be referred to the some other higher level trauma center. So this is the initiative which is in the progress in the state of Rajasthan. To spread awareness among children and the college-going student, the government has in the process of establishing the traffic parks in all the districts. Now, in all the 33 districts, the traffic parks are being constructed to give the awareness to various community groups. So they are the construction of these traffic park is also in the development phase. There's another initiative that is of automated driving testing tracks. Now it is very important to improve the quality of drivers that we have in the state. So overall, there are 30 districts have been identified where the driving testing tracks have been approved, out of which the 13 tracks as of now have become functional in the state, and rest the rest of the district, it is the civil work is going on, and in 8 district the civil work has been completed. So very soon we'll have 8 more tracks that will be operational in some point of time. There's another initiative that has been recently taken by the department, the state road safety cell and the police. Now a joint team has been established where that team has visited the 2 national highways. One is the National Highway 48 and the National Highway 21. Now, the team comprises the officers from the road safety cell and the police department. So recently, a stretch from Jaipur to Bhilwara has been inspected by the this joint team, and in the last month, in the February, the NH21 in the Dausa district, the inspection was conducted. Now the team has found the various safety issues which have been reported, and this report has now been shared with all the stakeholders, including the officers of National Highway Authority of India and the region which is there in the Rajasthan, that is the RO Jaipur. And after that, a meeting has also been convened by has been convened, which was chaired by the Honorable Transport Minister, wherein all the stakeholders have been directed to implement all the interventions and the suggestions which have been given after the inspection of these highways. Similarly, according to the direction which have been given by the Supreme Court Committee, this state has already notified a scheme under the Section 135 of Motor Vehicle Act, which says that which talks about investigation of road accidents, the development of amenities on highways, and the development of traffic post on the highways. So this is now will come in force from this year. Again, there is another initiative of the Rajasthan that is related to the for the awareness of the public, that is the organ donation drive. Now we can we know that whenever a applicant goes for a driving license, so there is a question over there for which the applicant has to give consent on the organ donation. Now earlier this question was optional, it was not necessary to give it answers. Now this question has been made compulsory, so user has to attempt this question for organ donation. So after implementing this change, now there has been a 30% increase of the people who have given their consent for organ donation. So in this case, if somebody met an accident or injured or declares brain dead by the hospital, so there will be no need to take consent from their relatives. So this has been done in the state of Rajasthan. Again, to implement, there's an initiative to add on to the automated enforcement system. Now the government has also upgraded its each manual challan system into the e-challan devices. The Department of Transport and Police have been given the e-challan devices, and at the majority of the districts, now the challan are being done through the e-challan devices instead of the manual challaning. This is the recent initiative that has been introduced by the government of Rajasthan. Now, a total 179 portable weighing bridges have been given to the enforcement staff. Similarly, there has been road safety corners have been developed at all dealers' point to give the awareness of road safety to the person who are coming for the inquiry of the vehicles, or they are coming for the purchasing of vehicles. Road safety module has been also developed in Rajasthan in collaboration with the Rajasthan Knowledge Corporation Limited. By this initiative, almost every year 6 to 7 lakhs students are getting benefited, as they have to compulsorily attend this particular module. There is a road analysis, crash analysis has been started in the year from 2018. It has been done continuously in the state. For the road safety education, almost 1,33,000 books has been distributed in almost 65,833 primary and secondary schools. Now this book aims to develop the road safety awareness in schools of Rajasthan. And if we talk about the strengthen of trauma care, a world-class skill lab has been developed in SMS Hospital and Trauma Center. Similarly, there has been a modern ICU has been established in Trauma Center SMS Hospital, which is a 16-bed ICU, which has again been developed through the State Road Safety Fund. And there has been a BLS training center has been developed within the skill lab, which is aims to provide training to the BLS training to the government officials and staff. The state support program is a MORTH funded program, which is in the process. And apart from that, there are regular training programs being conducted by the department, which includes various training programs for the different stakeholders, including police, PWD, and other government officials. So way forward is the government is in plan to have the road safety action plan for the next 10 years. War room is going to be set up where the timely assistance shall be given to the road crash victims, and there will be a integration of ambulances in process where the NHI ambulances and the private ambulances shall be integrated to a single helpline number. Similarly, there will be a road safety curriculum will be introduced in school and colleges curriculum. Recently, at present, the curriculum is available only for the classes 6 to 10. Now it will be available for the classes 1 to 12th as well as in the colleges. So this was the end of the this slide. Thank you very much for your patience and your time.
A lot of work has been done by Rajasthan government. Really worth.
Time was too short to explain each and everything. So
now, Mr. Bhagat sir, I will come back to you again regarding this traffic part. Actually, we are also developing one traffic part in our institution. I'll take your suggestion also in this regard.
Sure, sure.
Okay, any question from the audience side, please?
Sir, good evening, Ravinder Tumar, DC Gurugram sir. आवाज आ रही है सर?
या
सर, क्योंकि आप हमारे पड़ोसी राज्य से हैं, तो आपसे दो बातें मैं शेयर करना चाहता हूं। नंबर एक की हरियाणा पुलिस ने एक 112 डायल 112 योजना स्टार्ट की है, जिसमें हमारे इनोवा गाड़ी में सारे वेल इक्विप्ड है और साथ में एम्बुलेंस और फायर ब्रिगेड, तीन डिपार्टमेंट एक ही जगह बैठते हैं जब भी कोई जरूरत होती है। तो ये इनिशिएटिव है फॉर हाईवेज एंड अदर आल्सो एरियाज सर, इवन स्टेट हाईवे, लोकल एरिया और NH। दूसरा सर मेरा ये था कि आपका हमारा NH 48 लगता है, अभी आप बता रहे थे, सारी बहुत अच्छी आपने बताई। मेरा एक सबमिशन है, क्योंकि ये स्ट्रेच जो है हमारा दिल्ली टू गुरुग्राम जो है, वो ये करीब आपके एरिया को टच करता है। गुरुग्राम का रेवाड़ी का लगाए तो उससे आगे भी है, तो करीब 150 किलोमीटर जो है आपके अलवर डिस्ट्रिक्ट को जाके लगता है। और ये आप देखेंगे जब कभी भी आपने यहाँ से विजिट किया हो, तो हर 2 मिनट पे एक ढाबा आता है जिसने रेलिंग को तोड़ दिया है, जितने भी रेन वाटर, स्ट्रॉम वाटर जो है उसको तोड़ दिया है। मेरा इस विषय में कहने का मतलब ये है कि क्या राजस्थान गवर्नमेंट और हरियाणा गवर्नमेंट मिलके अगर आप लोग इनिशिएटिव लें, एवरी 20 किलोमीटर एक हब बनाया जाए, एक पार्किंग हब, जिससे कि उनको पार्किंग के लिए एरिया मिल जाए, वहां पे फैसिलिटेट हो, रेस्ट रूम हो, लंच डिनर की व्यवस्था हो, इवन वहां पे कुछ गाड़ी में कोई खराबी है तो वो मैकेनिक वगैरह की भी व्यवस्था हो। उससे दो चीजें खत्म हो जाएंगी इस पूरे स्ट्रेच पे। अगर आप देखेंगे,
साहब थोड़ा ब्रीफ सवाल छोटा करें, आपका बहुत लंबा हो रहा है, छोटा कीजिए।
रोंग साइड ड्राइविंग खत्म हो जाएगी, इवन रोंग साइड पार्किंग खत्म हो जाएगी और एक्सीडेंट खत्म हो जाएंगे। इस पे विचार करेंगे आप, मैं ऐसा मानता हूँ।
अच्छा, नहीं, अच्छा सजेशन, आपका सजेशन नोट किया जाता है। हम इसके ऊपर जो अपनी समरी बनाएंगे उसमें सवाल इस सजेशन को भी रखेंगे, प्रॉपर जगह देंगे।
थैंक यू सर, थैंक यू।
आपका मेल आईडी से शेयर कीजिएगा, हमारी जो स्कीम बनी है 135 की, उसमें सारे प्रोविजन है जो आपने बताए।
ओके सर, थैंक यू, थैंक यू।
जी, आप मेल आईडी से शेयर करें, आई विल सेंड यू द स्कीम। जी सर।
Mr. Prabha, it's been a really wonderful presentation, wonderful initiative taken by Rajasthan government, and you have summarized all those things in a very brief manner and completed all these things. Quite attractive schemes are there being executed by the government. Thank you very much too, and thank you for sparing time for CAPT for this presentation.
Thank you very much.
Thank you. Now I will request my next speaker, Professor Nitya. Sorry, Professor Mithun Mohan. Assistant Professor Mithun Mohan, are you there?
Yes, sir. Hope you can hear me.
Yes, Mithun Mohan, you are, yes, you are coming up. Please share your presentation. Let me. Please share your presentation.
Presentation, actually, one of my student will be taking the presentation, sir.
Okay.
Mr. Ansar, could you just please share the presentation?
Okay, sir. I'm here.
So I'll just give a brief preface to what he is presenting.
Okay.
So first of all, let me just introduce ourselves. On behalf of the National Institute of Technology, Karnataka, we will be presenting this research paper. This research paper has been a work of Mr. Ansar Shah's MTech thesis, and I was a supervisor there. So I'll just start with why we had taken this topic as a part of his thesis. So the thesis covers a case study that was done on a newly constructed bypass on a national highway in the state of Kerala. So the intention of construction of this bypass was to bypass the Kollam town, and it was reported very widely in the printed media as well as in the digital media that this newly opened bypass is a very common location for accidents. So we were trying to investigate, is this statement that is made by the printed media and the digital media is correct or not, for which we have collected data from the traffic police of Kollam district in Kerala. And also, then the next main culprit would be the improper design of the facility. So what we did is, we did the entire geometric study of the various elements that are available across the entire length of the bypass. And we did not find anything that was out of the specification. And so, further to investigate what could have been the main reason for these accidents, we did a survey to and feedback were collected from several users who were very common to using this facility. And since this was conducted during the time when the pandemic was on the high, so we were not able to collect the data from the field. Instead, what we did is we collected information through online surveys by focusing on people who have been regular users of the bypass. And we found that certain driver-related and road-related factors were the major contributors to these accidents that is happening on this bypass. So to give a very detailed explanation of how we accomplish each of these steps and also what were the major findings of these works, let me just invite Mr. Ansar Shah to carry on with the presentation. Mr. Ansar Shah, you can start.
Okay, sir. Okay, thank you, sir. Good evening, all of you. I am here to presenting my paper, Investigating Accident at a Newly Opened Highway, a case study from Kerala. So first, let's get into the topic. Sorry for the inconvenience. Okay, so let's get into the topic. What is the significance of accident study? That is the main problem here. What is the significance of accident study? From the report of WHO, that is World Health Organization, 2018, India is currently positioning at the rank 1, which is including the 11% of the global accident-related death. And also, when we considering the MORTH report, 2019, Kerala is positioning the rank 4th. It is when we analyzing these things, it is a very alarming data. So I thought that I have to choose a particular bypass, and I have to study that. So I planned that I chose that Kollam bypass. So there will be a question why you chose Kollam bypass. So Kollam bypass is a 13.14 kilometer road stretch which was recently inaugurated connecting two portions Mayavaram and Kavanagh and a part of NH66. Actually, it reduces travel time for passengers by avoiding the city traffic, that is Kollam city traffic. But the interesting thing that is the accident cases reporting at this location was pretty much high. So it concerned me and it led to a study on this stretch, and I planned this study as four parts. That is accident data and analysis, and second part was geometric study, and third part was field visit, and fourth part was online survey. On the first part, accident data and analysis, I collected the data from District Crime Records Bureau Kollam, that is DCRB Kollam, from the recent 3 years, that is 2018 to 2020, and analyzed the data. And I got some result and some of the problem I found out. Then from that data, I plan to check some features, road features like length of the road, width of the road, radius of the curves, side triangles at intersections, like that. I plan to find out. But at that time, physical examination of the these features was difficult because at that time COVID second wave was too much high, and it was physical examination was not possible. So I used AutoCAD software and Google Earth Pro. So the thing I was done was I plotted the whole entire road stretch in AutoCAD software using Google Earth Pro, and I measured all these factors, and also I calculated these features and found out some conclusions from there also. From these two portions, I got that some issues are there in this road stretch, so it was necessary to conduct a field visit. So the third part was I planned was field visit. I got that 12 accident spots were there in this road stretch where recurrent collisions were occurring, and a field visit I conducted. And along with the field visit, I asked to the local shopkeepers and rickshawalas and the local public what are the problems here, what are the issues we are finding here, and what are any problem with this signal, what is happening here, and they suggested some problems here, and I got that it is necessary to conduct a proper online survey. So it led to me a proper online survey, and the online survey I planned in a manner that in the online survey, questionnaire survey, in the first part I included the personal information of the road users, and in the second part the technical things which is causing the road accident. And in the technical part, I gave the option to scale the features from 1 to 5. The scale of 1 indicates argument, and the scale of 5 indicates that it is the strongest argument. And sorry.
And so you can just pass quickly through the initial slides. Maybe you can focus on your main contributions.
Okay, let's get to the accident data and analysis. So from the DCRB, District Crime Records Bureau, 145 road accidents cases were available and 25 entries were incomplete, and I discarded that. Sorry? Hello?
It's the unwanted disturbance. Please go on, Vishan sir, and please be brief because come on the main point, come on the main theme, because we are running short of time, please.
Sorry, sir. Sorry, sir.
Vishan sir, I'll say that you come on the main point, what you want to say about this case study.
Okay, yes. Yes, sir. I'm getting into the topic. First the topic was first I analyze that accident data, and first part was accident data and analysis. On that, I collected 145. I got 145 data, 145 cases of accident, and 25 cases were incomplete. So I discarded that data, and from that I got that among these 12. I already told that there were from the data there were 12 locations where almost accident cases are reporting. And among the 12 locations, Kalumtaram was the prominent spot, and the accident cases occurring at the daytime was almost twice than night time, and almost out of 143 accident cases reported, and in that 85% of the reported injuries fall into the fatal and grievous category. These are shown in this. These are shown in these two slides, two diagrams. And the second thing was when we consider the age group, the most susceptible age group which was fall under the accident was 18 to 29 age group. That is the young age group. Maybe it is due to their risk-taking behavior and the psychological factors. And also when we consider the vehicle category, both in accused vehicle and in victim category of vehicle, the two-wheelers and LM light motor vehicles was more susceptible to accident. Then the second, I already told that the second portion was geometric study. I plotted the geometry using AutoCAD and Google Earth Pro. Then I found out the length of the road. I got that exactly the length of the road was 30.143 kilometer, and the width of the road I found out by offsetting the center line of the road, and it also got 7 meters as per the limit. And then the third property, I found out that the radius of the curve in that road stretch there were 6 major curves were there. All the radius of the curves within the limits as per IRC. And also I plotted the side triangles too. In some of the side triangles were obstructed by trees and flex boards and some buildings like that. And also from this conclusion, I visited these 12 locations. And from this 12 location, the major outputs I got that the main problem is lack of service road. This entire stretch of road is including a lot of pocket roads, but there is no service road for there is no service road. So, and also there is no signboards for indicating pocket roads also, and also the signal timing, improper signal timing at signal intersections also making confusion among the road users. And also overspeeding, carelessness. These were the problems they proposed from the public. I already told that these were the problems they were told, and this led to the questionnaire survey. And in questionnaire survey, I said that I prepared that in 2 languages, English and Malayalam. And in first part, I included the basic data and demographics of the road users. And second part, I included that what are the road-related factors which is causing for road accident, and what are the driver-related factors which is causing for road accident. And in questionnaire survey, primarily I conducted a pilot survey, and from the pilot survey I made some modification, and then I prepared the final questionnaire and made available to the public, and 157 responses I got. And the basic information I included was age, gender, marital status, educational qualification, occupation, annual income, like that. And the second part was, I already told that the driver-related factors and the road-related factors, which is causing road accident. The driver-related factors I included was overspeeding, mobile phone usage, drunk and drive, fatigue or workload or stress driving, or careless driving. I did that. I given overspeeding might be the reason for accident, and they can scale it from 1 to 5. 1 is the weakest argument and 5 is the strongest argument. Like that, all these factors I have given. Similarly, when we considering the road-related factors, these 10 factors I have given: width of the road, lack of proper signals, lack of service roads, sharp curves, poor night visibility, like that. Then from the analysis of the research, I got that most of the people in driver-related factors, most of the people decided that overspeeding and careless driving are the major problems that that is causing for the accident. And here we can see that 84 people chose that as overspeeding as the main reason for accident. Similarly, when we considering the mobile phone usage, also 44 people only chose that it is a major problem. And drunk and drive also we can find that only 51 people. And also stressful driving we can chose that 42 people. Like that we got. And when we considering driver related factors, when we arranging these in a rank related manner, 86 people chose that careless driving, and 84 people chose that overspeeding as the main problem for accident at that stretch. And similarly, when we considering and analyzing these graphs, I got that lack of service road and the lack of pedestrian crossing facility was a major problem at this location. Surprisingly, I got that the same thing. I thought the lack of service road is the main issue for the accident. And and also I have studied another thing, that what led that that is their personal trait, that is their gender or their education qualification or annual income, and which relation between that and their choice of careless driving as selecting as the major driver related factors. From that I got that 78% of in age group 30 to 45 chose careless driving as primary reason for the accident. Similarly, 56% of male respondents and 65% of married people and 62% of +2 qualified people, like that, chose that driver related chose that careless driving as a major related major factor for road accidents in driver related category. Similarly, in road related factors also I found this trend, and 40% of the male respondent and 37% of the single people and 44% of the +2 qualified people chose the road chose the lack of service road as the main problem for road accident. And as a conclusion, the whole procedure I did was the Kollam bypass is a 30.14 kilometer road stretch. I collected that data from DCRB, and also 120 cases of accidents we got, and the accidents occurring at the daytime is more than night, and the accident age group the age group which susceptible to more accidents is 18 to 29, and the number of grievous injuries was higher than minor injuries. And also in geometric study, I plotted the whole area, whole road stretch using Google Earth and AutoCAD software. And also find out the road features, and only side triangles at some intersections, that is NS Hospital Junction and Kollam Bypass Kunnadi Road intersection was made the problem. And also from the field visit also I got some conclusion. They told that these were the problem, and it led to the questionnaire survey, and from questionnaire survey I got that the major problem in driver related factors was the overspeeding and careless driving, and in road related factors the lack of service road was a major problem. And totally it was the final conclusion. And thank you for having my listening me. Thank you.
Yes, audience, please put up some questions if there are.
Sir, the study was good and is given a brief explanation for that. But
hello,
what is the
Yes,
action
sir.
of those accidents? It has been.
Sorry, sir.
What is the step taken to stop the accident of Kollam bypass? See, your study is good. You have given some reasons for that. But what is the remedy to stop those accidents?
Actually, okay, I actually propose this result to the concerned authority, that is District Crime Records Bureau 2, and also to the newspaper. I have given, and also from that they have told that they will give proper notable thing to present it, and they will give it at proper time, and it to be there is no further no updates, sir.
At present, the road is under the control of National Highways Authority of India or the state government.
Yes, sorry, sir.
The road is under the control of National Highways Authority of India,
yes,
or
yes.
it is under the control of state government. I want to know who is the authority in charge of the road.
National Highway NHA, sir, I think. It is a part of NH 66, sir.
Okay. So the concerned authority have given letter.
Yes, actually, I have given that letter to the District Crime Records Bureau, sir.
Okay. Okay, so let's wait and see whether it is fruitful or not. Okay, thank you.
Now, the start of investigation, there were no cameras were there. Now, I think they have installed some cameras. At least they have done that much.
Okay, I have one question.
Okay, sir.
Your analysis was, you have done very detailed analysis, very good.
Okay, sir.
But while concluding, you have not given the solution for after the crash investigation analysis. So when a crash investigation analysis is being done, you have to take consideration not only the infrastructure point of view, but then you have to also take care of all the 3 E's if possible. That is one. Secondly, you were telling about the you have concluded about the high speed. Now there are a lot of speed traffic coming measures are there. So like rumble strips as per IRC 99/2018, and signboards, and then many other ways of traffic calming measures by which the traffic speed can be come down. And that can be one of the short-term measures, some reflectors, delineators, and all these things will be accountable. You have suggested a long-term measures, that is service road, but service road will take a lot of time to come up. So till
Yes,
then
sir.
people will be dying. So that is why, if possible, you continue your analysis further and try to see what type of short-term short-term measures can be taken on this road. And you have not taken consideration of contraflow of the vehicle. Now, whether there are contraflow of vehicle on this road, that will be also contributing for the enforcement team. Enforcement team has to be escalate so that the contraflow will be stopped, and you have to also see the junction point access road which are coming out. So whether the access roads are directly entering into the road, whether the bell mouths are okay or not, acceleration, deacceleration lanes are there or not, whether the petrol pumps are rightly put up, whether in the retail outlet of petrol pump, whether the acceleration, deacceleration lanes are there or not. So these are few area where you have to work. Thank you very much.
Okay, okay. So thank you for your suggestion. So thank you. It was too valuable.
So just to add to that point, I thank for your suggestion. I think nowadays, if you see, a better of enforcement have been improved on this bypass. You can see policemen's position with speed, speed guns at frequent points, and even the message has been spread regarding the amount of accident that is happening. I think so. So some amount of education is also happening. So all these have already contributed to some extent in reducing the accidents. At least you don't find this road being mentioned very often these days in the news. So I think our intention was to just highlight what were the possible causes. Yes, of course, we agree to the point that we did not give any suggestions in this regard. So I think some output from our study has already been taken into account by the authorities, and those are currently helping in reducing the accidents as far as we are concerned. And thank you all for the suggestion.
Thank you very much, Professor Mithun Mohan sir and Mr. Ansara. You have your research work are really giving some data input to the government, and definitely they are the basis for the further improvement and implementations in the policies. Thank you very much to you, and Mithun sir, thank you very much for sparing time for us.
Thank you,
now,
sir.
Thank you. Now I will take our next speaker is Parvez, Mohammad Parvez from Mohammad Parvez. He is from Manit. Mohammad. Sorry, just a minute. He is MTech scholar from Manit, Bhopal, Maulana Azad National Institute of Technology. He is also going to discuss one case study on the gap acceptance behavior at urban uncontrolled intersection. Mohammad Parvez, are you there?
Sir, is my
Please,
slides are visible, sir?
Yes, please start on.
Yes, sir. Right. So, good evening to one and all. And first of all, I would like to thank Central Academy for Police Training Bhopal for giving us this opportunity to present our work. And our work is on gap acceptance behavior at uncontrolled intersections, urban uncontrolled intersection, which is a case study of Bhopal city. So these are the contents that I am going to discuss. The basic introduction. Generally, many accidents occur at uncontrolled intersections, which is a major accident-prone zones where driver behavior is a major concern. And studying that driver behavior will be a quite complex and risky thing. So in our study, we have studied the gap acceptance behavior of the driver, which gap acceptance means the driver how he evaluates the gaps and how he judges whether I have to merge into the major or minor road. This area will become under gap acceptance. So to develop a correct model, develop a base model to assess the driver behavior is a major part, and it definitely impacts on safety and capacity estimation too. So the need of the study is generally in Indian conditions. We have mixed traffic conditions where studying driver behavior is quite complex, and concerns this gap acceptance behavior can be used in delay estimation, capacity estimation. Further, it can be used in safety of an intersections. So this can also be applied at not only at uncontrolled direction, it can be used at signalized and at median gaps too. So many studies has been done on this gap acceptance in major homogeneous traffic conditions. In heterogeneous traffic condition, a suitable method is yet to be determined. So we have gone through several literature reviews along the world. These are the major literature review. That is first Asalatan, Satish Chandra sir. They have used clearing behavior approach, and they have found that this may be a best for Indian conditions. They have said that critical gap values. They have found that critical gap values are lower than the highway capacity manual, which was published by US HCM 2000. They have found that these values are lower than our values are lower than this HCM. And next, Moria sir also they have used many methods, and they have said that clearing behavior approach will be good to assess gap acceptance behavior. And occupancy time. Then Mohan and Chandra sir has used occupancy method, and they have found that this method considers zigzag movement, and whether it is whether we have less data or high traffic. it doesn't depend. This method has shown that it is good for Indian conditions. And so some literatures have been concentrated on developing binary logic model, and they have assessed that which parameter will affect the behavior of the driver, like car performance and waiting time, all those things. In our study, our main objective was to estimate a critical gap at a uncontrolled intersection and developing a binary logic model. And in that model, we defined many parameters like subject vehicle, what is subject vehicle, what is the gap, and what is the occupant's time, how it affects the driver behavior. The scope of the study is that how much extent we have gone through that. As I said, we have only concentrated on urban uncontrolled T intersections, and the parameters like lag, spatial gap, type of vehicle, this we have concentrated on these parameters. And we have studied on majorly on right turning vehicles, because right turning vehicles are major concern at intersections. They are dangerous than left turning vehicles. So critical gap is we have used occupancy time method to evaluate critical gap at intersection, and a logic model has also developed to study acceptance behavior. This is the methodology that we have adopted. And in this first, we have collected videographic data and manual data, which is a geometric data of the intersections. And from videographic data, we have extracted the parameters like vehicle gap, how much gap, what is the waiting time, what is the speed of the conflicting vehicle, all those things. In data analysis part, we have done this 3 analysis part. And in data collection, we have taken 3 intersection, Box 7A, Board Office, and Panchsheel in Bhopal city. And these 3 are major residential and commercial areas. In this, we have done videographic survey at weekdays, and we have collected 2 hours in the morning and 2 hours in the evening. And we also collected geometric features of the major and minor road and at all intersections. These are the 3 intersections we have studied on. These are the geometric features of the 3 intersections. So we have used Kinuvia software to overlay a perspective grid on video, and from that we have extracted parameters by playing the video at 20 frames per second. That we have taken the middle line as a reference, as which was said from past literature. From that, we have calculated this spatial lag, how much spatial gap, the distance when subject vehicle, that is from minor road, reaches to the conflict area. At that time, what is the spatial difference between reference line to the conflicting vehicle 1? That comes under spatial lag. And the time required to reach the conflicting vehicle to reference line is taken as time lag. And the difference of time between first conflicting and second conflicting vehicle will come under spatial gap. The time come under time gap, and whereas the distance between the spatial distance comes under spatial gap. So we have done this analysis part. In that this is the exploratory data analysis of 3 intersections. What is the mean gap at that location? What is the spatial gap? What is the average speed of the conflicting vehicles at that location? And we have done a collinearity test to determine whether the parameters are independent or not. And we have found that as the variance in inflation factor, that is VIF, is under 5. So it may be considered as the variables are independent among each other. So later we have done Pearson correlation test to determine whether the this these parameters, that is subject, vehicle, continuity, the speed, gap, all those things are having any correlationship with the accepted or rejected gaps that that was taken from by drivers, whether they are dependent on accepted or rejected gaps or not. it was found that except subject vehicle which has p value 0.9, this should be under 0.05. So except this, all vehicle all are dependent on rejected or accepted gain. So later ANOVA test was determined to find out whether time has significant difference, whether if we take morning or on evening, whether these two have significant difference in values. And we found that no such difference in whether it was in morning and with the acceptance behavior of the drivers are same. Similarly, in intersections too, at both at all the three intersections, the acceptance and rejectance behavior looks similar. Later, we have estimated critical gap using the occupancy time method, which was also mentioned in Indo-HCM 2017. Basically, we have drawn the cumulative distribution graph of occupancy time method and the one minus frequency graph of accepted gap. So the point where these two curves meet will be termed as critical gap. So in this we can see that critical gap of two-wheelers is less than critical gap of three-wheelers, which shows that less gap is accepted by two-wheelers, which shows that they are more aggressive than three-wheelers. And also when it comes to different type of intersections, all the intersections show similar critical gap values. And when it comes to morning and evening times, morning time we have less critical gap compared to evening, which shows that more reaction time is needed during evening. It may be due to light issues. So and when it comes to two-wheeler and different vehicle classification, two-wheeler shows less critical gap, whereas heavy vehicles, that heavy large size vehicles show more critical gap. And later we have developed binary logic model in which we have taken that if the vehicle accepts gap, then it is coded as 1, whereas if vehicle rejects the gap, we will be taken as the acceptance as 0. So this is the probability of estimating whether the driver accepts or rejects the gap. So in that U is termed as utility factor, in which the utility factor equation will be determined from this constants that we have got from this binary logic model. From this we can see that the significance should be under 0.05. So except conflicting vehicle speed, spatial waiting time, spatial gap, and waiting time, all are not that significant. The speed of the conflicting vehicle, gap, spatial, these are more dependent, or these are the main factors to whether the driver are accepting the gap or not. We have found that these 4 are main to accept or reject the gap by driver. These are the notations we have determined to make the model. This model will be helpful to determine whether the driver will accept the gap or he reject.
Parvez, I request to summarize it, please.
Yes, sir. Yes, sir. Later, critical gap. This is the results that critical gap for major right turning vehicles is less compared to minor right turning vehicles. That shows that the aggressiveness of the major right turning vehicles. And two-wheelers, as I said, two-wheelers show less critical gap. And from logic model, we have found a spatial gap between the vehicles has shown more impact on deciding whether we have to accept or reject in major road. Whereas in minor road, temporal gap, the time gap is more significant. And among all, waiting time also shows major impact, as if driver waits for more duration, it is less it is a probability that he will accept less probability that he will accept the gap. Speed of conflicting is also showing that if the conflicting speed of the vehicle is more, then the driver from major road has less probability to accept the gap. So from this we can say that this gap acceptance models can be used to at assessing the safety of intersection, and also for developing models of saturation flow models, delay models to and also to study accident analysis. And this can also be used to determine level of service, which can be helpful to determine capacity of an intersection. Further, these models can also be used in micro simulation to develop a model in micro simulation too. These are the references we have gone through. Thank you. Yes, sir. Any doubts or any discussions are acceptable. Welcome.
All the models
Yes, sir.
and studies made or on the paper itself. Let that be given in the practical field so that your model has helped in reducing.
Hello? Hello?
And it shows all the details. But practical problems, whether it was solved or not, with your and that too, you have given 3 intersections. What is the gap between the median? That is the opening. What is the length of the opening in the median? Can you tell me that?
Sir, can you repeat the question, sir? I lost the voice in between.
The median. What is the gap in between that median? Opening is there, no? What is the length of the gap for a particular junction? You taken a model.
Yes, sir. The median gap in the intersections was around 30 meters.
30 meters.
Yes.
So that itself is a problem. As per IRC code, the gap should be only 20 meters. Since the gap is more, the accidents will naturally be more. So that gap is to be reduced as per IRC. What about the other 2 junctions?
The other 2 junctions are around 15 meters to 20 meters.
Then it's
and
okay.
one intersection is
But
around
for
30, remaining 2 are 15 to 18 meters in the train.
Okay. If it is less than 20, okay, it is acceptable. If it is more than 20, the median should be reduced to 20, so that the unnecessary movement of vehicles will be reduced. So your model study should be based on a practical solution that will be helpful to us. The study will be helpful to us, for people like us in road safety. We are in charge of the roads. So that will be useful for us. Thank you.
Thank you, sir. Further, further we will do on this. Yes, sir.
So Mohammed Parvez, it was a really nice study you have been done by you. And this is the beauty of this platform, that whatever the shortcomings or drawbacks are there, that can be means you are on the online itself, you are getting the suggestion what to improve, how to improve it more. Nonetheless, it was a very good, great presentation by you, and great efforts by you. And now in this series, in this session, we are going to have our last presentation from the side of Dr. S. Velumurugan. He is going to discuss about the active speed control. Mr. Velumurugan, sir, you are there.
Yeah, I am there. Yeah.
Sir, please start your presentation. I have given you
Am I
slides.
audible? Am I audible?
Yes, sir, you are audible, sir. Please start sharing your
Okay.
presentation. By the time
Okay, I understand.
I'll give you a brief. I'll give a
I
brief.
will try to be very brief. I'll just finish it well within time.
Sir,
I hope my screen is now shared.
let me give a brief introduction, because you are a very high profile officer, sir. Let me allow to give a brief introduction of yours, sir. Dr. S. Velumurugan is presently working as Chief Scientist at CSIR, Central Road Research Institute, New Delhi. He has completed his PhD in Transportation System Engineering at IIT Bombay in March 1995. He possesses more than about 27 years of experience in traffic engineering, road safety, and transportation planning and transport economics. He has served in capacity of project leader, coordinator in the World Bank sponsored project, as well as National Highway Authority of India and various state public work department project for the conduct of various stages of road safety audits covering more than 90,000 kilometers of road. Over to Velu sir, please go on sir.
Yeah, thank you. In fact, I hope I am audible. My presentation is visible in full screen in presentation mode.
Sir, you are audible, but your presentation is off. It is showing that you are sharing it.
Sure, I have done it, shared. Okay, shared. Maybe I will share it again.
It will come, sir. It will come, sir. Wait for a second.
I will. You people have given me the sharing option, no? Window. Maybe I
Yes,
will
sir.
share my.
It is given, sir. It is given to you.
Uh,
Presenter rights are given to you.
Acha, acha. Getting it. Is it visible now?
Yes, sir, it's visible.
Is it in presentation mode now? Is it in presentation
yes, now
mode?
it is in presentation. Yes,
Sir, visible, sir.
Okay, okay.
Presentation mode. Okay, thank you. Thank you, and thank you once again for. I'm pleased to be again be part of your international conference. If I remember correct, in 2020, I happened to attend your physical conference where I was able to share my small experience in February 20 when you conducted it, and now I am. So basically, this is a very small presentation. As per the request, I made it in 15 minutes. Thing for speed control measures to enhance road safety. I am trying to give varying functional classification of roads. So the presentation focuses since last 2 days. Everybody are talking about the safe system approach, the 5-pillared approach. So in that, safe system is one of the major one which we need to address. For that, need for speed management, I will try to emphasize it in my presentation, and I will make it in this thing. I hope you are able to see my movement of the mouse, no?
Yes, sir. Yes, sir.
Yeah.
It is.
Yeah, need for speed management I will be emphasizing, and effect of speed on road crashes and its severity with the different type of pedestrian related crashes and other type of crashes I will be doing. And lastly, I'll be explaining with one ongoing study, IRASTE project, where we are trying to ensure speed control measure at the identified black spots, including geometric design measures. That is what I'll try to present the thing in a different perspective. You might have, I heard day one, Mr. Deshpande and Verma has spoken about this IRASTE project. They have spoken from the perspective of the technology. I'll be talking here primarily from the engineering perspective, where CRRA is the overall coordinating agency for this project. So I'll be talking from the from the traffic engineering and civil engineering perspective. So this is the case study I'll be talking. So this right now, safer travel, how would you achieve it? As we see on our roads right now, the safer road plays a wider road, and use based on the FIR record itself, which has been people try to contemplate the FIR records, but I try to believe that FIR records, whatever best available with the police, getting recorded, because the police is the person who is reaching the first onto the site. So from that angle, I believe those record maybe with the 80% level of accuracy with a pinch of salt, but that is the best way we have to go about it. There they record it overspeed as 65 to 70% as the major culprit, as one of the major causes. So that we have to understand. So that's why safer speed, if we can achieve it with the proper engineering measure, and also the safer vehicles, and we will be in a position to ensure some sort of a crash reduction, wherein education and information supporting the road users, that also should be there. So that should be facilitated with the enforcement of road rules. Like police plays a role here in terms of making it ITS driven also, which has been spoken out by the people. So that is one way we can try to address this thing. So all those things, if it is done in a comprehensive manner, safer roads, with starting with the safer roads, which is the engineering perspective, and safer speeds achieving through safer vehicles, and education and enforcement supporting the thing, and ITS related things, makes the thing in a more safer for travel by taking the admittance system and understanding the crashes. That is also important, because people should understand the present crashes, then accordingly all these measures have to be done. And safer speed through speed management is one thing. Why is speed management important? Because safe and efficient travel is the cornerstone of a healthy and prosperous society. To balance between appropriate travel speeds, maximize, and the trauma care. That is a trauma which has been spoken by many of the people about the road trauma, how it brings. So that way, in a simpler terms, speed management relies on the appropriate mix of, as I told in the previous slide, the mix of infrastructure, education, and enforcement. They have to be given in the proper mix. Just like we see the mixture what we eat, that it has the all ingredients. That way you are expected to give the proper infrastructure and the education which is needed for the people, and the enforcement in whatever ways which I told you. And one of the available tools is speed limit for this. So otherwise you will end up this kind of things. Speed and crashes in the prosperity is always related. And you've seen so many kind of crashes, that whether it's high profile or low profile, any people, and you have this problem. And what we see there is basically the people are not able to compensate with that speed. So the overspeeding is one thing which I already mentioned. I will not dwell on it. So this is the way each of the states report it, and that's why overspeeding is the panel which it want to look into and try to address it, especially on the highways and expressways, and to some extent MDR roads also. Whereas in the case of urban roads, along with the speed limit, you have to put the physical measures as well. That is why I just told you about this part. I will not have to tell. So why that is a problem? Because of the issue here is when the travel speed, stopping distance, and crash impact speed. If I try to go about it, so the reaction time at a speed of 50 kmph, the vehicle can stop in time on a highway. If it reaches say from 50 to 70, it it is going to take from the application of the brake, it can hit at 46 kmph speed. So that's why you need to really be careful, whether it's 65, 70 or 75, 80 speeds. It can become really a problematic thing. That's why the stopping distance is an important part, which is actually taking from the time somebody applies the braking. It is going to take this much of a distance. So that's why you have to be careful when we are on the highways. You have to provide the safer environment for the people to travel. Similar is the case in the case of urban environment. That's why we try to say most of the things not more than 60 as the speed limit for the arterial road in an urban environment. Whereas in 90% of the roads, we will not cross 50 as the speed limit for urban environment. Whereas for the rural environment, you can go on the higher thing by providing proper merging and diverging lanes. So if a pedestrian is hit, a car with a pedestrian, 20 to 30 kmph above, chances of surveying a crash decrease rapidly above certain impact speed. So if a pedestrian is hit up to 20 to 30, his survival chance is almost 90%. Beyond that, he or she is in a problem. Similar is the motorcycle or any motorized two-wheeler, or even a car hitting a pole or a tree. That way, the occupant of the vehicle also beyond 40, his survival becomes an issue. And similarly, car with the car at side impact of 50, if the impact speed is at 50, that is a problem. And car with the car 70 kmph, that because the speed can be much higher in terms of impact, that's why this can be a problem. So pedestrian crash severity, which I already mentioned you, that's what I just given it in this thing, which is a study done in Australia. They are trying to say like at 30 kmph, as I told you, 10% is the rate of fatality, the chance of fatality, probability of fatality. Whereas from 30, it increases rapidly at 40 at exponential level, and 50 at a much more level, which increases as high as 60, almost 60%. Sorry, 85% at 50. 40 it increases to at a speed at 22%. So speeds on our highways, some of the things which we have reported way back in 2012 itself was very, very high. Like average speeds are of this nature, which we see it on our cars, which is between 90 to 93 on a 4-lane road or a 6-lane road or a 8-lane roads, whereas the maximum speed is unimaginable for our roads, which is actually there. And right now we are contemplating even a Nagpur-Mumbai expressway at a speed limit of 150, we are thinking. So are we having those vehicles which are traveling at that speeds? It's a big question, because the speed differential is a big problem. You can see here, even in this things, the vehicle at 60 is 64 is traveling with 93. And if a big car, as we are expecting to go at a speed limit of 150, what will be the speed differential is a big question we need to be careful with. These are all the free flow speeds I just told you. And similarly, on an outer ring road, we found unimaginable speed in the outer in Hyderabad. So these are all the important part we have to take on board and while designing it. So the various speed control devices we have is we can have it as a differential speed limits and transitional speed limit. When it reaches the rural highway to urban environment, we can have a transitional speed limit. That can be one option. We can have it so that it will bring down. And also speed enforcement cameras, as I told you, is an option which we can think about it. So, and also in urban areas, we can think about when the road is passing through urban area, we can do it, or even the like this kind of speed limit written directly in on the surface of the road is an important option. We can have it, or street narrowing, which we can do it by having the chokers as we keep the barriers. Police used to keep the barriers. That is the a sort of a street narrowing only, or the humps, and there is a traditional way of putting humps, tables, and all. So I'll just end my presentation with two typical remedial measures which we are proposing, and that is being considered for implementation as part of the IRASTE project. It is one of the major intersection. That is 39 locations were identified in the city of Nagpur as black spots out of 117 locations. So for that, 2 locations I'm illustrating here. This location, one is the first is the Prakash High School, which is a black spot. 12 fatalities and 7 crashes have occurred during the last 3 years. So this is the typical. This is a mid-block location. So we are trying to give a generic solution for 1 kilometer long thing. So that way, proper AutoCAD drawing was prepared. From that, we are trying to give the solution for the mid-block sections as well as the minor junctions passing through. So this is basically the mid-block section of the road, where in front of the school, specialized measures are given, and similarly in front of the major junctions and 2 minor junctions, which is contributing to some sizable traffic. There also we try to give the solutions. So I'm just giving you an illustration of it, how we are trying to give, which will be how the location will look like after the improvement in this minor junction. So we are trying to give the stop sign facing the minor road, and also this kind of stop written and the stop line drawn, which are the traditional ones, and also the hazard marking area in these things, and with the studs
which are expected to be there, and also the studs on the median side of the road in the picture, and also the typical things like religious place structures and all. So this is a before improvement. This is the location. I should have, the slide is interchanged, sorry. So the absence of footpath and all those things are there at this location. So we are trying to give the location with all the improvements. And similarly, that the mid-block section of the road on the main road, where the road leading to the high school, that location is having the absence of footpath, zigzag marking, absence of cautionary signs. So many issues are there. So we are trying to give the things in the form of transverse bar marking and studs, and also zigzag marking, and also the median markers. All those things are proposed. And similarly, as it lead to the school, what side crash prone area sign, and also the school ahead sign written in the fluorescent yellow green color, and speed limit sign, and the speed hump sign, which is given as we lead into the thing. And also as the school entrance location, and this is a school where we are supposed to have, so we are trying to give the speed table so that the people can safely cross. So I have shown it for one direction of traffic. It is expected to be replicated for the other direction of traffic. So that this is the whatever the sign marking and geometric design improvements have been given as per the codal provision, or if it is code is not there, we are trying to give conceive our own and give it. And similarly for other location, Chickley Square intersection, we are just given this kind of thing. That is again a location which is the present configuration is like this. You can see here the junction is having poor road geometrics, as well as the problem of channelizers are not adequately done, and it is contributing to 10 fatalities and 5 crashes during the last 3 years. So we are trying to give the solution for minimum of 250 meters for each of the approaches, because as you know, police tend to report it near to the junction. So we are trying to take minimum 250 meters from this junction location for all the 4 approaches solutions. So this is the present photograph of this location. And though it is done with the ICBB, that is interlocking block pavers, but there are problems of pedestrian crossing is not delineated, edge line markings are not there, zigzag marking at that location is missing, road signs are missing. So we are trying to give 2 options. One is the typical junction improvement. As I told you, we try to give the thing. This is the option with the closing the main junction itself, so that the U-turn provision can be given. As we see in some of the cities, we try to give U-turn provision. Instead of junction is creating more conflicts, and more importantly, people are not following the rules of the game in the junction when they're waiting for the signal. So considering that part, 2 options are given. One is the traditional junction improvement, and second one is closing the main junction itself, and try to, because the land is available, you can provide the U-turn provision, and the proper signages are given along with that thing. And this is the thing which I just am showing on the regular junction design. If I am going for option 1, this is a regular junction design, wherein we are trying to give on all the left turning approaches, speed table on all the free left turning approaches. And whatever signs to be given, they are just given facing the direction of traffic. Just for illustration purpose, it is shown here. And also you can see here, road studs and the median marker, everything is given, what is actually required for a junction thing, so that the policy maker or the road owning agency can understand the utility of this thing for the same road, how it may look like. That is generated. And this is the thing. Second option, the same thing. As I told you, second option is closing the median opening. So that's what we are done. We are totally closed the median opening and try to give the solutions for the thing in the form of people can cross it, along with the pedestrian signal for the right people. The pedestrian signal also, what signal has to be there for pedestrians? 90-second signal time. At every 90-second signal time, 20 seconds will be dedicated for the pedestrians.
Like that, this has been given, and so that the people can safely cross. So like that, these are the various options which have been contemplated. So this kind of things we are trying to give for managing the speed environment in the urban area of the city as part of the iRaste project. Thank you. I'm done with.
Audience requested to ask if any question is
Good
there.
evening. Good evening, sir. I have two small questions. One, sir,
Yeah.
what would be the maximum speed
Yeah.
how much, sir, I have two small questions. One, how much it can be maximum speed in our country as per existing infrastructure? How much speed?
Yeah,
Second,
it's a very good question. Very good
second,
question.
sir,
That's what.
one more small question, sir. I just added. And how much driver can attain maximum speed provided his senses are normal?
Yeah, that's correct. So first question I will answer. See, basically, as I made a passing reference about this speed, whatever we observed in way back in 2010, 12 itself, people reaching up to 150 kmph, which is unimaginable for our roads. That is, the stray vehicles will reach. Cars, cars which will reach, and now it may be the same level. Maybe they will reach up to 140, 150 and all. That is not more than 5% of the entire traffic which is moving, because the 95% of the traffic will move between the speed of 70 to 90 only. So maximum speed, the free flow speed. So my point is, it should not go beyond 100 as a speed limit. 100 is the optimum speed limit, because speed differential will play a huge role on our highways. Highways, we can't really keep 150 as a speed limit, and which will have, because that traffic which is moving, the other goods traffic, they will not be able to cope up with that. Unless always we have a dedicated lane for them. If there is a dedicated lane, then there is no problem. There is no this thing means. So that is the issue which we have to have. And second question, what you asked, I forgot actually.
Sir, at the senses of a driver up to what?
Yeah, senses of a driver. Yeah, correct. The senses of a driver, as I told you here, up to 60 is the way. If he is a normal driver and he is driving with the proper this thing, you can expect with the 60 the traffic can come to a standstill without any problem. But beyond 60, unless otherwise there is a every likelihood property damage crash can happen. And if it is up to 70 or 80 or 90, there is every likelihood of, if a person is not attentive enough, it can result in some fatality crash. If he made a mistake, like if he is not able to judge the traffic which is in the front. So that's what 60, up to 60, they can bring the vehicle to a standstill position. Remaining location, they are supposed to be careful. They need to divert off from their their lane of travel. If he is a normal driver, if he is an attentive driver, without having any problem of nasha or anything.
Thanks a lot, sir. Great, sir.
Good evening, sir.
Yeah.
I have a question, sir.
Yeah.
Yeah. The maximum speed limit
Yeah.
120 kilometers per hour on expressways with 6 lanes. On
Yeah.
all other national highways, it is 100 kilometers per hour.
Yeah.
Within the municipal limits, it is 70 kilometers per hour for the cars.
Yeah.
For the bikes, 60 kilometers per hour.
Yeah.
Why are we discussing all the controlling the speed limits, and why can't we have the vehicles manufactured which cannot go beyond 120 kilometers per hour? Why are we allowing manufacturing of the cars which can run up to 240 or 300 kilometers per hour? The bikes which are getting in the market, they can be driven at 200 kilometers per hour. So why can't the government make a policy that According to the Government of India's Gazette, maximum speed limit on the expressway should be 120. So no car should be manufactured which can go beyond 120 kilometers per hour. That should be our strategy and the policy of the government.
Yeah, it's your point is a very good one. It's a well taken one. But as I told you, 120 is the one prevailing speed limit. But as I told that Nagpur Mumbai expressway, which is coming up, they are keeping speed limit as 150. So, which is also unimaginable. As I told you, it's not more than 5% of these vehicles will reach that kind of speed. 95% of vehicles will go only between 70 to 90. So you are not expected to have that kind of crazy speed limit. And also you told that speed, not even speed governor, as you rightly told that horsepower of the vehicle should not be in any way permitting for beyond 120 as the speed limit, as a speed which can be achieved. That is an important decision which can be taken if the government takes a conscious decision about it.
Thank you, sir.
I have one question, please.
Sir, yeah, sir, I am Kalyan Datta speaking, sir. In addition to our Lali sir, as he was stating about the speed limit notified by the Government of India. Now, wherever there are vulnerable locations, like the junction you have shown, so if we go on putting the speed limit in a reduced form, say like 30, 40, 60, like that, then the very concept of our notification of the speed limit gets defeated. So in such cases, whether we are allowed to put the lower speed limit or we have to go for only the speed coming measures.
Yeah, a very good question. Like when the highway, in the highway environment, you expect this kind, whatever I showed you, the two locations are the urban environment. In urban environment, from 50 is the 90% of the roads in our country in urban environment will be 50 is the maximum speed limit. So for there at that crash prone locations where it is identified as a black spot, you are entitled to bring it to 30 by providing either not the speed humps on the main carriageway. You can provide speed yes, that not TBM or rumble strip. In दोनों से एक तो डाल सकता है. TBM or rumble strip on the main carriageway you can put. But on the intersecting road, you are allowed to put the speed humps, which can make this vehicle to come to a standstill position. It is expected when a vehicle is entering from the minor road, it is expected to wait for an opportunity. If it is an unsignalized intersection, it is expected to wait for an opportunity before it goes to the joins with the main carriageway. That is expected and that should be followed. But other than that, whatever your point told is exactly correct. And on highways condition, you can provide up to rumble strip only.
Right, sir. Sir, I have one more submission to you, sir. As you are in a position to put forward my suggestion that we encounter a lot of contraflow and accidents are occurring and fatalities are very is too much on our national highway. So can there be any system of e-challan system on the contraflow? Can be implemented.
Yeah, it is a very possible thing. Like as I told you, ITS solution, what I told, speed enforcement, and even I feel in 2006 itself, this kind of solutions are.
इनका राइट कहाँ चला गया? मलिक साहब कहाँ? Yes, Sefali madam. Sefali madam, please look into the matter why the voice is not coming.
Bridge, are we done with the discussion? Or any more points left for discussion?
No, sir. Now we are going to conclude it, sir. Now time is also.
Yeah, Mr. Arvind Kumar Jain has raised the hand.
Sir, good afternoon. Sir, one small question. As you have said, you have applied and you have chosen number one option of having all the road marking, signage, and this. Can you have idea of data? What changes has been made? What changes has been effected after doing this, resulting to the accidents? How much percentage of accident has been reduced by applying that particular option one?
Yeah, in this thing, it is proposal stage, it is there. Another thing which we have done for Noida, Greater Noida Expressway, with all the measures, which includes signages, markings, and also crash protection measures on an expressway, along with the provision of speed enforcement cameras, has yielded economic internal rate of return of the investment of 23%. And also it has brought down the crashes by about 18 to 20% in terms of, in the case of but fatalities have come down by 60%. Crashes have come down by 20%, whereas the fatalities have come down by 60% on Noida Greater Noida Expressway. That I didn't present here today, but whatever I presented now is the proposed one for the location in Nagpur. It is not yet implemented.
Thank you very much. Thank you very much, sir.
You may ask one or more questions, because let me confirm whether our chief guest has joined. Please give me 1 minute for that. By the time you may ask.
Nirmal has joined. Nirmal Saab has joined.
Okay. Right.
Yes, he has joined.
First of all, okay, then we should conclude our session now, question answer session. And now I request firstly all of you to please switch on your videos, because our this chief guest and deputy director, they are coming for this validation section, and I want you to please switch on your videos. And now the program will go on like this, that I'll request my deputy director, sir, for the summing up, thereafter a closing address by the chief guest, and then I'll propose a vote of thanks. So now I should start with this proceeding. Good evening to all. Good evening to one and all present on this WebEx platform. Respected Sri Sanjay Kumar Nimble, Additional Director General, Ministry of Road, Transport and Highway, Secretary General, Indian Road Congress, Sri Chandraprakash Saxena, DIG, Deputy Director, Central Academy of Police Training, Bhopal, and all participants, speakers, and research scholars and students. The 4th National Conference on Traffic Technology and Road Safety began on 3 March 2022 with the opening remark of the Sri Pavan Srivastava, IPS Director, CAPT, and inaugural address by Srimati Alka Upadhyay, IAS, Chairperson, NHAI, who has been chief guest of the event. And today, after 2 days of extensive deliberations on the theme, it is all set to be concluded. Sir, the participants of this conference were 136 police officers, 46 PWD officials, engineers, 103 officers from State Transport Commission, 27 officers from NHAI, executive officers from CRAI, ARAI, CIRT, IRC, TRG, and Caltron, non-profit institutions like IRT, NGOs, students, and educators. For this conference, we invited original research work on traffic technology and allied topic, and sharing of best practices for discussion from all stakeholders having the domain in the road safety, engineering, construction, and traffic regulations. This is the first time we invited research scholar and got an astounding response from the top educational institute of the country. We have received 13 research papers from different IITs, 6 papers from the NITs, and 8 research papers from the regional government technical institute and private technical institute. After proper scrutiny of the contents, 8 papers were sorted out for discussion in this forum, and all the presented research paper and others having merits and could not be presented due to the time limit will be published in the Technical Research Scholar Journal, Bureau of Police Research and Development, and will be disseminated to the concerned ministry, Government of India. Besides presentation and discussion on the research topics, case studies and sharing of best practices during conferences, keynote addresses were given on some of the following important topics by very eminent and experienced speakers. These topics were technology as an enabler of sustainable development rather than a total solution. Capacity building of manpower and indigenous research should be given precedence. Performance simulation of highway infrastructure using computer simulation as per global standard. Intelligent solution for road safety through technology and engineering. Road safety audit and road safety awareness and community participation. Science behind the motor vehicles, number plates in India, emerging technology and road accident emergency scale. These were some of the topics which were touched by a special person. Now, before inviting the Honorable Deputy Director, CAPT Bhopal, for presenting conference report, I would like to give a brief introduction to you. Sri Chandraprakash Saxena is a BSF cadre Direct Entry Officer of 1987 batch. He successfully executed anti-militancy operations and successfully commanded many BSF battalions in hypersensitive militancy-prone areas of J&K and Mizoram. He also served in SPG on deputation and also joined the UN peacekeeping mission in Kosovo as UN SIPPOL officer. Sri Saxena, sir, also served in BSF Academy Tekanpur, MP, where he contributed to raising the BSF Institute of Disaster Response and training of 2 NDRF battalions. He is accredited Master Instructor of Peer course, which provided training in disaster response. For notable contribution, he has been awarded many appreciation certificates from the Chief of Army Staff, DG BSF, DG SPG, Vice Chairman NDMA, DG NDRF, and DG BPR&D. He is awarded President Police Medal for Meritorious Service and Police Medal for Distinguished Service. Sir, now I will request DIG sir to please present conference report, sir. Over to DIG sir.
Thank you, Bridge. You have sent me a very long report. I think past 2 days hectic consultations and discussions with the eminent gathering here. I would say the response was overwhelming. So on the behalf of Director Academy, Shri Pawan Srivastava, I extend again a warm welcome at this valediction session and summing up of the proceedings of 4th National Conference on Traffic Technology. So a very warm good evening to Honorable Chief Guest, Shri Sanjay Kumar Nirmal, Additional Director General, MORTH, senior officers, research scholars, dear students. I would say a very august gathering is present here on this portal at Cisco WebEx platform. This was indeed a very, very overwhelming response from all of you on this special topic, special subject of concern, which is plaguing our country, I would say, and I think needs utmost attention of each and everyone as a stakeholders who are present over here. So I will just quickly cover. This is around a 9-page report, and I will just quickly shuffle through this, what has happened in last day and today's discussion. Again, with the opening session, Dr. Rohit Baluja, President, Institute of Road Traffic Education, he talked on technology as an enabler of sustainable development rather than a total solution. He spoke about capacity building of manpower. Indigenous research should be given precedence. He emphasized on one of the key areas in retrofitting smart cities with intelligent traffic and transportation management system and creation of traffic management centers. In his concluding remarks, he stated to bridge the current gaps by avoiding bypassing the traditional stages of development. And he emphasized that policymakers should consider strengthening the framework through capacity building of the human element. Next was Ms. Lisa Malik, Assistant Professor, Indian Institute of Technology, Dhanbad, Jharkhand. She presented her research paper on development of safety performance function using surrogate variables for network screening on Indian national highways. She spoke at length about the limited availability of traffic flow data, which has continuously affected the accuracies of the developed safety performance functions. In short, the SPF. She further spoke that limited availability of traffic information and costly surveys continuously affect the accuracy of the development of SPF in India. It's high time that we use an alternate approach to develop simple SPF based on travel speed, access density, and land use variables. Shri Sanjay Kumar Agrawal, additional SP MP Police, talked about enforcement challenges that are faced by police officers and presented an eye-opening case study on evidence-based road traffic accident analysis. He explained how the wrong construction of the rotary or the crossroad areas become more prone to road accidents. Whenever any construction of any crossroad or rotary has to be done in the city, a traffic expert should be there in the consultation process so that these things are advised based on the evidence, based on the traffic, and based on the requirement. They should be advised. He also indicated that a lesser space is available on the road, especially in the cities where no arrangements for parking is made at various places such as marriage halls, school, colleges, banks, which also leads to problem in maintaining the traffic system. Shri Ashutosh Pandey, Project Assistant, Department of Civil Engineering, IIT, Banaras Hindu University. He presented research paper on black spot analysis and identification of potential risk factors through road safety audit. I'm just revising, in a sense, just to collect the, total thoughts that have been, passed on through various discussions. He described that road safety is considered as one of the primary concerns for any traffic engineer when it comes to road transportation. In India, road accident results in death of almost 1.5 lakh people each year and around 11% of the global road accident related death. The finding from the study submitted by Shri Ashutosh Pandey can be taken as a reference to identify probable accident causing factors on other roadway facilities. Shri Anurag Kulshrestha, President Tracks Society, he gave a presentation on safe infrastructure intervention for black spot, ensuring road and user safety. He talked about mindset and common thinking in the traditional system of probing a road crash. The sole blame is upon the driver or the other road user, location or situation wherein a crash took place. There is a requirement of holistic approach that encompasses provisions for safer road infrastructure, safer vehicle design, readily and in time available pre and post crash facilities, better enforcement and active participation of lawmakers and stakeholders. The integration of corrective measures with better enforcement and a safe system approach can get us good results in terms of reducing road crash fatalities. Shri Deshpande, Executive Traffic Engineer, and Shri Verma S. Konala, CEO of National Institute for Transparency, Access to Information and Personal Data Protection. They gave a presentation on iRaste, intelligent solution for road safety through technology engineering. They also talked about the artificial intelligence powered project on pilot basis in Nagpur in Maharashtra. They have shown various equipments being utilized in road safety technology. Colonel Pradeep Garola, GM NHIDCL, National Highways and Infrastructure Development Corporation, gave a presentation on road safety audit and road safety awareness and community participation. The finding and suggestion which he encountered during the audit, which he suggested that safe stopping site distances should be mentioned, construction zone safety should be earmarked, unwanted roadside vegetation growth should be removed, old bridges, parapet should be refurbished or maybe reconstructed, vulnerable road users, cycle track, footpaths, vulnerable road usability, temporary diversions, pothole drainage, and unregulated junctions. Mostly I have seen, even I have met with the accident on unregulated junctions because nobody follows the traffic there and you never know who will jump in front of your car from what direction. And therefore, he had talked about the unregulated junction to be controlled, whether by way of traffic signals or maybe by placing traffic police personnel over there. Then Mr. Nyalkonda Prakash Reddy, IPS, Deputy Commissioner of Police, Cyberabad Police, he gave presentation on integrated and intelligent traffic management system. I remember, I think last time also in the traffic technology conference, he presented a model from Hyderabad. ITMS provides a common platform for managing traffic and associated incidents, events, KPI-based performance tracking, he suggested. He suggested 7 different modules in ITMS, that is traffic incident management, traffic junction management, intelligent traffic routing, traffic violation management, special event management, traffic business intelligence, case management. Now, intelligent traffic routing, I have seen in Calcutta. You see, if you have been to Calcutta, you find at particular time when the peak hour is there, the traffic is routed in such a way that you don't encounter. You move in a singular direction. And then after some time, when the traffic becomes easier or lighter, then that particular portion where the jams occur, they open it for the traffic. So intelligent traffic routing is somewhere in the metro cities. I think they are being practiced. Shri Vivek Tiwari, assistant professor, and Shri A.S. Chauhan, DYSP Traffic Police Indore, presented a research paper, come a case study on need of integrated traffic management practices for Indore city. In their research, they provided suggestions on intra-city traffic, urban traffic city, outer parameter routes, inner parameter routes, traffic sanskar as per NEP 2020, how to drive, all the traffic rules and regulation after 10:30 school. That is for the sensitization of the school students. Then retired police officer should be engaged. And NHI contributing for national and state highway, but for intercity road, no department is dedicated to it. And every department is designing in their own way, which causes a lot of problems. Then Deotima Mukherjee, research scholar from IIT Delhi, she presented a research paper on pedestrian safety near bus stop, a case study in Delhi. And she mentioned about the fatality at bus stop and gave some good suggestions. Broader sidewalk has more effective width, should have more effective width to accommodate pedestrian and bus commuters. Bus stop with a higher bus commuter frequency to be addressed, where addresses more number of fatalities. Okay. Free intersection left turn makes it difficult to judge the status of the incoming traffic. On-street parking increases visual obstruction and buses are forced to halt away from their designated locations. This is another very important point. I've seen in Delhi, the bus stops are there, people are there, but you will find either the bus stops a bit distance prior to the stop or maybe ahead of the bus stop, because either tempos and cars are standing over there, or somebody is blocking that place, or maybe some other bus is standing. And proper lighting condition at night time also she has given as a reason for fatalities on the bus stop. Ms. Deepa Sharma and Ms. Niyanta Balan, research scholars and Professor Dev Pratim Pandit, Department of Architecture and Regional Planning, IIT Kharagpur. They presented a research paper on planning and design strategies towards improving bicycling safety in Indian cities. They gave analysis of parameters associated with provision of safe bicycle infrastructure and the suitability of the present bicycle infrastructure planning and design approaches for addressing road safety. Shri Amudapuram Mohan Rao, Senior Principal Scientist, Head of CRRI, presented a research paper on science behind the motor vehicle and number plates in India. He informed about the history of number plates and peculiar study of number plates system in India. Ms. Gitanjali J, research scholar, and Professor Dev Pratim Pandit, Department of Architecture, IIT Kharagpur. They presented a research paper on a protocol for designing a dynamic bus dispatch and control system along an urban corridor in the Indian context. Ahluwalia Gayatri, postgraduate student, Civil Engineering Department, and Sri Subhadeep Vishwas, Assistant Professor, Civil Engineering, NIT Hamirpur. They presented a research paper on provision for speed bumps and data-driven methods. Speed bumps are horrible, and even at the highways in Bhopal, I have seen speed bumps are created in a way it is left over to the person, to the contractor who has no knowledge about creating the speed bumps, and invariably you will find your vehicles get bumped up at the bottom. and you find damages. There is no similarity. You find 3 speed bumps at a distance, and you find one of the speed bump is such that it invariably gets stuck up with the vehicle having the low ground clearances. So their research objective was to develop an empirical model to predict the percentage reduction of speed based on number and height of the speed bumps, as I said. So this is one of the good, and I'm sure this will find a suitable place for the study and for the discussion at appropriate level, so that it is not only distributed, but it is also communicated to all the concerned stakeholders who are involved in construction of the road bumps, especially on the highways. Shri K.C. Tiwari, International Safety Consultant, Melbourne, Australia. He gave a presentation on speed management, and he narrated 4 basic principles. Human fallibility, people make mistakes which can lead to crashes. Human vulnerability has a limited physical ability to tolerate crash forces. And road safety is a shared responsibility, and to build a safe and forgiving road system. Safe system principles he had informed the gathering. Shri Srijit, CS Technical Head, Senior Project Executive, Caltron. He presented on Paltrack, a solution for pedestrian safety and better queue management for vehicle. The system was developed and implemented by Caltron Traffic Signal Division, is an advantage to both pedestrian and vehicle. Top priority was focused on pedestrian safety. In this system, pedestrian safety is ensured by providing an alarm at the termination of pedestrian base. So, as a good knowledge for all the members who had remained present during the 4th National Conference. Then Samkit Jain, ME scholar, and Dr. Rakesh Meher, Department of Civil Engineering, SATI, Vidisha. They presented a case study on development of methodology for prediction of traffic accident fatality in Vidisha city using MATLAB. Vidisha near Bhopal, if anyone of you have visited, is a noisy, congested, polluted, and a typically disorderly developed city, wherein suddenly you find the road is quite spread, wherein 4-lane traffic can move easily, and suddenly you find that it is narrowed down to a single lane. They discussed about the causes of accidents, their contribution by giving the statistics of road accidents in India. Drivers fault 77.5, defects in road condition 1.5, defects in motor vehicle 1.6, fault of bicycle 1.3, fault of pedestrian 2.4, weather condition 1%, and all other causes 14.8%. Now this 14.8% are other causes attributed to the sensitization or to knowledge about the traffic, or the knowledge you can call a traffic sense maybe resulting in the accidents. Then Shri Dilip Kumar Panda, Safe India, NGO Bhubaneswar. He made a presentation on sustainable urban safe mobility and participation of public transport and integration of local resources. Shri V. Srinivas Rao is research scholar. Balaji Ganesh Rajgopal, postdoctoral research, NIT Trichy. They made a presentation on trends and opportunity for infusing artificial intelligence into new generation intelligent and transportation system. Maybe in times to come, maybe 10 years down the line, probably we'll find AI right into the place to manage your traffic conditions in metro cities. The way the technology is advancing, I think we can hope to see the same maybe 10 years down the line. The paper addressed the problem arising out of traffic congestion with an advanced paradigm called artificial intelligence. Their paper explained about the fundamental of AI technique and bring about the potential application in traffic management system. Shri Dipanshu Gupta, Vice President and Co-founder, Indian Road Safety Campaign, NGO. He made a presentation on youth engagement in road safety. Now, until and unless we sensitize enough our population or the coming youth, school, colleges, then it becomes very difficult. It is not an individual responsibility, it is the public responsibility as well. And until unless we focus on the generation next, मेरा ये मानना है कि अगर हम आने वाली जनरेशन को, चाहे वो डिजास्टर मैनेजमेंट हो या रोड सेफ्टी हो, अगर हम उनको नहीं अभी से सेंसिटाइज करेंगे तो आने वाली जनरेशन भी सेम वही फॉलो करेगी जो अभी तक फॉलो होता आया है. So he made a presentation on youth engagement in road safety. The session focused on the need of youth engagement in road safety and possible ways of youth engagement in road safety by government and civic body. Padma Shri Dr. Subrata Das has been a very prolific speaker and is a esteemed faculty for us. He's a managing trustee and CEO Lifeline Foundation, and he's always on board with us in our efforts to engage him for the traffic technology side. And he's our eminent faculty. He made a presentation on emerging technologies for road accident emergency care. Mrs. Nidhi Singh, Joint Transport Commissioner, State Road Safety Cell, she talked about the best practices of Rajasthan in the field of road safety. Shri Mithun Mohan, Assistant Professor, Department of Civil Engineering, Karnataka, he made a case study on investigating accidents at newly opened highway. For the case study, they considered Kollam bypass on NS66 in Kerala, which is around 13.14 kilometer long, but accidents reported on the road are higher than the normal. The analysis led to the detailed study of geometry using AutoCAD and Google Earth Pro. Sanghapriya Bharti research scholar Dr. Pratikana Das and Dr. Siddharth Rogde from Maulana Azad National Institute of Technology, Bhopal. They presented a research and based on the case study on gap acceptance behavior at urban uncontrolled intersection. Case study of Bhopal city. The paper presented the steady gap acceptance behavior of major road right turning vehicles and minor road right turning vehicle at an uncontrolled intersection. Dr. S. Velumurugan, Chief Scientist, CSIR, co-convener G7. He talked about the active speed control measures covering varying functional classification of roads. So thank you very much for bearing with me for such a lengthy talk, but I think it would not be right. It would not have been right rather that if I skip on someone who has made a presentation in this national conference of importance, and their name is not called out here for making contribution here. Let me assure you, gentlemen, that all these points are in a format for compilation purpose only here, for the purpose of speaking out. But let me assure you, a detailed kind of a report will be formed and will be presented to BPR&D headquarters with the suggestions that have come up. And as Bridge has already told you that we intend to publish a compendium of all the research paper, even if someone has missed in the presentation part, but we intend to include those research paper as well. And this is one thing that we have done this time, and we hope to scale up from the next conference onward, and maybe seeing the overwhelming response that we have received from the research scholars, I think we have been able to create a platform wherein we hope to have a very, very good participation for better in times to come in our future conferences. So thank you very much for bearing with me. Over to you, Bridge.
Thank you very much, sir. Now, before I invite our chief guest for closing address, let me share his brief introduction to audience. Sri Sanjay Kumar Nirmal assumed the role of Secretary General of Indian Road Congress in April 2017. He has been associated with IRC for more than 30 years. He joined the Ministry of Road Transport and Highway, Government of India through Engineering Service Examination in 1986. From 1986 to 2017, he worked at various offices of the ministry in various capacities. He also worked in the National Highway Authority of India during 2003 to 2009 as a general manager and 2009 to 2010 as chief general manager. Sir was corresponding member of the technical committee of flexible and semi-rigid payment of World Road Association, Paris. He is also fellow member of Institute of Engineering, India. Sir has graduated in 1983 from Malviya National Institute of Technology, Jaipur in civil engineering with honors MBA in 1990 with from Institute of Management, Jaipur, and Master of Science in 1998 from Delft University of Technology, IHE Delft, Netherlands. He is a recipient of Pandit Jawaharlal Nehru Birth Century Certificate for outstanding contribution to national highway professional given by the Indian Road Congress in 2003. So now may I request our most valued guest of the event, Sri Nirmal sir, to address the audience. Over to sir.
Thank you. So, am I audible?
Yes, sir, you are.
Okay. So, DIG, Deputy Director, Central Academy for Police Training, Bhopal, Sri PC Saxena, distinguished faculties and participants, which involve, I think, senior police officers, senior officers from the field, particularly NHAI, PWDs, and a lot of research scholars who are present here. So first of all, I am grateful that you have given me opportunity by inviting in this valedictory session of 4th National Conference on Traffic Technology and sharing my views on behalf of Ministry of Road Transport and Highways, as well as on behalf of Indian Road Congress and our contribution towards promoting this traffic safety and other road sector related issues. And I am sure in this 2-day national conference, you have been benefited by various eminent faculties, discourses and talks and presentations, as have been just summarized by Sri Saxena ji recent just now. So we have the dubious distinction of becoming having the largest casualties in road safety, road accidents particularly. And for last couple of years, it is near about 1.5 lakh people are getting killed, and which is about 11% of the world's figures. So that is really very alarming that this normally we should not have this kind of faculty which is taking place, fatalities. And as we see, I mean, if you compare the accidents, United States have 4 times more accidents than India, because about two times more road network. India has the second largest road network, and the United States has the largest road network, and they have 4 times more road accidents. But the casualties in the United States are 4 times less, I think 25% only as compared to India. So it means that there is a hope that even the most developed countries, if they can contain the accidents in spite of having the best roads, why we cannot have? And unfortunately, our national highways and our expressways have the highest so I think all of us have the we have the responsibility, and we should do the concentrated effort how to reduce these fatalities and accidents, and how to improve the traffic behavior and our road conditions. So Government of India has made commitment at the 3rd Global High-Level Conference on Road Safety at Stockholm that, to reduce the fatalities and injuries both to 50% by the year 2030. I mean, coming in this decade, and the United Nations have also declared again this decade for road safety. So that is what is the importance, which not only at the global level, but at the Government of India level also we are giving the importance. And considering this importance, Ministry has also formulated its strategy to how to address this issue of road safety. So we have formulated multi-pronged strategy to address this issue, not only for road engineering, that is design of roads, design of vehicles also is important, then education, emergency care is another important aspect. So these 4 E's are defining the strategy which Government of India has adopted. Now, when we talk about education, then Ministry implements a scheme for undertaking publicity measures and awareness campaigns on road safety through the electronic media, print media, NGOs. We have also appointed even the ambassador for road safety. Akshay Kumar was the ambassador appointed, and to promote this in the general public. That is what we are doing to promote this. Not only that, earlier we were having a week which was dedicated road safety week every year. And from last year, we have made it as National Road Safety Month. So we want to spread this awareness throughout the month. This, because of the COVID, this January we could not have. So now we will have this sometimes later, this Road Safety Month. And this also is very helpful spreading the awareness and complementing the efforts made by various important persons and various NGOs towards road safety. Apart from that, capacity building is another important area because we need a lot of experts in the road safety regime. So towards that end, a certification course for road safety auditors have been formulated by the Indian Road Congress, and Ministry and IRC have signed MOUs with various academic institutions. So far, we have signed from 13 institutions, which include 4 IITs and NITs, CRRI, IHE, and NETPAC. And now another 23 institutes, which include 10 IITs, have come forward, and they also want to sign MOUs for training of road safety officers and certification course. So that will give a boost, because unless we have the experts which can, which can effectively do the road safety audit and road safety designs and all that, we will not be able to address this issue. Apart from that, then when we are talking about the engineering aspects, then towards road engineering, already road safety has been made integral part of road design. In fact, our TOR for DPR consultants, we have specified that they must have the road safety audit at the planning stage and design stage. And after completion also we have road safety audit. And apart from that, Indian Road Congress has also published a number of documents, which are, I think, in the course of this 2-day program, various faculties have discussed these particular documents in detail. And some of the important documents, one is that road safety audit manual, which is IRC 88, then traffic calming measures, that is IRC 99, then crash barriers, that is IRC 119, then road signages, that is IRC 67 has been recently revised, then pedestrian fatalities addressed, that revised our pedestrian facility document IRC 103 very recently. And another important thing that which IRC has done towards road safety is that we have recently formulated a new document on identification and rectification of black spot, or rectification of black spots, and which will be a very important aspect. And in fact, Ministry of Road Transport is giving highest priority to address this issue of to removal of these all the black spots which have been identified, because they are identified in a systematic way. And for last 3 years, we had identified, because this data of 3 years are taken for that, and 5,803 black spots were there. All these black spots already we have taken all the temporary and immediate measures for rectification, and permanent removal of these black spots may be completed by end of next year. So that we are giving the highest priority. Then apart from that, even we want to reduce the congestions and all that on our highways. That is why the capacity upgradation, earlier it was being done at the 15,000 PCUs. Now we have taken a policy decision that even at whenever the traffic triggers more than 10,000 PCU, then we will do the upgrading of 2-lane road to 4-lane road, so that there is not much congestion in that aspect. Then apart from that, even for automobiles, we have improved the safety standards. And recently in August 2021, we have made mandatory that the co-passenger, earlier only for the drivers, it was mandatory to have airbag, but now it is mandatory for all vehicle manufacturers that they must have the airbag for the another front co-passenger. So this also, I think, will be will go in a big way to save at least the lives in case of accidents for at least those who are sitting in the front row. Then Ministry has set up a scheme for model inspection and certification center in each state and union territory with central assistance for testing the fitness of vehicles through an automated system. So these were about the these measures on education. And now about in that our mentality of most of the road drivers in India, that we are taking, I mean, overspeeding is one of the important cause, and we are not taking much care. And every time when we see that the road is, I mean, there is less traffic, then we tend to overspeed. In fact, the study shows that more than 50% of the car drivers are overspeeding. So recent amendment in the Motor Vehicle Act 2019 provides for strict enforcement through use of technology, and further provides for strict penalties for ensuring compliance and enhancing deterrence for violation of traffic rule. In fact, electronic enforcement devices have been enforced under this, and these devices, some of them are speed camera, closed circuit television camera, speed guns, automatic number plate recognition, and weighing motion. And so these are some of the, I mean, equipments and technology which are used on our highways and the high speed corridors and important critical junctions and all the areas which are prone to accidents. And I think they are coming in a big help. These are very much deterrent for that will, and I think the results of last year have shown that after enforcement of this particular amendment in the Motor Vehicle Act, definitely the road accidents have come down. Now towards the driver training, because that is another area, because so many of our drivers, particularly of truck drivers and heavy vehicle drivers, they are not properly trained. They can't even read the signs. So there is a necessity that every state in the country, we should have driver training centers, and the ministry is giving the grants to various states to establish these driver training centers. And accreditation of the driving training center have also started. So then coming to the fourth E, that is the emergency care. Then Motor Vehicle Act 2019 also provides for a scheme for cashless treatment of victims of the accident during the golden hour. And I think today only in the newspaper you might have read that it has been made mandatory that every accident within 48 hours, the police officer have to report to the insurance agency and the hospitals that their accident and this has taken place and death is taking place. So they have to report so that immediately we can make the cashless payment to the victims of the accidents. So towards that, and this has been made compulsory by ministry. Now in all our toll plazas in India, throughout India on national highways, we have made provisions for ambulances so that immediately the victims of the accidents can be taken to the hospital and we can save the lives as much as possible through this. Then apart from that, as per the direction of Supreme Court, now every project having 5 kilometers and more is being road safety. And all existing roads are also, we are doing road safety audit so that to identify that there is no death only because of the engineering issues. And so far till the 31st December 2021, we have completed road safety audit of 54,600 kilometers. So roughly about 45% length of national highways have already been audited for road safety audit. And apart from that, putting crash barrier is another important aspect to because many of the vehicles they overturned because if there are no crash barriers on high embankments and particularly on bridges. So more than 4,322 kilometer length of national highways, we have already installed these crash barriers. And the speed calming measures we have taken on all the important junctions where there were any issues about road safety. And more than 27,336 junctions have so far been addressed in this regard. Then IRAP program, IRAP, which is rating the various highways on road safety issues. So NHI has also conducted road safety, this rating of IRAP on 1288 kilometers so that we can rate our various highways, and wherever they are rated poor, we can address those issues, why they are rated poor, and we can improve the safety on those highways. Then road users, in fact, we have put a number, helpline number 1033 on our highways So road users can report the incidents of any incident of road accidents and all through that helpline, and immediately our call centers can address that particular spot, and we can save the, if we can save the life of the accident casual injured people. Over 1,500 vehicles in total, ambulances, stowaway vehicles, and cranes and patrolling vehicles, highway surveillance vehicles have been deployed on our national highway just to see that how to prevent these casualties and from turning into the deaths. Then apart from that, we have to our field officers so that there are no delays whenever an accident spot is identified that yes, this is a problem area, immediately we address them. So in Ministry of Road Transport and Highways, we also have regional officers in state level. Similarly, NHAI also has regional officers. So up to 50 crore cost of projects which need improvement in the road designs, road geometrics, that power has been delegated to the regional officers, and they can sanction and they can get these works executed by without asking the head take care of the black spots. And apart from that, recently ministry has also set up a National Road Safety Board in 2021 September, and which is a focused agency now, which will deal all aspects of road safety, including the policies, and which include all the transport ministers and all. I think now we can have more focused attention, and at the highest level, at the, I mean, all the political level and the official levels through this particular National Safety Board. So these are the various measures which Ministry of Road Transport and Indian Road Congress and towards that traffic technology. Already ATMS, Advanced Traffic Management System, has been made mandatory on all our highways, which are 4-lane and more. And in fact, we are coming out with the new expressway manual. Just it is under finalization. There also we will, based international practices, we will use on towards traffic management on our highways. But there are really some area of concern, especially the casualties of two-wheelers. I think so far we have not been able to address that issue, and maximum casualties of two-wheelers. So I think there is a need to have we should two-wheelers traffic, motorized two-wheelers traffic particularly, which is the largest casualty in the road accidents. So we are now in IRC, we are trying to have a new document on how to have the policy document on how to segregate that particular traffic. This is a challenge, and to reduce the fatality, because when you see the international figures, 90% of the deaths are taking place in developing countries and only 10% in developed country. So that means there is a lot of scope to address this issue in all the developing country, including India. So I think we have all, and in fact, our minister has told in various forums that he doesn't want to wait even for 2030 to reduce to 50%. He has set a target that we should have zero accidents. We should try to have zero accidents in all our projects, and all our roads should be designed for zero accidents. And human also, I mean, we should try to have to reduce the human causes through this training of drivers and to the behavioral changes, how we can make and have more and more forgiving roads so that people can, I mean, even those who have made some mistake can again come back and to the normal stream of our highways. So I think these measures which has been taken by the Ministry of Road Transport and Highways, and these documents which have been prepared by IRC should come in a big way to reduce the fatalities which is taking place. And we should, I mean, do all of us should take the responsibility for reducing these accidents due to road accidents and fatalities. And with that, I think this particular conference, whatever we have heard, and this will be published. I think they will provide it on the website. So this can be used by all the policymakers, the research scholars in coming out with their findings, good findings, and even our IRC documents. I invite all of you, I mean, if you have any suggestions to improve our existing documents, we are ready for even updating our existing standards. We are ready for coming out with new standards where we can promote safety on our highways. Thank you, sir.
Thank you very much. Ladies and gentlemen, it's my privilege to propose a vote of thanks on this occasion. First of all, I extend my sincere gratitude to our Honorable Chief Guest, Sri Sanjay Kumar Nirmal, to take out time from his busy schedule to praise the occasion. Thank you very much, sir, for inspiring and encouraging us all with your word of wisdom. We are all inspired by your remarkable presence and highly lively words. I must thank all government bodies as NHAI, IRC, CRRI, ARAI, Caltron, TRG for rendering their active contribution and cordial cooperation in the conference. I would like to place on record my hearty thanks to the contribution of IRTE and various NGOs for providing us necessary guidelines in conducting this event. I must mention our profound sense of appreciation to police officers who are at the cutting level age of traffic management for sharing some of the best management practices which benefited one and all of this conference. I thank all the esteemed speakers for sharing their opinion, knowledge, and experience. I mention my deepest sense of appreciation to the wonderful scholars and educators of the National Conference, National Technical Institute, who have shared their original quality research work to give an age and impetus on this discussion. On behalf of all members of CPT, I would like to express my gratitude to all esteemed participants at this conference for their significant presence and keeping the session lively through interaction and contributing in making this conference a great success. I must thank Director CPT C. Pawan Srivastava, IPF, for giving us the directions and motivation to convene this event. Sir, your constant help and encouragement have helped us in best way. The paper presentation by the scholars, talks by eminent personas, and sharing of best practices, I'm sure all participants are benefited and enrich their knowledge by coming here. And I once again want to state that we are grateful to all the speakers here over the stage. We thank you for being with us throughout the conference. It has been a great pleasure. Last but not the least, I would also like to mention a big thanks to Team CAPT for rendering back-end support, who greatly contributed to the success of this conference. Thank you and Jai Hind to all of you.
Thank you, sir.
Thank you,
Jai
sir.
Hind,
Thank you,
sir.
Jai Hind, sir.
Thank you, sir.
Jai Hind.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you,
Ji.
Thank you, sir. Jai Hind, sir.
Thank you, sir. Jai Hind.
Sir.
Jai sir.
Jai Hind, sir.
इनके जहाँ डिवाइडर से बना रहे हैं वो अगर कट होते हैं तो उनके
जय हिंद, सर।
जहाँ पे जो ऐसे काट रहे हैं लोग
छूट गया
जय हिंद सर।